Now let's look at some special type of relations. They are called as functions. A function is also a relation. So we know what a relation is, isn't it? A relation is nothing but subset of the Cartesian product. If we have two sets A and B, if I apply the Cartesian product, then we are going to get set of all ordered pairs. Now if you take a subset of the set of all ordered pairs, then that is called a relation. Then some of the relations will qualify to become a function if they have some particular characteristics, right, or properties. Let's see what that property is. Simple. See this, a relation, it is important. See this, a relation F. So the definition itself is saying that a function is a relation with a special property. That's it. A relation F from a set capital A to a set capital B is called a function if to each element small a belongs to capital A, we can assign an unique element of B. Right? So what is the meaning of it is, watch it. Now if we have a set like this, capital A, which is having, let's say, 4 elements A, B, C, D, and you have one set capital B which is having, let's say, 5 elements 1, 2, 3, 4, 5. Right? Now what is a function is, for every element in capital A you should exactly assign one element to capital B. That will be a function, right? So this will be a function, right? So how do you look at it? It is nothing but a relation. So if you want to look at it as a relation which is nothing but a set of ordered pairs, you can look at it this way. A is mapped to 1, B is mapped to 2, C is mapped to 3, and D is mapped to 4. Simple. Got it? Okay. Now if you try to, what will not qualify as a function is if you don't have this, right? If D is not being assigned to any of this, which means if you don't have this ordered pair, then this relation cannot be a function, because every element in A should get exactly one element in B, right? Or what will not be a function is if you have, let us say you have this also, which means you have D comma 4 as well in this. Along with this, if you have like this, which means if A is related to more than one element, if you have A comma 2 as well, right, then also it will fail to be a function. So if a relation has to become a function, it has to satisfy exactly one property. What is it? Every element in A, if the relation is from A to B, okay, every element in A should get exactly one element in B. That is also called as image, right? So image of A in B, right? So in this case, image of A in B is 1, image of B is 2, image of C is 3, image of D is 4, right? So if you have that, that is called as the function, and you need not have a pre-image for every element in B, which means there is no requirement that every element in B has to be mapped to D. Now you tell me whether these are functions or not. Okay, let us say I have A, B, C, this is A and this is B, and I have 1, 2, 3. A is mapped to 1, B is mapped to 1, C is mapped to 1. Is this a function or not? It is a function, because every element is mapped to exactly one element there, but we need not care whether they are all mapped to the same element or not. So it is definitely a function. Now tell me whether this is a function or not. A, B, C, 1, 2, 3. Is this a function? It is not a function, right? Why? Because A is having more than one image, right? Tell me whether this is a function or not. A, B, C, 1, 2, 3. That's it. Is that a function? It is not a function. The reason is the element C of A is not having any image. Every element in A should have an image, but since it is not having an image, it is not a function. Got it? Tell me whether this is a function or not. A, B, C, 1, 2, 3. This is a function because every element is having an image there, right? So that is how we define the function. Got it? See, a relation. Why? Because it is containing ordered pairs. If you see this, it is exactly looking like a relation. A relation from set A to set B is called a function if to to each element A belongs to A, we can assign an unique element of B, which means for every element here we are able to assign an element from B. It is denoted as f is a function from A to B. You have to read it like this: f is a function from A to B, and this particular set A is called as domain and this set B is called as codomain. In this case, A is domain and B is codomain. A is domain and B is codomain, right? Now we are defining even range. So what is range is, if you see any of these mappings, it is not always necessary that we map every element in B is going to get an element in A, but every element in A is going to get an element in B, but it is not necessary that every element in B is going to participate in the function, right? So if that is the case, see this, these two elements are not present in the function, therefore whatever elements are participating in the function, they are called as range. So in this case, range equal to 1, right? And in this case, let's say D is mapped to 4. In this case, range is equal to 1, 2, 3, 4. Range is nothing but set of all elements of B which are participating in the function, right? So in this case, it is not a function. It is not a function. We don't talk about it. In this case, the range equal to 1, 2, 3 is equal to codomain itself. So if you observe it, if you look at the codomain set, all the elements might not be participating in the function. Therefore, what we can say is codomain is always a subset of range. Range is always a subset of codomain, which means in this case, see this 1, 2, 3, 4 is a subset of 1, 2, 3, 4, 5. Therefore, there is no requirement that every element of B should participate in the function, and so when you write out the range, you will not get all the elements of the codomain. That is why range is always a subset of codomain. Remember that point, okay? And sometimes what happens is, we might define a function from the set to itself, just exactly how we did with the relations. From we have defined the relation on a set, not on two sets. Similarly, we can define functions also on one set only. In that case, it is called as a function on A itself, right? Let's see some questions on this. You will understand even more. Now let's try to count the number of functions possible from a set A to set B. Okay, so how many functions can be possible from a set A to set B? If you have to answer this question, you should first know how many elements are there in set A and how many elements are there in set B. Assume that, just an assumption, the number of elements present in set A is M and the number of elements present in set B is N. Now how many will be there? So let's boil down to a small number and just see it with some practical numbers here. Let's say A is here and B is having two elements, right? Now how many functions can be possible from A to B? If you look at the element 1 in A, it has got two choices. Either you can map it to A or you can map it to B. Therefore, this element is going to have two choices. And what about this element? Again, two choices. It is not like A has taken up one element and B, one has taken up one element and 2 has to use the other. It is not like that. One is having two choices. It could either use A or B. And similarly, 2 is also having two choices. It could either use A or B. Therefore, again, two choices here. And what about 3? 3 is also having two choices. It could either use A or it could either use B, right? Therefore, 2 into 2 into 2, which is nothing but 8 functions are possible from a set A to B, in case if A is having 3 and B is having 2 elements. Now let's try to generalize it. So let's see what happens if A is having M elements and B is having N elements. Okay, A is having M, 1, 2, 3, so on, M elements and B is having N elements. Okay, then what happens here? In this case, what happens is, now each element in A can be mapped to any one of N elements in B. Therefore, this element will get N choices. And similarly, the second element also will get N choices. The third element will also get N choices. Therefore, we get N into N into N into so on m times these many functions are possible from a set A to set B, where A is having m elements and B is having n elements. Now it is nothing but n power m. So this is the total number of functions possible from a set containing m elements to a set containing n elements. Got it? This is how you should analyze it. Okay. Now we have already seen that set is a function is a relation, isn't it? So can we say that is every relation a function? Clearly no. Why? Because we have already seen many exceptions. If a relation is not having the element starting with 3, then it means that the element 3 is left out and it cannot be a function. Therefore every every relation cannot be a function. Okay, so what I mean to say is this. See this? Now I want to find out the total number of relations from A to B which are not functions. So exactly what I am looking at is, if you have, this is the set of all, let us say set of all relations, then where will functions be? Functions are nothing but relations itself, isn't it? Functions will be here. This is set of all functions, right? Now I want to find out the relations which are not functions, which means all this part. This is what I wanted to know. I want to find out this line part. That is what I wanted to know. In order to answer this, you should know how many total number of relations are possible, and then how many total number of functions are possible. Then from the total number of relations, if you subtract total number of functions, you are going to get the total number of relations which are not functions. Got it? So now check this. What I wanted is the total number of relations from A to B. So we already have seen that the total number of relations, how do we get the relations? By cross product, right? So once we take the cross product of A and B, here A and B, the number of ordered pairs in this Cartesian product is going to be mn, isn't it? And we know that the number of relations are nothing but the number of subsets from that Cartesian product. Therefore the number of relations is going to be 2 power mn, right? And we know that the number of functions possible from and this A to B is n power m. Therefore the total number of relations which are not going to be functions is 2 power mn minus n power m. This is the total number of relations that are not going to be a function. Got it? Okay, so this is all about we are talking about two different sets. What if we are talking about the same set? Which means if we are talking about the relations which are defined on the same set, or the functions which are defined on the same set. In that case, both these two sets will be A itself, and the Cartesian and the number of elements will be same. Let us assume that the number of elements in the set A is n. Okay, and now we are talking about functions or relations from A to A itself. Then how many functions will be possible? N power n. How many relations will be possible? 2 power n square. Then how many relations are possible which are not functions? 2 power n square minus n power n. Okay, this is how we can count the number of functions and number of relations and number of relations which are not functions. Okay. See this, if there are exactly 81 functions from set A to set B, then which of the following statements is not true? We have already seen that the number of functions possible from set A to set B is going to be n power m, where A is having m elements and B is having n elements, isn't it? So let's see if it is all the options are right or wrong. Now if A is containing 4 elements and B is containing 3 elements, then how many functions will be possible? The number of functions will be 3 power 4, which is nothing but 81. Therefore option A is right. And what about this? It is 9 power 2, which is again 81. Option B is also right. What about this? It is 81 power 1, which is nothing but 81. So it is matching. Now what about this? It is 9 power 9. 9 power 9 is not equal to 81. Therefore we can say that this is false. Got it? So this cannot be the right option for the given condition. Now look at the next one. Which of the following is a function if the domain is set of all real numbers? Which means they are talking about a function which is defined on set of all real numbers. Okay. So range and domain and codomain you can take here as both as real numbers, because they have mentioned only one set. So it means that these are the functions which are defined on one set. Okay. Which of the following is a function? That is what they are asking. F of x equal to 1 by x. So what does it mean? If for every real number x, if you can find out the value of if we can give it exactly one value for this, then you are going to say that it is a function. See this, for example, if for the real number 1, what value do you want to associate according to this function? 1 by 1, which is nothing but 1, which means 1 is mapped to exactly one value, 1. And similarly for 2, what is the value that you want to assign? For 2, value assigned is 1 by 2, which is 0.5, which means 2 comma 0.5 will be present in this function. Likewise, for every real number, if we can assign one number according to this function, then you can say that according to this given expression, then you can say that it is a function, right? So let's see this. Now for every element you can find out what 1 by x is, except one number. What is it? 0. Since for 0 you have to write it as 1 by 0, which means you have to assign a number called 1 by 0, but there is no number in the real number system called as 1 by 0, which is infinity. So we can say that it is not a function. Okay. What about this one? For all real numbers you should be able to assign some real number here, right? But what happens here is, if you say root x, for positive numbers you can find out the root of x. Even for 0 also you can find out root of x equal to 0. But then for negative numbers, finding out the square root is not possible in the set of all real numbers. Here the functions are defined on the real numbers, right? Therefore we can say that it is not a function, because you are going to get an imaginary number for negative numbers, right? So it is also not a function. Now what about this one? Now if you observe it, for every number there are two numbers mapped to it, plus or minus, isn't it? But then a function should have mapping for every one element in the domain. You should only get one element in the codomain. You should not get two elements. But here if you observe it, for example, if you put x equal to 0, you are going to get plus or minus root 1, which means you get plus 1 as well as minus 1. Therefore for one value we are getting more than one values, so it cannot be a function. Now what about this one? So x equal to mod x, which means for every number we are taking the positive version of that number. So for 0 there will be 0, for 1 there will be 1, so for 0 there will be 0, for 1 there will be 1, but for minus 1 there will be 1. So for every number you will get exactly one number as output if you apply the mod function, which means every number in the domain is mapped exactly to one number in the codomain. But more than one element can be mapped to the same number, but that is not a problem at all. So this is definitely a function. Got it? See, why is the first one failed? If you observe the first one, what happened is, if you see the set of all real numbers, for all values you are able to assign the values, but then for 0 you are not able to assign any number. That is why it failed. For the second one, what is the problem? For all positive numbers you are able to assign the values, including for 0 also, but then for negative numbers you cannot give any real number because it is an imaginary number, but it is defined on set of all real numbers. And for the third one, what is the problem? See, for a single number you are getting two numbers as output, which means for every number is mapped to two numbers like this. It cannot be a function. And for the last one, it is not a problem. The reason is, for all positive numbers you will map to positive numbers, corresponding positive numbers, and for all negative numbers also you will map to the corresponding positive numbers. But anyway, if you see the elements in this, there will be only one mapping. But if you see the elements in the right hand side, two elements might be mapped to one element there, but that is not a problem. Okay. So anyway, what we can say is D is a function. Now see the next one. Consider the following relations from set of all bit strings to set of all integers. Okay. So they are talking about set of all strings to set of all integers. Then f1 is which means the first function is the number of ones in the bit string s. So what they mean to say is, if you have set of all these strings like this, let us say 0 0 0, this is a string, then what is it mapped to? It is mapped to 0 according to f1. So f1 counts the number of ones in the bit string s, which means since there are no ones in this string, we are going to give it 0. And what about 0 0 1? Since there is 1 1, we are going to assign value 1. What about 0 1 0? We are going to assign value 1. What about 1 0 0? We are going to assign value 1. So that is the meaning of it. According to f1, we are counting the number of ones, and every string is going to get an integer which is equal to the number of ones in that string. Got it? This is going to get 0. Now how many elements will be there in the number of strings possible? Infinite. Okay, but then every element will always get one number here, right? That is equal to the number of ones. So if you are counting the number of ones in a string, it cannot be two numbers, isn't it? Or it cannot be 0. I mean, it cannot be undecidable, because every string is of finite length. Getting this? You have a finite length string, you try to count the number of ones, you will come up with a single number. Therefore every string will be assigned a single number and exactly one number, right? So what is that number? That is equal to the number of ones. Therefore f1 is a function. And what about f2? f2 is saying that it is going to give the position of 0 bit in the string. Yes. So what it means is, if you have a string 0 1 0 1, then 0 is present in position number 1 and 0 is present in position number 3. Therefore position number 3, right? So it is going to have 1 comma 3, which means this particular one string is actually assigned to more than one numbers. Therefore it cannot be a function. So what is the definition of a function? Every string should be assigned to only one number, but in this case this string is assigned to more than one number. Therefore what is the question here? Which of the above relations are functions? So f1 is a function, but f2 is not a function. That is the meaning of it. Okay, see this? Which of the following functions, which of the following relations on set A is a function, and set A is given as a set containing 3 elements A, B, C, and then some relations are given. Now which of them is a function? Now let's see this one. First one, we have elements A, B, C. For A, image is B, for B, image is C, again for A, image is C. Now if you observe this, for the same element A, we are having more than one images, which means we have two images here. Therefore this cannot be definitely a function, because for every element we are supposed to have exactly one image, but here we are having two images, right? And if you observe the next one, for A, image is A, for B, image is C, but for C there is no image, which means for all the elements we are not having images. Therefore it is not a function. Now if you observe this one, for A there is an image, for B there is an image, for C there is an image, and exactly one image is there, and so C is a function. Now let's look at the next one. State the following, if the following are true or false. So how to find out whether the following are true or false? See this? There exists an equivalence relation which is a function. So is there any equivalence relation that you know which is exactly a function? Just think about it. Let us say capital A equal to 1 2 3. What equivalence relation can you think of which is also going to be a function? If it has to be equivalence relation, it has to be reflexive, symmetric, and transitive. That we know, right? Now if it has to be reflexive, definitely it should contain 1 1 2 2 and 3 3. This is the smallest equivalence relation, isn't it? Now if you observe this equivalence relation, it is also a function, isn't it? Why? Because 1 is having exactly one image, 2 is having exactly one image, and 3 is having exactly one image. Every element in A is having an image and exactly one image. Therefore we can say that it is a function, right? So this is an example of equivalence relation which is a function. Now if you try to add any more elements into this, then it will not become a function, because if you try to add any other element, you will try to give more than one image for an element. Therefore this is the only relation or only equivalence relation which is a function. Yes, there exists an equivalence relation which is a function. There exists at least one, right? So S1 is true. Now look at the second one. The functions f of x equal to x and g of x equal to x square are identical. So they are saying that f of x equal to x and g of x equal to root of x square is identical. Let's see this. Now if you look at f of x, if you take the element x equal to 1, then it is going to map 1 to 1 itself. If you take element minus 1, it is going to map minus 1 to minus 1 itself, because f of x equal to x. But if you look at this g of x, it is going to map 1 to 1, fine, as well as minus 1 will also be mapped to 1. The reason is, if you take minus 1 square here, this one, you are going to get 1, and root of 1 is 1 itself, square root of 1 is 1 itself. So in g of x, all the negative numbers will be mapped to positive numbers, but in f of x, all the negative numbers will be mapped to negative numbers and positive numbers will be mapped to positive numbers. Therefore definitely they are not identical, right? So they are not identical, it is false. Now look at the next one. F of x equal to log x square base c and g of x equal to 2 log x base c are identical. They are saying that these two are identical, but they are not identical at all. The reason is, if you observe this one, here x can be anything. X can be anything other than 0. Except 0, x can take any value, either positive values or negative values, both are allowed. You can give x equal to 1 as well as x equal to minus 1, but here you cannot give x equal to minus 1, which means it is defined for all the values other than 0, but it is defined for only positive numbers. Therefore these two are not identical, it is false. Now look at this one. The domain of the function f of x equal to 1 by square root of this is mod x minus x is minus infinity to 0. So they are saying that this function will accept only negative numbers. This particular function will accept only negative numbers. Let's analyze that. What happens? Okay, so in order to analyze this, you should understand what is mod x, and we know that this mod x is actually x when x is greater than 0, and it is minus x when x is less than 0, and of course it is 0 when x equal to 0, right? Now what happens is, when x is greater than 0, it is going to be x. So if you try to define this function for x greater than 0, then what happens is 1 by square root of, in place of mod x I am placing x minus x, which is nothing but 1 by 0. Therefore for positive values x is not defined, but for negative values what happens is, when x is less than 0, it is going to be minus x, because mod x equal to minus x when x is less than 0. Then it is going to be 1 by square root of minus 2x, right? But since x is less than 0, this entire minus 2x is going to be positive, and so it is defined, right? But anyway x is not defined for 0, so x is not defined for 0 or positive numbers, but x is defined for all the negative numbers, and so it is true. The domain of this one is f of x equal to this is true. Okay, fine. There is a special type of function called one-to-one function. It is also called as injection. So if every element is going to have let's say two elements should not have the same image, which means if you are going to have some elements from A mapped to the elements of B, then you should see that no two elements of A should go to the same element in B. Okay, what I mean to say is this. Now let us say you have 3 elements here and you have 3 elements here. Okay, now when you are mapping one element from here to here, you should not map other element also to the same element. That is the meaning of one-to-one function. If no two elements are mapped to the same element, right, then it is called as one-to-one function. A one-to-one function is a function in which no two elements will have the same image, right? So you can just think of various functions. Now if one element has taken up an element here, then other element should not take that element, therefore it should take a different element, and the other element should not take any of these two elements, therefore it should take a different element. So if you are talking about functions from set A to set B, now if you have three elements here, then how many elements should be there for one-to-one functions to be possible? Definitely at least 3, isn't it? If the number of elements present here are less than 3, we will not be able to find, we will not be able to make a one-to-one function. Therefore, the minimum number of elements that should be present in B should be at least as many as the number of elements present in A. So one condition is for sure: the number of elements in B should be greater than or equal to number of elements in A, then only one-to-one function may be possible. Otherwise, one-to-one function is not possible. Got it? And the second one is, next one is, how many one-to-one functions will be there? See this? Let us assume that we have 1, 2, 3 elements in this, 1, 2, 3, 4 elements in this. Now, if you observe this, the number of ways we can map the first element to make it a one-to-one function is 4. So you can map this one to any of these 4 elements. But the number of elements you can map this one is 3 only. The reason is one of the element is already taken up for mapping for the first element, and the number of elements that we can map here is 2. Got it? Therefore, in general, if A is having n elements and B is having m elements, if A is having n elements and B is having m elements, right, then how does it work is, for the first element the number of choices it will have is m, right, and for the second element the number of choices it will have is m minus 1. For the third element the number of choices it will have is m minus 2, so on. For the last element the number of choices it will have is m minus n minus 1, right, or we can say m minus n plus 1. Therefore, this is the total number of one-to-one functions possible from a set A to set B. Now if you want to simplify it and write it in an expression, you can write it this way: mp n. You remember this notation from permutations and combinations, right? mp(n), right? In case if both m and n are equal, then the number of one-to-one functions possible is mp(n). Got it? So how to understand this one-to-one functions? No two elements should have the same image in B. It is possible only when B is having more elements than A, at least as many elements as A, right? So if it is already given that a function is one-to-one, then it is very clear that if images of two elements are same, then it definitely means that these two elements are same. So if it is a one-to-one function and if you see that images of two elements are same, then it should definitely follow that these two elements are same. Remember that point, right? Otherwise it cannot be one-to-one function. Okay, fine. See this question: if there are exactly 120 one-to-one functions possible from A to B, then which of the following is not true? So they are saying that the total number of one-to-one functions possible is 120. So what is total number of one-to-one functions possible? mp(n), isn't it? Now let's see this. So first one is, the number of elements in A is 5 and B is 5. With 5 and 5, will 120 functions be possible? Yes. So why? If you write this mp(n) formula, it is going to be 5p5, and 5p5 is 120. You can check it. Then what about this one, 5p4? 5p4 is also equal to 120. You can check it. And what about this, what is this, 6 and 3, right? 6p4, 6p3. 6p3 will also be equal to 120. And what about this one, 4p5? Oh, it is not possible at all. So no one-to-one functions will be possible with this configuration, isn't it? The reason is, you have 5 elements to map, but then you have only 4 elements to take as images. Therefore here definitely 2 elements are going to should at least map to one element here. At least 2 elements have to map to one element here. Therefore no one-to-one functions are possible here, right? It is false. Okay. Now on to functions. A function f from A to B is said to be onto if every element of B is mapped by at least one element of A. So better I'll take some picture and I'll explain you instead of going by the definition. See this? Let us assume that there is a function f from A to B. This is set A and this is set B. And let us say we have 4 elements here and we have 3 elements here, right? Now if every element in B is associated with at least one element here, then we can say that it is onto function. For example, see this? This is onto function because every element, if you see in B, is associated to at least one element. Now see this, a function f from A to B is said to be onto if each element of B is mapped by at least one element of A, that is range of f equal to B. In this case, what is the range of this function f? The range of this function f is the entire set B, because all the elements of B are actually participating in the relation, right? So I'll just give you one more example. Let's say we have 1 2 3 4 and 1 2 3 4. Now see this. Now if this element, if it didn't map to this one, if it goes and maps here, then it is not onto, because we have left out one element without mapping to the element in A. So every element in B has to be mapped to an element in A. If it doesn't happen, then we can say that it is not onto function, right? Let us say the mapping is like this, then we can say that it is onto function. Now can you say that, so what should be the condition for a function to be onto? Can you just imagine this one? Let us say A is here, B, A is having 3 elements and B is having 1 2 3 4 elements. Just see what happens now. Even though you try to give one element to every element in B, since there are less number of elements in A, it is not possible. Therefore, it is not onto function and it can never be onto function. The reason is this simple. See, the number of elements in A are less than number of elements in B, then there is no way every element in B is going to get an element in A. So the condition for a function to be onto is like this. Number of elements in B should be less than or equal to number of elements in A. So you have, it is not the sufficient condition, it is a necessary condition, which means even if this is satisfied, it does not mean that a function will be onto. But if it doesn't satisfy, then the function is definitely not onto. Are you getting it? If you see that the number of elements in B are larger than the number of elements in A, then you can directly say that it is not onto. But if you see that the number of elements in B is less than number of elements in A, you cannot directly declare that it is onto. You have to see the mapping and then answer it. Are you getting this? See, for example, if I have some elements like this, A, B, 1 2 3 1 2. Here the number of elements in A in B is less than or equal to number of elements in A, but you cannot directly declare that this is onto function. You have to see the mapping and then say it. For example, if all the elements are mapped to the first one, right, even though the number of elements in B are less than number of elements in A, it is not onto, which means that is just a necessary condition and not the sufficient condition. What is the sufficient condition? Every element in B should be associated to one element in A. If that has to happen, first that condition should be satisfied and next the other condition. Got it? So what can you say about one-to-one and onto functions here? Is this one-to-one function? It is not one-to-one function because many elements are related to one element, right? So when two elements have the same image, then it is not 1-1, which means this is the example of a function which is onto but not one-to-one, right? And what about this one? This is the example of a function which is one-to-one and onto. Got it? Now what about this function? This is example of a function which is not one-to-one because many elements are having the same image, and not onto as well. Got it? Now just tell me what happens when you have equal number of elements in A to B. A and B if they have equal number of elements, 1 2 3 here, 1 2 3 here, right? And which means I'm talking about this number of elements in A is equal to number of elements in B, right? If this is the case, and if it is already known that there is a function f which is 1 to 1, which means every element here can have at most one image there. If it is already known as 1 to 1, then what can you say it? So if the number of elements are same and if the function is known to be 1 1, then it is also onto, then it will become onto. Why? What could be the reason? If it is definitely going to be 1 1, which means every element here will be mapped to a distinct element here, then how many distinct elements we have? Exactly as many as the number of elements in A. Therefore every element in B has to be mapped, then only we are going to get a 1 1 function, right? Now let us say the same one, the number of elements in A is equal to number of elements in B. Okay, this is the case. And now if it is known that it is a onto function, onto function means every element here is going to get one element here, right? Then what can you say about it? So if it is this condition, number of elements in A equal number of elements in B, and is known that the function is onto, then it is definitely going to be 1 1. What could be the reason? Since the function is going to be onto, every element here is going to be mapped to at least one element here. Now we know that if that has to happen, we should exactly have at least these many number of elements in here, and we have them, right? And every element here cannot have more than one element there. That is why it is going to be 1 1. Got it? And one important question: if these two are equal, then how many onto functions are possible? Of course it is n factorial, right? Why? Because onto functions also can be made in the same way. You take each element here, then how many choices will it have to be mapped here? N. You take each next element will have n minus 1, next element will have n minus 2, because every element has to get one element, isn't it? So you cannot make two elements go to the same element, then it will not become a function. So n factorial. If cardinality of both the sets are equal, then the number of onto functions is going to be n factorial, and the number of 1 1 functions is also going to be n factorial, right? Okay, in fact, if the cardinality of both the elements are same, and if you try to make either it as onto or 1 1, then the other property will be satisfied. But it is not always the case if the number of elements are not equal. Okay, so the cardinality or the number of onto functions possible from a set A to set B when the number of elements are different, which means when the number of elements are not same. When number of elements are different is going to be bit different question. Okay, what I'll do is I'll give you the formula for that, and then we shall see the questions on it. Okay, fine. See this: if number of elements in A equal to m and number of elements in B equal to n, then the number of onto functions from A to B is given by this formula. So you can prove this formula by mathematical induction. Anyway, proof is not required, and even there are no questions on this formula, but then still it is just for the sake of completion we are going to include it. You need not by heart it, just try to remember it somehow. If you can't remember it, leave it. There will be no questions on it. Okay, so but then the formula is this. So one more thing you should observe here is they are giving that number of elements in A equal to m and the number of elements in B equal to n, and always m is greater than n. Okay, which means the number of elements in set A should be greater than or equal to n. So one thing is for sure, if number of elements m is less than n, there will be no onto functions possible whatsoever. We have just seen that, isn't it? In case, see what I mean to say is, in case if m is less than n, which means if the number of elements in set A are less than number of elements in set B, how can you give one element for each of the element in B? It is not possible, right? So there will be no one-to-one functions possible. That is why this case is eliminated, and the other case is m equal to n. Now we have just seen that when m equal to n, it is either m factorial or n factorial. Now the other case remaining is m is greater than n. So when m is greater than n, then the number of onto functions possible can be derived from this formula. Okay, so look at the formula: n power n minus nc1 into n minus 1 power m plus nc2 into n minus 2 power n, so on. So I'll just give you an intuition behind it. This is the total number of functions possible. From the total number of functions possible, we are going to subtract something, right? So what is it? The total number of functions possible in which one element from the set B is never associated to any element. You can choose that one element here, and then you can remove it, right? And then we have to add some other factors. So we add here and then subtract here, add here, subtract here. By mathematical induction, you can prove that it is right. Okay. So anyway, now let's see some examples on this. If number of elements in A equal to 6 and number of elements in B equal to 3, which means m equal to 6 and n equal to 3, if you substitute in this formula, see this, 3 power 6 n power m minus nc1, nc1 is nothing but 3c2 into n minus 1 power m, which means 2 power 6 plus nc2 into n minus 2 power 6. So if you expand it, we are going to get this one, right? That is one example. And look at the next example here. If number of elements in A equal to n and number of elements in B equal to 2, then the number of onto functions possible. So according to this formula, you are going to get this 2 power n minus 2c1 into 1 power n. Even if you directly do it also, you can see this. So how do you think that we got it? How do you think that we got it? Simple. See this, the total number of functions possible are 2 power n. From these total number of functions, 2 functions will not be onto functions. See, they are saying that we have n elements here, but then we have only 2 elements here, right? Now the total number of functions possible is going to be 2 power n. We have already seen that. Now from this, only 2 functions are not going to be onto functions. Can you guess what they are? One function will be, all the elements will be mapping to the first element. This is one function which is not going to be onto. And what about the other one? The other one is all the elements will be mapped to the second one, like this, right? So these are the 2 functions which are not onto. Therefore from the total number of functions, which is 2 power n, we have to subtract 2. Okay. Let's see this. In how many ways we can assign 5 employees to 4 projects in such a way that every employee is assigned to only one project and every project is assigned to at least one employee? So it is a kind of onto function related question. So if you are having a set of employees and a set of projects, then you have to map them in such a way that in this side every employee should get only one project, which means every element here should be mapped to at most one element there. So that makes it a function. And the second one is, they are saying that so at least every project should be mapped to at least one element, which means they are saying that every project should be mapped to at least one somehow. So now the first condition, so what is the first condition? Every employee is assigned to only one project. That is going to make this mapping a function. And the second condition, what is second condition? Every project is assigned to at least one employee, which means every element here should get at least one element here. Now the second condition is going to make it onto. Therefore in other way, they are asking how many onto functions are possible from a set containing 5 elements to a set containing 4 elements. That is what they are asking, in other words, right? So it is very simple to answer. You can apply the formula of onto functions. Once you apply, we get this expression, right? And from this we can directly get it. So there might be questions which might not directly contain the word functions or onto functions, but from the verbal description you should be able to get what it is. Okay, fine. Now see this example. Consider the following functions on set of all integers, which means both sets A and B are going to, if you consider that f is a function from A to B, then both sets A and B are set of all integers. Okay, and f of x equal to x square is a function, g of x equal to x cube is a function, and h of x equal to x by 2 ceil is a function. Then which of the following is true? So they are asking whether each one is 1 1 or onto, like that. So first one is f is 1 1. So what is f? F is f of x equal to x square. Now it will take each element and it will map to the square of it. Now when will it be 1 1? It will be 1 1 if no two elements map to the same element, isn't it? But then square doesn't act like that on set of all integers, positive and negative numbers. For example, if I give f of 1, then it is going to be 1, and f of minus 1 is also going to be minus 1, right? So by looking at this, you can clearly find out that it is clear that, okay, sorry, f of 1 minus 1 is 1. So we can say that two elements 1 and minus 1 are actually mapped to the same element, so it cannot be 1 1. This single example is enough. It is called counter example, right? One example is enough to show that it is not 1 1. Yes, you can get even more examples like f of 2 equal to 4 and f of minus 2 equal to 4, right? So that also shows that it is not a 1 1 function, right? So anyway, it is not 1 to 1 function. Now the next one is f is onto function. So what does onto function mean? Every element in f should have some element in, okay, like this. Every element here should have some element here. But the problem is, how can square of a number be a negative number? See, since it is a set of all integers, which means here we have 0, 1, 2, 3 and then minus 1, minus 2, minus 3. Now we'll take an element and we map to the square of it. How can square of some number be a negative number? Therefore, all these elements will never have any image here, right? Any mapping here. So we can say that it is not onto. Or even you can find out some other examples as well. If you see the number plus 2, then what happens is, whatever integer you square here, you will never get a 2, which means 2 will never have any pre-image here. Therefore, all the elements here may not get some images here, and these are some of the examples. Therefore, it is not onto. Now the next one is saying that g is 1 1. So what is g? G is x cube minus y cube. Sorry, g is just g of x equal to x cube. So how can cube of a number be 1 1? Which means if I take a number and if I find the cube of it, it is going to give us some number. Now if you take some other number and if you find the cube of it, will it give the same number, right? So if it doesn't give the same number, we can say that it is 1 1. So what I am trying to say is like this: if you take a number here and if you try to find the cube of it, you are going to get some number here, right? And if you take some other number and if you try to find the cube of it, you should get the same number. Then only it is not going to be 1 1, otherwise it is going to be 1 1. So other way of finding it is, let us say there are two numbers x and y in such a way that f of x equal to f of y, which means f of x equal to f of y. Let us say we have two numbers x and y in such a way that both are having the same image there. Then if we can show that these two are actually same, then we can say that it is 1 1. If we can show that these two are actually different, we can say that it is not 1 1, right? So for that particular proof, you can prove it like this: x cube equal to y cube, and then you can show that x cube minus y cube equal to 0, and from this equation you can prove that x is equal to y, right? If you solve this, you can prove that x equal to y, which means if f of x happens to be y of x, then x actually happened to be y. In earlier case, if you try to talk about x square, then if you have f of x equal to f of y in the earlier question where we are talking about f of x equal to x square, then if you have x square equal to y square, then you will get x square minus y square equal to 0. Then in this case you will get x minus y into x plus y equal to 0, which means you will get either x equal to y or x equal to minus y, right? Therefore there is a chance that even though x is not equal to y, if x equal to minus y, then we are going to get f of x equal to f of y, which means it is not always necessary that if f of x equal to f of y, then x equal to y, which means even though the numbers are different, they can have the same image. That is why it is not 1 1. But in this case it is not possible. In this case, if the images are same, which means if x cube equal to y cube, then definitely the numbers must be same, which means x must be equal to 5. Therefore it is true. G is 1 1 is true. What about G is onto? G is onto may not be true, because for the same reasons. If you have to have a 2, if you know the number 2, if should have a pre-image here, then definitely the cube root of 2 should be present here, isn't it? Which should be an integer, but cube root of 2 is not an integer. We are talking about set of all integers. Therefore there will be no pre-image for some of the elements, and so we can say that it is not onto. And H is 1 1, right? They are saying that this one is 1 1. So if you have to show that H is 1 1, you can use the same method, or you can use the counter example method as well. For example, you can just test it like this. What is H of 1? H of 1 is 1 by 2 ceil, which is nothing but 0.5 ceil, which is nothing but 1, isn't it? Okay, you know what the ceil function is, right? It is the greatest integer, which is it is the smallest integer which is greater than this number. The smallest integer which is greater than this number is 1. And what about H of 2? H of 2 is 2 by 2 ceil, which is again 1. Now for 2 elements we got the same image, therefore we can say that it is not actually 1 1. So H is not 1 1. Now the next one is saying that H is onto. Yeah. So for every element, definitely there will be some element here, right? Somehow, isn't it? So if you want to get it, assign an element for 3, yes, there will be some possibility. So how is it possible? You can maybe take 4 by 2, right? Or 6 by 2. So there will be element 6 which is mapping to 3. So there will always be some element which can be mapped to an integer here, right? So it is onto. So it is just by intuition, nothing else. Okay. So that is how you can find out whether a function is 1 1 or onto by either using the proof or by intuition or by finding some counter examples. Okay. Now that we have seen what is 1 to 1 and what is onto function, a combination of these two is called as bisection. A function is said to be a bisective function if it is both 1 to 1 and onto. See this? A function f from a to b is called a bisection if f is 1 1 as well as onto. So what are the conditions? What are the necessary conditions for a function to be bisection is like this. I'm talking about necessary condition, not sufficient condition. Now first of all it has to become 1 1, right? So for 1 1, if you have to have a to b, a function from a to b in such a way that it is 1 1, it is clear that every element here should have a distinct element here, which means whatever number of elements I have here, there should be more than those elements, which means the cardinality of a should be less than or equal to cardinality of b. Then only every element here will get a different element here. Otherwise what happens is there will be insufficient number of elements in b, and so we might have to map more than one element to the same element, right? And what about onto? A function f from a to b will be onto only when the every element here gets at least one element here, and we know that an element in A can never take more than one element, right? Therefore if every element in B has to get a pre-image in A, then definitely the number of elements in A should be as many as number of elements in B. So which means the number of elements in A should be greater than or equal to number of elements in B. Then only there will be a chance that every element in B will get a distinct element in A, right? Now combining these two, if you want the function to be both 1 1 and onto, if you combine these two conditions, then it will result in this, right? So both when these two conditions will meet only when number of elements in A is equal to number of elements in B. Therefore that is the necessary condition for the bisection, right? So if you see any two sets which are not having equal number of elements, and if they ask you if there is any bisection possible, it is not possible. Okay, in case if this is satisfied, then we can know how many let us say we have 3 here and 3 here. Now how many ways can we map this one to any of these 3 ways? And once this mapping is done, since the mapping has to be 1 to 1, it cannot use the same element, so we have to use the other element, which means for the first item we have 3 chances, for the second one we have 2 choices, for the next item we have 1 choice. Similarly, if you have n items, n elements, for the first item we have n choices, for the second item we have n minus 1 choices, for the third item we have n minus 2 choices, so on 1, so which means n factorial, right? So if you have number of elements in A is equal to number of elements in B is equal to n, then the number of bisections possible from A to B is going to be n factorial. Okay, fine. So what we can take some examples and see whether the functions can be bisection or not. There are not many problems on this, but we shall try to see some examples. Okay, this example, let capital A equal to set of all real numbers minus 3. Okay, so they will just describe what OR means. Here I am just giving you what OR is, but in exam they will describe what OR is. So capital A equal to set of all real numbers minus 3, which means every number is present in A except the number 3, and capital B equal to set of all numbers, real numbers, minus 1, right? A function f from A to B is defined by f of x equal to x minus 2 divided by x minus 3. Which of the following is true? Now if A is set of all numbers minus 3, this is set of all real numbers, but it will not contain 3, except 3 it will contain everything. And B is set of all real numbers minus 1, which means except 1 it will contain all the other numbers, and f is a function from A to B, right? If that is the case, then they are asking what type of function is this function f. So see this, now f is a function which is defined by x minus 2 divided by x minus 3, then which of the following is true? So is it 1 to 1 or on to or both or none, right? So let's test it. Let us assume that okay, let's see whether it is 1 to 1 function or not. So how to find out whether it is 1 to 1 function or not is, we have to prove it by contradiction. The contradiction is this way: a function may not be 1 to 1 if we have 2 elements in A in such a way that both of them will have same image in B. If this is the case, right, then we can say that it is not 1 to 1 function. Now we'll assume that there are 2 such elements A and B, okay, for which we have the same image. Let's call this image, either you can call it as f of A or f of B, let's say, and now we have to show that 2 such elements will exist. If we can show that 2 such elements exist, then we can say that it is not 1 2. If we can show that these 2 elements doesn't exist, and in fact these 2 elements are also equal, in case if their images are equal, we can show that it is 1 1. Fine. Now first of all, is it really a function or not? So what do I mean by that? Will every element in this set, will every element have an image there, right? So it is already given that it is a function, so you need not really test it, but just for the sake of explanation or just for the sake of practice, I want to ask you this question, whether this is a function or not, right? It is going to be a function only when for every point in A this value exists, isn't it? So it need not be different, this value should exist, that's it. Now if you look at this function, if you look at this expression, for every value of x there will be some real number existing in such a way that you can find the real number, but then only for one value no real number will exist, that value is 3. That is the reason we are excluding the value 3. So in case if you have value 3 in this set A, it is not going to be a function. The reason is you try to find out the image for value 3 in A, because for every element present in this real number set we should have an element there. When you try to find out the image for 3, it does not exist, it will not exist, then it will fail to be a function. That is the reason why they have subtracted 3. So we don't have 3 in the real number set, and for the remaining elements we have the images. Now let's try to test whether it is 1 to 1 or not. For this reason, I'll assume that it is not 1 to 1, which means I'll assume that there are two elements A and B in such a way that f of A equal to f of B. Now what could be f of A? F of A is going to be, I'm just substituting in place of x, A. See this, in this expression, in place of x, I'm just substituting A. Then what do I get? F of A is A minus 2 divided by A minus 3 is equal to f of B. I'm just assuming that there are two elements A and B in such a way that their images are same. Then A minus B, A minus 2 minus A minus 3 equal to B minus 2 by B minus 3. What does it mean? It means that A minus 2 into, I'm just cross multiplying, right? B minus 2 into A minus 3. What does it mean? It is going to be AB minus 3A minus 2B plus 6 is equal to AB minus 3B minus 2A plus 6. Now AB get cancelled, 6 get cancelled. Now what can you see? You can see that A equal to B from this. Therefore, in case if two images are equal, then we are getting that these two elements are actually equal, which means there is no possibility for two different numbers or two different elements in the set A to have the same element as the image in set B. In case if it happens, those two elements are actually one and the same. Therefore, we can say that since no two elements will have the same image in B, we can say that it is 1 1. Therefore, the function f is 1 1. Okay, fine. Now let's test whether it is onto or not. So what do I mean by onto? For every element in B, there should be a pre-image in A, right? Now let's see that. Now let us say for every element, let me take a element Y. Just for example, let us take element C. Okay, let us assume that C is present in B, and C can be anything other than 1, because 1 is ruled out, 1 is taken out, right? B does not, this set B does not contain 1. So let us say C is a variable which can be any of these elements, right? Then I want to find out for every C there exists an element in this in such a way that the image is going to be that. Let us say C is some element in B, and I am assuming that there is some element X here in such a way that image of X is going to be C. So for every C, if it is satisfied, then it is enough to say that every element in B is going to get an image in an element in A in such a way that image of that particular element is equal to that C. Okay, so now if image of C, if some element is there and the image of this X has to be C, then what should it be? Then X minus 2 by X minus 3 should be equal to C, isn't it? Now I want to find out such X present in A. Are you getting the proof? I'm just assuming, I'm just taking a variable here. Okay, now what I want to show is for every element present in B, there should be an element present in A in such a way that image of that element is equal to this element, right? So for that reason I am assuming some element C here and some element X here. I am just assuming that for this element C, X must be the element whose image is equal to C. Now I want to show that for every C, for every element in B, there will exist at least some X in such a way that image of X is equal to C. Now I want to find out what that element X could be, right? So see this. Now I want to find out what could be X. X minus 2 equal to Cx minus 3C. What does it mean? It means that X minus Cx equal to 2 minus 3C. That implies if you pull out X as common, 1 minus C equal to 2 minus 3C. What does it mean? X equal to 2 minus 3C divided by 1 minus C. What does it mean? For every element C, there will exist a X such that once you find out this expression, right, such an X will have C as a value, right? For example, if you want to find out what could be the corresponding element for 1 here, which means what is the element, okay, see this. So will all the elements exist? Just see this one, it is interesting. See, now we found out that for every element C there exists an X which is present in A in such a way that image of X equal to C, right? But then except one element we can find it. So what is that exception? 1. The reason is once you try to substitute 1 in place of C, you will get an infinity, which means there will be no pre-image for the element 1. That is why even if you see this, they have subtracted the element 1. Therefore it is not a problem. So other than 1, for every other element we can find out the pre-image by using this formula. Got it? You can give me any element, I'll just substitute in place of C that element, and I can tell you what its pre-image of that element according to this function. Then we can say that definitely it is a onto function. The reason is every element in B is having a pre-image. So it is already 1 1, and now we have shown that it is onto. So what can we say? Since it is 1 1 and onto, we can say that it is a bisection. So F is a bisection. Okay. See this, inverse of a function. Let F be a function from A to B. If the inverse relation F inverse from B to A is a function, then it is called inverse of function F, and it is denoted by F inverse from B to A. So what is the meaning of it is, I'll just take an example and explain you. See this, if you have a set A and a set B, let's say we have 3 elements here, A, B, C, and we have 3 elements here, 1, 2, 3, and F is a function mapping all the elements of A to elements of B this way. A is mapped to 1, B is mapped to 2, and C is mapped to 3. Now what about F inverse? F inverse exists. F inverse will be a function only when you take the inverse mapping and if you see that it is a function. Now see this, if the mapping from A to B is A is mapped to 1, B is mapped to 2, C is mapped to 3, then F inverse will be a mapping from B to A in such a way that 1 is mapped to A, 2 is mapped to B, and 3 is mapped to C, isn't it? Now if you take that inverse, it is going to be a function. The reason is every element in B will have an image in A, and also there will be exactly one image. Therefore inverse of this function exists, right? Okay, I'll just give you one more example to just show you that every function will not have inverses. Let us say A is a function like this. We have 3 elements and the same one, A, B, C, 1, 2, 3. Now let us assume that F is mapping A to 1 and also B to 1 and C to 2. Now what can you say about inverse? So if you try to find out the inverse function, it will not exist. The reason is if you try to see the inverse, see 1 is mapped to 2 elements. So according to the definition of a function, we cannot have one element mapped to more than one element. That is why if you take the inverse of this function, since one element is mapped to more than one element here, it cannot be a function. And also one more reason here is the element 3 is not mapped to any elements here, therefore it cannot be possible, right? So if you try to see this, it is very clear that if a function has to have an inverse, then every element in B should have only one image in A, isn't it? Therefore the original function should be 1 to 1, right? So what do I mean by that? See, here 2 elements are having same image, and that is why when I take the inverse of it, this one element is getting 2 elements as images, right? That is why this failed to be 1 1, sorry, this failed to be a function. The reason is it failed to be 1 1. So if a function has to be, if an inverse has to exist, and if it has to be a function, then definitely the original function should be 1 1. And the second reason, if you observe why this inverse failed, is that the element 3 does not have any image here, right, or any pre-image here. So why did it happen? Because the function is not onto. So if the function is onto, then it can be a function, and it can exist, it can have a inverse. So what I mean to say is, if the original function, if it is both 1 1 and onto, then only inverse of that function will exist. So why these two conditions are required? One is, if it is 1 1, then every element here will have only one element here instead of one element having two elements as images here. That is the reason it should be 1 1. And why should it be on 2? Because every element here will have exactly or at least one image here, otherwise it will not have, right? So a function will have an inverse only when it is 1 1 and on 2. So see this theorem, inverse of a function f exists if f is a bisection. Bisection means if it is both 1 1 and on 2. Okay, some questions are possible like this: which of the following will have inverse? See this, f of x is defined as x square and f of x is defined as x cube. Which one of these will have inverse existing? So in order to answer this, you should find out which one of these are bisections. If you can find out if they are bisection, you can say that inverse exists. We already know that x square is not 1 1, isn't it? F of x equal to x square is not 1 1 function. The reason is 1 will be mapped to 1 as well as minus 1 will also be mapped to 1, right? And it is defined on set of all real numbers, which means we both have negative numbers and positive numbers. So since 1 and minus 1, two elements are mapped to the same element, when you try to find the inverse, one element will try to get mapped to more than one element. Therefore it is not a 1 1 function, and so it cannot be having any inverse. Now if you look at this one, we have already seen it earlier that f of x equal to x cube is a bisection. It is both 1 1 as well as on 2. So what can we say? So since it is both 1 1 and on 2, we can say that inverse exists. Okay, fine. Hi, in this video we shall discuss about the limits. So what is the main intention to introduce the limit is, so I'll define it, why we need it. So the limit, the definition, the word, why it is required is, if you have a function like this, y equal to f of x, in order to talk about this function or in order to study the behavior of this function, the main problem is we should talk about all the values, or for every value of x, what is the value of y. That is how we study a function, isn't it? In many applications, either in physics or mathematics or any other areas, whenever we talk about these functions, for every value of x, we want to know what the value of f of x. From that, we'll know how it is behaving, right? Now, the main problem is, for some of the functions, we will not be able to give a definite value for a function at some point x. I'll take an example quickly. Let us say y is a function y equal to 1 by x, which means f of x in this case is 1 by x. Now if you have to study this function 1 by x, we are supposed to talk about what are the possible values of this 1 by x for all values of x. But then the problem is, if we talk about the value of 1 by x at a point x equal to 0, it is undefined. The reason is, it is infinity. You cannot give a definite value. It is undefined, isn't it? Therefore, in that cases, since we cannot discuss about the value of x at a point x equal to 0, we talk about what happens in its neighborhood, which means we are not able to say what happens exactly at x equal to 0. Therefore, at least you should be able to say what happens in a at the values which are close to 0. Even though you are not able to discuss it at x equal to 0, tell me what happens when it is close to 0, either left side or right side. Now using those values, I can approximate the value, what could be the value at 0, because we see in most of the functions, if we have to, in most of the applications, we need the exact value of the function, but then clearly we will not be able to get the exact value of function. Therefore, in this case, instead of going for exact value, we go for the approximate value. How do we approximate it? We just go into the neighborhoods and we check it. I'll quickly take an example, then you will understand it better. Let us say I have f of x like this. I have f of x as x square minus 4 divided by x minus 2. Now clearly, if you observe it, we cannot define the value at x equal to 2. At x equal to 2, obviously if you try to substitute x equal to 2 here, it is going to be in 0 by 0 form. Check it. 2 square minus 4, 2 minus 2. It is going to be in 0 by 0 form. Therefore, this function is defined at all the values other than x equal to 2. Let us say that is why this function is given this way, which means they don't want us to talk about x equal to 2, right? Then, since we don't have the value at x equal to 2, I want to know what could be its value at a value close to 2, right? So in order to find that, I'll use this factorization method. What is factorization method is, the very reason that we are getting 0 by 0 is because, see, whenever we get a 0 in this function and whenever we get a 0 in this function, it means that, you know, when I substitute 2, it means that x minus 2 is a factor of this and x minus 2 is a factor of this. So I'm going to write it like this: x minus 2 into x plus 2 divided by x minus 2. I think you know how to expand this. I mean, you know, x square minus 4 equal to this one. That is why I'm not writing it. Okay, so now you can cancel it off. Therefore f of x turns out to be x plus 2. Got it? Now we have got the function x plus 2. Let's call it y. So here y equal to f of x. So y equal to x plus 2 is what we got. Now I want to see how does this function x plus 2 behave. So for that reason, let us plot the graph. Let's see what happens for this. Okay, let us say this is x-axis, this is y-axis. Fine. Now y equal to, let's say x equal to 0. When x equal to 0, y equal to 2, which means when x equal to 0, y is equal to 2. This is the point, isn't it? This point is nothing but 0 comma 2, right? And similarly, when y equal to 0, x equal to minus 2. Let's say this point is minus 2 comma 0, right? See, from this I'm just plotting the points. Therefore the function f of x or y equal to this one, x plus 2, behaves like this. Okay, it is passing through these 2 points. Now how does this function behave at 2? At 2 it is not defined, isn't it? Therefore at the value 2, let's say at x equal to 2, let's say this value is 2, at this value it is not defined, so I am just putting a circle. So circle means it is not defined at that point, so we don't know what its value, it is hollow there, which means we are not talking about its value there. Now what we want to do is, since we are not able to say what its value is at x equal to 2, I want to know what its value might be when the value gets close to it, which means I don't know exactly what its value is here because it is not defined, the original function, isn't it? The transform function is giving us 4, that is okay, but the original function is not defining it. Now I want to discuss about what its value could be as we approach that point, right? Which means from left side as we approach it and from right side as we approach it, which means 2, not exactly at 2, but we are interested in finding out its value at the surroundings of 2, at the neighboring points of 2, right? And now those, if I find out what its value is at the left side and what its value could be at the right side, which means here and here, and if those two values turns out to be equal, then we can say that yes, the limit extends to 2, f of x equal to that particular value. Then in that particular, whenever it is required, we can replace f of x with that particular value in all the applications. Okay, I'll just tell you what I mean to say here. See, now at 2 it is not defined, therefore I'm not interested at 2, I'm interested at a point which is very close to 2 but less than 2, right? So let me define for that reason a small number which is called x. Now x is a positive number which is infinitesimally small. Infinitesimally small means it is a very small number. Okay, let us, what is it? What is h? H is a positive number. Remember that it is positive number. Wherever I write h in this complete subject, it is a positive number, otherwise I'll let you know. Okay, so it is a positive number which is very, very small. Now I want to define the point neighboring to 2 which is to the left of 2. If you have to go to some value which is less than 2, then of course we have to do 2 minus h, isn't it? So what is 2 minus h? It is a point which is less than 2, which is very close to 2. Now I want to find out what could be the value of the function f in that point. That is also called as left hand limit. Left hand limit. Why is it called left hand limit? Because we are actually coming from left side. We are actually coming from left side towards the function. Okay, left hand limit of f of x at 2 is equal to limit h tends to 0 f of minus h. So what is f of 2 minus h? See this, f of x equal to x plus 2, f of x equal to x plus 2. Therefore in place of x I am going to put 2 minus h, 2 minus h plus 2, right? Limit h tends to 0, isn't it? So what is that? That is limit h tends to 0. This is 4 minus h, which is nothing but 4. So what did you find out from that? So we don't know what its value is at 2, but then at a value which is less than 2, which means in the neighborhood of 2 from the left hand side, we are going to get a value of 4. Now let's see if the same thing happens on the other side also. If on both the sides the value is approaching to the same value, then we can say that probably the value of the function at that particular value 2 must be that. Let's see that. Now right, which means now I want to go from the right hand side. So I want to test the value of this function at a value which is to the right of 2 and very close to 2. Now what is that value? Obviously 2 plus h, where h is a very small positive number, right? Therefore let's discuss about right hand limit of f of x at x equal to 2, right? So that equal to limit h tends to 0 f of 2 plus h. Already we know that f of x equal to x plus 2. Then what will be f of 2 plus h? That equal to limit h tends to 0. F of 2 plus h is nothing but x plus h plus 2, isn't it? In place of x we are going to put 2 plus h, which means 2 plus h plus 2, which is nothing but limit h tends to 0 4 plus h, right? Now what is its value? Its value is going to be 4. Therefore because you put h equal to 0 there, therefore we got that both the left hand side limit and the right hand side limit is, both of them, they are both left hand limit and right hand limit both are equal, right? So since left hand limit and right hand limit both are same and both are equal to 4, we can say that limit x tends to 2 f of x exists and its value is 4, and its value is 4. So it might look trivial. You might even ask me, why are you doing all this? You could even directly declare it here itself, but it is not that easy. It is, for this function I have taken a small function, a trivial function, just to explain you the concept. Later when I take big functions, then you will understand what is the difference and why should we be doing all this. Okay, for now understand the procedure. Later I'll tell you why you should be doing it. Now what did we find out finally? Finally we found out that even though for the given function the value of f of x is not defined at 2, we can approximate it to 4 whenever required. That is the meaning of it. So in most of the practical applications we cannot say the value of it is 0 by 0, go and put it. We cannot do that, because if you do this in numericals, let us say you got an equation which determines about the speed of a car, and now suddenly you got the value to be 0 by 0, right? And if you ask them to just substitute it there, it doesn't work there. Then what we do is, if its value is going to be 0 by 0, which is undefined, indeterminate, then what we try to do is we try to convert it to a close approximate value by using this method, right? That is why limits are useful. Okay, I'll take more examples and I'll make this point clear. Fine. Now let's see this function mod x. The importance or why this function is very interesting is it behaves in two ways. So we know about mod x. Whatever input we give it, the output is going to be a positive number which is equal to in magnitude to the input. For example, if I give like this, so if I apply mod to minus 3, it is going to be plus 3. If I apply mod to plus 3, it is going to be plus 3, which means either you give a negative value or a positive value, output is always going to be positive, and the output is equal to the input in terms of magnitude. Okay, that is the reason why this function is interesting. So let's write this definition of the function, and then we shall see why we have to analyze it here. So let me write the definition of this function. Now f of x is equal to minus x when x is less than or less than 0. Let's say x is less than 0, and it is equal to plus x when x is greater than 0. Here I think you will get some doubt. The doubt is when we are saying that f of x mod x has to be always a positive number, why are we writing it as minus? Here minus, that is a doubt, a very popular doubt. The reason is simple. See, even though I am writing the value number as minus x, right, but x is less than 0. Check this. So x is less than 0 means x is a negative number, which means inside this number x itself we have a negative sign, and outside we have a negative sign. Therefore overall it is going to be positive sign. Now when x is greater than or equal to 0, then what happens? That it is already a positive number. That is why we are not putting any sign there. Therefore the output is going to be positive. That is the reason, right? And now if you observe this, this mod x, this function seems to change when x is at a point 0, which means this function is going to change at a point 0. Therefore at that point 0 they are asking us to analyze it. Now check this. Discuss the limit of f of x at x equal to 0. Now what did I say? The limit exists at a point whenever its left hand limit as well as right hand limit both are equal to same, right? Now let's find out what is left hand limit and right hand limit here. See, watch it. Left hand limit of mod x, which is nothing but f of x here, at x equal to 0 equal to limit h tends to 0, right? Which means I am going to take this. What is h? H is a small infinitesimally small positive number. Okay, limit x tends to 0 f of x minus h. In this case it is going to be 0 minus h. Why 0? Because we are talking about at x equal to 0, right? So what does it mean? In place of x you are supposed to substitute 0 minus h in this, so that equal to mod 0 minus h, right? So we know that already h is a positive number which is small, and 0 minus h is definitely a negative number. So since it is negative number, we are going to have h is a positive number, minus h is a negative number. So when we give it a negative number, output is going to be h itself, right? Now we have to apply limit h tends to 0. Limit h tends to 0 here and here, right? Limit h tends to 0 here and here. So which is nothing but 0. The left hand limit is equal to 0. Now let's examine the right hand limit as well. So what is right hand limit? Right hand limit of f of x at x equal to 0. What is right hand limit? We have to go some point beyond that x in the neighborhood of x, equal to limit h tends to 0 f of, we are talking about at 0 plus h, which is nothing but limit h tends to 0 mod 0 plus h, right? So what is this? H is a positive number, therefore mod 0 plus h is nothing but h, which is simply limit h tends to 0 positive h, which is 0. Therefore we got 0 here and 0 here. Therefore left hand limit is equal to right hand limit for a point x equal to 0. Therefore limit exists at x equal to 0, and the value of that limit exists at x equal to 0, and the value of that limit is 0 itself, right? So the answer is the limit exists at x equal to 0 and the value of limit is 0 itself. Okay, now let's discuss the question number 2. Now I think we understood how to find out whether a limit exists at a value a or not. So I'll just put it together in small kind of definition, and then what I'll try to do is I'll explain you the second question in this. The second question is also discuss the limit for all x in its domain, which means they are asking us, now we have discussed about what happens at 0, now they are asking us to say what happens at every possible value. So just before going ahead, I want to discuss about the definition. So when do we say that a limit exists? See this. So we say that a limit to a function exists if, what is the condition? If left hand limit is equal to right hand limit. Now how to find out the left hand limit or right hand limit of a function exists at a, okay, at a point x equal to a, limit of a function f of x, okay, that is the meaning. So now when do we say that it exists? It exists when left hand limit is equal to right hand limit. Now what is the left hand limit? Left hand limit is nothing but we have to talk about the value of the function at a point left to it, right, in the neighborhood, which means if f of x is the function, we are supposed to find out the value of f of x at the neighborhood of a, which means a minus h is nothing but, see, it is, we are talking about the value of f of the function f at a value which is somewhat less than a in the neighborhood of a, isn't it? Limit h tends to 0, right? This is left hand limit. Now what is right hand limit? We have to talk about the value of the function to the to the right of it, which means limit h tends to 0 f of a plus h, right? Now whenever this value becomes equal to this value, then we can say that limit exists. That is what we have been doing till now. Earlier, if you observe the two functions that we have observed, which means x square minus 4 by x minus 2 as well as mod x at value 0, and the earlier function was at 2. Now if you observe these two functions, we discussed about the limit. We found out that these two values happen to be same. That is why we have decided that we declared that limit exists, right? Now similarly, they wanted us to discuss about when the limit are about all the values of x, right? Discuss the limit for all the values of x, which means they wanted us to what they wanted is they wanted to ask whether the limit exists for every value of x including 0. 0 is already done. Now we shall discuss about the other remaining values. What are the remaining values we have here? See this. So one value is we can have x less than 0, right, which means we want to discuss about negative numbers. Let's say case 1. Case 1 is x less than 0, which means x is negative, right? So let us say x is negative. So when x is or instead of writing x, let us discuss about set of all negative numbers. Let us say a represents a value which is less than 0. Now we want to discuss whether the limit exists at a or not, which means for the negative numbers I want to discuss about it. Okay, now left hand limit. Left hand limit is what? See this is left hand limit, isn't it? Left hand limit is limit h tends to 0 f of a minus h, where h is a very small positive number, isn't it? That equal to limit h tends to 0. See, f of x equal to mod x, then f of a minus h equal to mod a minus h, isn't it? Now it is a positive number. If we have a negative number, and from that negative number if you are going to subtract a negative number, right, from a negative number if you are going to subtract something, still the answer will be negative, which means this entire number a minus h is going to be a negative value. So when it is going to be negative value, we are going to have minus a minus h as its output, isn't it? Therefore the value of this one is nothing but this, with limit h tends to 0. Now if you substitute h tends to 0, we are going to get it as minus a. Fine. Now let's find out right hand limit as well. Right hand limit. See this. Right hand limit is this one. What is it? Limit h tends to 0 f of a plus h. What does it mean? Limit h tends to 0, a plus h is nothing but, f of a plus h is nothing but mod of a plus h. Right? Now a is a negative number to which we are going to add a very small infinitesimally small number which is positive. Even then the entire limit is going to be negative itself. See, only way you can make this as positive is when a is very very small, and when you are going to add it, it is going to become 0, isn't it? Even then the same thing will occur. A plus h will be true. See, h is a very small number and a is a negative number. This is positive. In case if it is also a negative number which is very small, then also in the worst case this entire value will become 0. Therefore minus of 0 is 0, so it doesn't, we can apply right like that. Or in all the other cases, if a is a big number and h is a very small number, and since it is a negative number, so we are going to get the entire result as negative, right? And we cannot say that what if a is a number which is very small than h? Already I am saying that h is the least smallest number possible. There cannot be, if you are going to take a value of a which is very small, then what I'll do is I'll take the value of h which is even smaller. That is how we find out the neighborhood, isn't it? See, if a is a number, we are going to take a very small number across its neighborhood, which means this entire number will never cross 0. That is the meaning of it. So if you say that it is a is very small and it is less than h, then I'll say that I'll take a small number which is even lesser than this. So what I mean to say is, whatever you go for the value of a, I'll still get a lesser value compared to a for h. Then in worst case it might go to 0 or it will be less than 0. Therefore the entire value is going to be less than 0, and so I'm going to put it as minus a plus h, since it is going to be a negative number, right? So in that case, if you put limit h tends to 0, which means in place of h if you put 0, this one is going to be minus a. So both of them you have to apply limit h tends to 0. Then you are going to get that left hand limit is equal to right hand limit, and so the limit exists for all values of x less than 0, which means for all the negative numbers limit exists. Already we know that the limit exists for 0. Now we are showing that the limit exists for values less than 0. Now we have to show that the limit exists for values greater than 0. Okay, now see this, what happens for limit greater than 0. So let us say case 2. Case 2 is a is a number which is greater than or equal to 0, and equal to 0 is already discussed. So let's discuss about only 0, which means we want to discuss about whether the limit exists at a point a if the a is positive number, and a can be any value. Okay, so let's talk about left hand limit. So what is left hand limit? Limit h tends to 0 f of a minus h. A minus h means a point just left, just to the left of it. Then what do you get here? So this value is going to be limit h tends to 0 mod a minus h, isn't it? Now a is a positive number and h is a very small number compared to a in general, otherwise it will be as big as a. That is the worst case, right? Then what happens? In worst case we might get 0, otherwise it will be a positive number. Therefore this entire number is going to be 0 or positive number, so I can directly write it as a minus h, which is going to be positive or 0. Got it? So what can you say about it? Limit h tends to 0. Now what do you get it? A. Okay, now find out the right hand limit. So how to find out the right hand limit? Limit h tends to 0 f of a plus h, which means we are finding out the limit at a point just in the neighborhood of a, but a small deviation to the right of a. Okay, so what is it? That equal to limit h tends to 0 mod a plus h. Already a is a positive number to which I am going to add h. The total result is going to be positive because h is also positive. So what can we say? It is nothing but limit h tends to 0 a plus h. So what is a plus h? When you substitute h equal to 0, we are going to get a. Now left hand limit and right hand limit both are equal even for positive numbers. For negative numbers both are equal, for positive numbers both are equal, and for 0 also both are equal. Therefore this function, limit exists for every real number. For every real number you could think of it, you think of any real number, limit exists. Okay, so that is the meaning of this one. Fine. So now we can, okay, see one more thing. You need not do the entire proof in GATE. If you can remember this, I'm talking about some of the standard functions, some of the popular functions. Just remember the result. This is how we are going to prove it. In theory exams, if you have any BTech theory exam, or if you are preparing for IIT JEE, if anyone watching this video is preparing for IIT JEE, for them the proofs are important, and other theoretical exams the proof is important. But coming to GATE, it is important that you just remember the result. Result is just enough. Yeah, even if you think that is going to be very big, you are not going to do it in the exam. Just remember the result. What is the result? For mod x, limit exists everywhere. So there are some very popular functions. All those functions we shall discuss. Okay. In GATE or any competitive exam, you need not worry about finding whether the limit exists or not. For most of the questions, they'll ask you the limit questions only when they exist. So how do you find it out? Simple. If it is a multiple choice question, just look at the options. In the options, if they don't have anything like limit exists or limit does not exist, then go for simply normal application of limits. And how to do that? There are various techniques. I'll just show you one example here, and here we are going to use something called as factorization. You must be already be knowing it. Let's see how to apply it. Let us say the question is like this: limit x tends to 3, assume that it is x power 4 minus 81 divided by x minus 3. If you have something like this, then how are you going to find out the limit? Assuming that in the options we don't have limit does not exist. In the options, let's say we have only the numbers present there. Then how to find it out? See this. If you directly substitute 3 in there, it is going to be 81 minus 81, 3 minus 3, which is going to be 0 by 0. It is a special form. We are going to discuss about it later in the later videos. Or here, what it means is the value does not exist. It is indeterminate. It is not defined. So we just want a value. So in this form, if you try to apply the limit, we are going to get 0 by 0. Therefore, we are supposed to change the form in such a way that we will get some value. So let's use the method called as factorization. See, one simple clue is whenever you are substituting 3 here, it is giving you 0. Whenever you substitute 3 here, it is giving you 0. What does that mean? It means that x minus 3 is a factor in this as well as in this. It is clearly visible here, but it is not visible here. Therefore, you can use normal division, you can find it out. Or I'm directly writing it. I think you know that formula, a square minus b square is a minus b into a plus b. I'm just using that formula and writing it. So it is x square minus 9 into x square plus 9 divided by x minus 3, and we know that x square minus 9 can be written as x minus 3 into x plus 3 into x square plus 9 divided by x minus 3. Now we can cancel out these two, right? Now we can substitute in place of x 3. Then what do we get? If I substitute in place of x 3, then we get 3 plus 3, right, into 9 plus 9, 6 into 18. So you can simplify it. Okay, so that is how you can solve it. So what I mean to say is, from this example, you need not always find out whether the limit exists or not. Only in the questions where it is required, you apply that method, which means in the options, if you see that whether the limit exists or not is there in the option, then you have to check it. Otherwise, you directly substitute it. In case if it is going 0 0 0 by 0, I'm just directly putting it. Okay, fine. Now let's see one more example of the same kind. Again, I'm assuming that in the options they didn't give whether the limit exists at 1 or not. So this is the question: limit extends to 1, which means they are asking us what happens for this function as we go towards 1. Okay, so this is the question given. Now try to substitute 1 directly and see if the value actually exists there or not. So if you substitute 1 directly here, I get 1 minus 6 plus 11 minus 6. It is nothing but 12 minus 12, which is 0. And here also 1 minus 1, which is 0. So if I directly substitute it that way, I'll be getting 0 divided by 0, which is indeterminate form. Right? So what is indeterminate form? I'll discuss about it later. Or simply put, there is no definite value there. So what we wanted is, in most of the applications, we want a definite value, but there is no definite value. In such cases, what are we supposed to do? Simple. So since there is no definite value, only thing that you could do here is convert it into some other form through which we can get the definite value. In most of the cases, it so happens that whenever you have the 0 by 0 form, we could apply some of the techniques and we can get whatever we wanted, the definite value. Okay, so here I'm going to use a technique called as factorization. So why factorization is applicable here? Just see this. When I substitute 1 here, it is all becoming 0. It means that x minus 1 is a factor of this. Whenever you substitute 1, x equal to 1, if it is all going to be 0, it means that x minus 1 is a factor of it. Why? Because if this entire thing is going into 0, it means that it can be written as something as x minus 1 into this. Then only when I substitute x equal to 1, this entire thing will become 0. This entire thing will become 0, right? Similarly, here also x minus 1 is a factor of it. Now we know that in both of them x minus 1 is a factor, right? So what you can do is directly try to write both of them as product of x minus 1s, and you can analyze it. Okay, so what I mean to say is like this. You can write this one as x minus 1 into something, and this one also as x minus 1 into something, and then you can cancel out x minus 1 and x minus 1, and later you can find out the value of it. Okay, simply put, what I'm trying to do is like this. So how to find out the how to write this one as x minus 1 into something? Simple. If you can divide it, you do that. If you don't know how to divide it, or if you are looking for a some other simpler way, then simple way is you can build the entire function by using this one as a building block. Just observe this. See, I want to use x minus 1 as a building block, and I want to build this entire function, right? So let me build it term by term. First I want to build x cube. So if I use x, and if I have to build x cube, then I have to multiply it with x square. That is the reason I'll be multiplying this with x square into x minus 1. Now what will it give me? X cube minus x square, isn't it? X cube minus x square. But what do I want? Minus 6x square. But what do I have? Minus x square. Therefore, how much do I need? Again, minus 5x square. Therefore, multiply it with minus 5x and again x minus 1. Then what do I get here? Minus 5x square. Already minus x square is there. Therefore, it is going to be minus 6x square, right? And what is remaining? Plus 5x. So 5x is remaining here. Here I have 5x and here I have 11x. Now what do I need? Plus 6, isn't it? 6x I need. Therefore, plus 6 into x minus 1. Then I get plus 5x plus 6x, which is nothing but 11x. And then here we get minus 6. So already minus 6 is there. Therefore, it is complete. So I have written the entire function as if it is like this. So what can I write this one as? I can pull out x minus 1. Isn't it? I can pull out x minus 1 and I can write the remaining terms here. What is remaining? X square minus 5x plus 6 divided by, so what should I write here? X square minus 1. I am going to write x square minus 1 is x plus 1 into x minus 1. Now we can cancel out these two. Now you apply limit x tends to 1. If I apply limit x tends to 1, if you just substitute 1 here, then you are going to get probably 1 minus 5 plus 6 divided by 1 plus 1, which is nothing but 7 minus 5, 2 by 2, which is 1. Therefore the answer of this one is 1. So the calculation part is not important. What I wanted to show you is, in exam, if they don't ask you about whether it exists or not, don't go for that method. You go for that exists or not method only if they ask you that. If they don't ask you that, don't unnecessarily complicate it. Okay, so directly you can do it using this method. Later I'll discuss about many other methods using which you can do. Fine. Now let's see this one other way of finding out the limits. So whenever you have a fraction like like this, then I told you that factorization method is going to work, but then we are going to use other method as well, which is called as L'Hospital's rule. So sometimes some people will call it as L'Hopital, and some people will say it as L'Hospital. So whatever you are comfortable with, you can go with that. So before looking at it, let's look at something called as indeterminate forms. So whenever you get the answer as 0 by 0 or infinity by infinity or 0 into infinity or infinity minus infinity or 0 power infinity or 1 power infinity or infinity power 0, whenever you substitute the limit in the expression, then all those forms are called as indeterminate forms. Now how to deal with them? One way is factorization, which we have seen. Other way is L'Hospital rule. Okay. Now coming to L'Hospital rule, what we are going to do is, we should keep on differentiating the numerator and denominator till 0 by 0 or all infinity by infinity form is removed. So this differentiate numerator and denominator till 0 by 0 or infinity by infinity is removed. Okay. Now what I mean to say is, if you are going to get limit x tends to a f of x by g of x equal to 0 by 0 or infinity by infinity, then differentiate the numerator and denominator one time and try to apply again the limit x tends to a, right? And again you see that 0 by 0 or infinity by infinity is not there. In case if it is again 0 by 0 or infinity by infinity, you keep on doing the same. Got it? So we are going to apply only for 0 by 0 and infinity by infinity. Even though all these are indeterminate forms, we are going to use this for only these two forms. Okay? Now coming to this, let's take this example. Limit x tends to 2 x square minus 4 by x minus 2. Now using factorization method, what we can do is, okay, why should we go for factorization method is, if you try to substitute x equal to 2 over here, you are going to get 4 minus 4 and 2 minus 2, which is nothing but 0 by 0 form, right? So in order to eliminate that 0 by 0 form, sometimes we can use factorization method. So what does factorization method say? Write the numerator in terms of the factors and then see if it is a multiple. If it is so, cross it off. See this? X square minus 4 can be written as x minus 2 into x plus 2. Now you can cross out these two. What is remaining? X plus 2. Now you can write limit x tends to 2 x plus 2, which will be 4. Got it? Now using L'Hospital rule, what we could do is, instead of going with that factorization method, whenever you see 0 by 0 or infinity by infinity form, see it is already in 0 by 0 form, you try to differentiate the numerator and denominator. And what is the differentiation of this? With respect to x, you have to do it, x, right? So d by dx of x square minus 4 d by dx of x square minus 4 is equal to 2x. In general, d by dx of x power n is going to be n into x power n minus 1, right? So d by dx of x square is going to be 2x. Therefore for this one 2x, and d by dx of 4 is going to be 0. Why? It is a constant. So whenever you differentiate a constant, there will be no change, therefore it is 0. Okay. Now what about this one? D by dx of x is 1. So it is 2x by 1. Now you substitute x in place of x 2. Then what are you going to get? 4. Got it? Okay. In order to solve the questions in this topic, you are supposed to know these rules, and some of them you can derive anyway using L'Hospital for rule, but then it is better if you can remember most of these rules. Okay, so what you will do is pause the video, just write down all the properties. We shall go on to the problems where we shall see the applications. Okay, fine, you can pause it and write it. Okay. Now let's see some examples on how to solve the questions when they are in the form of 0 by 0. Example number 1. Limit x tends to 3 x square minus 9 by x cube minus 27. Now if you try to directly substitute the value of 3 there, you are going to get 0 by 0. So whenever you have such form, it is always better that you apply L'Hospital rules if it is applicable. In this case, it is applicable, we can apply it. Now if I differentiate the numerator, it is going to be 2x. If I differentiate the denominator, it is going to be 3x. 3x square, right? 2x divided by 3x square. Now you try to apply the limit. See, after every time you apply the L'Hospital's rule, which means the derivation, you are supposed to again apply the limit. Now if you apply the limit, in this case you didn't get 0 by 0 form, so that is the answer. Okay, so if you get 0 by 0, again you are supposed to differentiate numerator and denominator. Okay, now look at this one. Limit x tends to 8 cube root of x minus 2 divided by x minus 8. Now you try to substitute the value of the limit there. You are going to get here cube root of 8 is 2. 2 minus 2 is 0. And again 8 minus 8 is 0, right? Therefore it is 0 by 0 form. So again apply L'Hospital rule. So you can write x cube root of x as if it is x power 1 by 3. Now it is in the form of x power n. Differentiate it, you are going to get it as n into x power n minus 1, which means 1 by 3 into x power 1 by 3 minus 1. That is why you get this 1 by 3 into x power minus 2 by 3. Okay. Now what is differentiation of 2? 0. Now here in the denominator, differentiation is 1 and it is 0. So now you got this. Okay. Now you try to apply limit there. If I apply the limit there, so 8 I am writing it as 2 power 3, so that these two will get cancelled, right? So finally you are going to get the answer as 1 by 3 into 2 power minus 2, which means 1 by 3 into 1 by 4, which means 1 by 12. Got it? Okay. Now the next one is limit x tends to 0 log 1 plus x cube divided by sine cube x. So again, if you try to substitute x equal to 0 here, this one is going to be log 1, which means 0, and this one is going to be sine 0, which is again 0. So 0 by 0 form is there. Apply L'Hospital's rule, right? So how to apply L'Hospital rule? Log x, if you differentiate it, it is going to be 1 by x, but it is a function, that is why it is going to be 1 by that function into differentiation of that function. Therefore 1 by 1 plus x cube into 3x square. What about sine cube x? 3 into sine square x into d by dx of sine x, right? That is cos x. So 3 into sine square x into d by dx of sin x is cos x. So we got this. Now you can directly apply, limit x tends to 0, the limit over there, but then again you might get some problem there. So let's try to do some modifications so that if we can get it into a form which we already know, it will be easy for us to apply. So I'm just doing some modifications here. X square, I'm taking it to denominator and writing below x, because we already know that limit x tends to 0, sin x by x equal to 1. For that reason I'm going to take sin x by x square into cos x, and I'm just writing everything as it is. Now here if you put 0, it is going to be 1, and it is going to be 1, and it is going to be 1. Therefore we got 1. Got it? Okay. Now here again, in this case also, if you substitute limit x tends to 0, cos 3 into 0 is cos 0, cos 0 is 1, 1 minus 1 is 0, and denominator is 0 multiplied with 0. So 0 by 0 form is there, and so apply L'Hospital rule again. Now if you apply L'Hospital rule, differentiate this one and differentiate this one. Yes, I have differentiated both of them, and again if you try to put limit x tends to 0 here, you are again going to get 0 by 0 form, right? Now what should we do? Differentiate it one more time. So when I differentiate it one more time, I got this expression. I have taken this and differentiated one more time, I got this expression. Now you substitute limit x tends to 0, you are going to get 9 by 4, right? Why? Cos 0 is 1, and again cos 0 1, cos 0 1, and this one is 0. Therefore 2 to 9, which means 9 by 4. Okay. And one other way of solving the same question is, see, this is one way of solving the question. One other way of solving the same question is this. See this? Now I am taking the actual given expression and I am writing it in the denominator as x and x here, multiplying with x here and dividing with x. Got it? Okay. Now I am taking this part to the numerator, which means I will be dividing this one with this, and I will be letting this one stay here. So I am just rewriting the terms. X square, I am taking it to the numerator and I am leaving it here this way, right? Now if you observe this, it is in the form of 1 minus cos ax divided by x square. 1 minus cos ax divided by x square. Now if you apply limit x tends to 0 for that, we know that it is a square by 2. Got it? So just now we have seen the formula that for this one it is a square by 2. So whenever you have two functions, you can apply this this limit individually. Got it? So when I applied it, it is a square by 2. So in this case a is 3, therefore 3 square by 2. Now what about this sin ax by x? It is a. Sin ax by x is a. Or if you didn't understand, you can multiply with 2 here and you can leave the 2 there, right? Then it is sine of something by that. Okay. Now 2x, you can apply limit 2x tends to 0. Got it? Even if you write like that, it is going to be 2. So anyway you are going to get 9 by 4, this same one. Got it? Okay. Now let's solve these questions. So again we are solving the examples where we get infinity by infinity form. So if you observe this, limit x tends to infinity, x square plus 5, x square plus 4x plus 3. Now if you try to substitute this infinity over here, you are going to get both in numerator and denominator in infinity. So how to solve it is, see, one thing is you can apply L'Hospital's rule, but then since both the functions are of polynomial type, and you can try pulling out something as common, just see if it works. Now if I pull out x square as common, then I get this function, and if I pull out x square as common in the denominator, I am going to get this function. X square and x square gets cancelled, and now you are going to get 1 and 1 in the leading term, right? So if you try to put infinity over here, it is going to be 0, 1 by infinity, 1 by infinity, 1 by infinity. Therefore you are going to get this. You know how to understand this one is, whenever both the powers are same in the polynomial, numerator and denominator, you can pull them and cancel them out, right? And you can eliminate such questions, okay, whenever limit extends to infinity is given, okay. And this is a combination of both polynomial and trigonometric functions. If you try to apply infinity over here, you are going to get infinity by infinity form, right? So again, for this function, sometimes you might need to apply L'Hospital's rule, right? And otherwise what you could do is, instead of using L'Hospital rule, you can just try pulling out something as common, this x, and see if you could minimize it. Now if I try that, see this, if I pull out x as common, I am going to get x minus sin x by x, and if I pull out x as common, I am going to get x into 1 plus cos x by x, x into 1 minus sin x by x, x into 1 plus cos x by x. I will cancel out the terms x, and now if you observe this, sin x by x is there, and I am going to substitute infinity there, right? What is sin infinity? Whatever the value of infinity is, sin value is always going to lie between minus 1 and 1, isn't it? Therefore here you are going to get minus 1 and 1. It is always going to lie between these two factors, and the denominator is going to be infinity, so overall it is going to be 0. 0 multiplied with a range of minus 1 and 1, isn't it? See, denominator is infinity, you can take it to numerator, which is 0. Now 0 is multiplied with this one, a range of minus 1 to 1 values, whatever it is going to be 0. Similarly, you can apply the same logic for cos x. Cos x is also going to always lie between minus 1 and 1. Whatever the value of infinity is, you are going to get 0 here, the entire term, right? So again you are going to get 1 there. Now if you look at the next example, it is logarithmic, so there is no other way you can solve it. Only option is go for L'Hospital rule. If you go for L'Hospital rule, you have differentiate numerator and denominator. Yes, when I differentiated it, I got this expression, and after differentiating it, you just write it in a form where it will be convenient for us to solve it. So see, once I have differentiated it and I got this one, and I am just writing it this way, okay. And now this entire function can be written as, I can cancel out this, right? And now you are going to get 2 and 2 is cancelled, cos 2x divided by cos square x, isn't it? Sin is cancelled, cos 2x divided by cos square x, right? So now if we apply limit x tends to 0, we know that cos 2x, this entire thing is 0, and cos 0 is 0, and again this entire thing is 0, and cos 0 is 0. Therefore 1 by 1, that is 1. Got it? Okay. Now let's look at some examples where we are going to have infinity minus infinity form. First one is limit x tends to infinity, x minus square root of x square plus x. Now in place of x, if you substitute infinity, you are going to get here as infinity minus infinity plus infinity. So again it is going to be infinity. So it is in infinity minus infinity form. So whenever you have such form, you have to convert it. So let's try to convert it to other form by multiplying and dividing with these two factors. So why only these two factors? So that I will cancel out these two terms. Okay. So once you see this, x minus, this is a minus b into a plus b form, which is a square minus b square form. So if I write like this, I will be able to cancel out the terms. Now I am able to cancel out these two terms, and now I got this one. Now if you try to substitute infinity over there, again you are going to get infinity by infinity form. Now I can use the factorization form. So in the numerator and denominator, I can cancel out x, right? Or if you divide numerator and denominator by x, you are going to get minus 1 here, and then here also you are going to get 1 and x square, which means 1, and here you are going to get 1 by x. So how did I get this one from this one? By dividing numerator and denominator by x. Why? Because it is infinity by infinity form. Okay. Now finally, if you substitute x tends to 0 here, x tends to infinity here, you are going to get 1 by infinity as 0. So this entire part is going to be 0, isn't it? Then you are going to get 1 by 1 plus square root of 1, which means 1 by 2. Okay, minus is there, so minus. Okay, and now look at this one. Limit x tends to 0, 1 by x minus 1 by tan x. Now if you substitute 0 here, it is going to be 1 by 0, which means infinity, and 1 by tan 0, and tan 0 is 0, which means 1 by 0 is again infinity, so infinity by infinity form is there, right? So let's try to change it. So just to simplify it, I have taken the LCM and then I have written it together in one term. So tan x minus x divided by x into tan x. Now you are going to get limit x tends to 0, tan x minus x, and you can write it as tan x by x. If you remember, we know that limit x tends to 0, tan x by x is 1. So for that reason, you can write it as multiply with x and divide it with x. Then you are going to get tan x by x into x square, right? So why am I writing like this? Because limit x tends to 0, tan x by x equal to 1, because of this, right? So you can directly eliminate it. So because it is 1, I am taking it away. So what is remaining? Tan x minus x divided by x square. Again, if you substitute limit x tends to 0 here, I am going to get 0, tan x is 0, minus x again 0, which means 0 divided by x square, again 0. Therefore it is again in 0 by 0 form, right? So in order to convert it, I am going to write it as, you can divide this numerator and denominator by x here. Okay, so tan x. Okay, see since here it is 0 by 0 form, you can apply L'Hospital rule. Then once you apply L'Hospital rule, tan x, d by dx of tan x is secant square x, minus d by dx of x is 1, and denominator again if you differentiate it, it is going to be 2x. Okay, and we know that secant square minus 1 is tan square. Therefore secant square x minus 1 is tan square x. So in this place I am just substituting it there, right? Okay, now if you remember one more form, so the same one, tan x by x equal to 1, limit x tends to 0. So since limit x tends to 0 is there and tan is there, I want to multiply and divide it with x. Already one x is there, so I want to add one more x. So I am going to multiply with x and divide it with x. Then what do I get? Already one x is there, one more x is added, so I can write it this way, tan x by x whole square, and x is what I have newly added, and 1 by 2 I am pulling out as common. Now you can apply limit x tends to 0 individually to all the three parts, and you can see what you get. 1 by 2 you are going to pull it out, and limit x tends to 0 x, which means I am applying limit x tends to 0 to this as well as to this entire part, right? And we know that this entire part is 1, so 1, and limit x tends to 0, 0 is 0, so 1 by 2 into 0 into 1 is 0. Okay, fine. Now one other form of indeterminate form is 0 into infinity. So whenever you have this form, we either convert it to 0 by 0 or we convert it to infinity by infinity and then try to solve it. So in this example, if you see it, limit x tends to 0, x square into log x is given. Now if you try to substitute x in 0 in place of x, you are going to get 0 here. And what about log 0? It is infinity. Therefore you are going to get 0 into infinity there, right? So now what I will try to do is, I will try to take this x square into the denominator by writing it as 1 by x square. Now if you observe it, if you try to substitute 0 in both, here you are going to get log 0 is infinity, and log 1 by, if you substitute 1 by x in place of x0, you are going to get 1 by 0, which is again infinity, which means you are going to get infinity by infinity form. Now if you observe it, since it is infinity by infinity form, you can apply L'Hospital rule. So according to L'Hospital rule, if you differentiate numerator and denominator both with x, here you are going to get log x as 1 by x, and you can write x square, 1 by x square as x power minus 2, and you can write it as d by dx of x power n equal to n into x power n minus 1. In that case, if you write it, you are going to get minus 2 into x power minus 3, and x power minus 3 is going to be minus 2 by x cube. Now it is a by b divided by c by d form. You can write it as a by b into d by c. So you are going to get this. Got it? Now again you can cancel it out. So whatever you get is simply x square by 2, for which you are supposed to apply limit x tends to 0. If you directly apply it, you are going to get 0. Okay, the answer is 0 there. Now for this one, if you observe it, limit x tends to 1, x minus 1 into tan pi x by 2, right? So if you substitute x equal to 1 here, you are going to get 1 minus 1, which is 0, and tan pi into 1 by 2 is nothing but tan pi by 2, and tan pi by 2 is infinity. Therefore here you are going to get 0 into infinity form. And now you are going to convert it in such a way that either it is going to be in the form of 0 by 0 or infinity by infinity. So if I take tan x to the denominator, I am going to get cot x. Therefore tan pi x by 2 is going to be cot pi x by 2, right? Now if you substitute x equal to 1 in numerator and denominator, you are going to get here as 1 minus 1 as 0, and then cot pi x is 0, cot x pi by 2. In the sense, if you substitute x equal to 1, you are going to get cot pi by 2, which means in numerator and denominator, both of them you are going to get 0. So 0 by 0 form, so you can differentiate it, numerator and denominator, by L'Hospital rule. So what do I get here? If I differentiate it, I am going to get 1. If I differentiate it, see, d by dx of cot x is cosecant square x, but since pi by 2 is here, I am going to multiply with pi by 2. Got it? Okay. And now I have taken this 2 to the numerator. See this, minus 2 pi into 1 by cosecant square pi by 2, right? Now you can directly substitute x equal to 1 there, and you know that cosecant pi by 2 is 1. So this entire factor is going to be 1. So the answer is minus pi by 2. Got it? Okay. Now let's see some examples on this form, 0 power 0 form. So whenever the question is in 0 power 0, we have to try to change it either into 0 by 0 or infinity by infinity. Let's see how to do that. Limit x tends to 0, x power x. Now if you try to substitute in place of x 0, you are going to get 0 power 0. So now we have to convert it either into 0 by 0 form or infinity by infinity form. How to do it is, we can assume that this entire factor x power x, this entire expression, as equal to a single expression y. So I am just equating y equal to this. I am just assuming y be equal to that. Now apply log on both sides. So why am I trying to do this is, I don't want to deal with 0 power 0, I want to deal with either 0 by 0 or infinity by infinity. So by applying log, I will be avoiding that exponential form. So now I got x into log x, right? Now try to apply logarithm on both sides. Sorry, limit x tends to 0 on both sides. When you try to apply limit x tends to 0 on both the sides, you will see that limit x tends to 0, log y is there on the left hand side. Now since there is no term like x, whenever you apply limit x tends to 0, with respect to this limit, this entire factor will be a constant. Therefore you need not apply limit to this. So, or you can also say that limit x tends to 0, log y is simply log y. So from this, see, I have applied log on both sides, and then I have applied limit on both sides, and now I am trying to replace this entire expression with this expression, because it doesn't make any difference, okay? And next one is, now here it is limit x tends to 0, x log x is there. I can take this x to denominator. Why am I taking this x to denominator is, if you observe it, it is in the form of 0 into infinity. Log 0 is infinity. So 0 into infinity is there. Again I told you that whenever it is in 0 into infinity form, you try to convert it to either 0 by 0 or infinity by infinity form, right? Therefore I am going to take this x to denominator. Then I am going to get it as 1 by x, right? Okay. Now if you observe it, limit x tends to 0, log x is infinity, and limit x tends to 0, 1 by x is infinity. Now we are again in infinity by infinity form. Whenever you have this form, you can apply L'Hospital rule. So what does it mean? Differentiate numerator and denominator with respect to x. So I am differentiating numerator and denominator with respect to x. Log x means you get 1 by x, and d by dx of 1 by x is nothing but minus 1 by x square. So you are going to get limit x tends to 0, x square by x, which means minus x you got. Now you apply limit x tends to 0, you got 0. Now what is 0? Log y is equal to 0. It is not this one. This entire factor is not equal to 0. Log y equal to 0. Therefore, what can be y? If log y equal to 0, then y is e power 0, which means 1, right? Now we came to know that y is this. So initially what did we do? We assumed that x power x is y, and now we found out that y is equal to 1. That is what we found out finally, right? Therefore, when I try to apply limit x tends to 0, x power x, it is nothing but limit x tends to 0, 1, isn't it? Limit x tends to 0, x power x equal to limit x tends to 0, x equal to limit x tends to 0, 1, isn't it? So which is nothing but 1. Therefore this entire value becomes 1. This is where you should be a bit careful. What did we do? We have equated y to be this, right? And therefore x power x is equal to y, and this y value turned out to be 1. Now we apply limit x tends to 0 on all the sides. Limit x tends to 0, x power x equal to limit x tends to 0, y equal to limit x tends to 0, 1, which is equal to simply 1. Got it? Okay. Now let's look at the second example of the same form. Limit x tends to 0, x power sin x. Again, when you substitute x equal to 0 here, you are going to get 0, and here x equal to 0, you are going to get 0 power 0. Again, it is in the form of 0 power 0. We want to convert it into either 0 by 0 or infinity by infinity form. For that reason, let us assume that y equal to x power sin x. Now you try to apply logarithm on both the sides, then log y equal to sin x into log x, right? Then you apply limit x tends to 0 on both the sides. Okay, now if you observe it again, for the same logic I explained there, limit x tends to 0 log y is simply log y. What is the reason? There is no x term there to apply the limits. Okay, now in the right hand side, limit x tends to 0 sin x into log x is applied. If you again see it, it is going to be sin 0 means 0 and log x means infinity. Again it is in the form of 0 by infinity form. Just try to convert it into form of infinity by or 0 by 0 form. So for that reason I am going to take sin x to denominator. If I take sin x to denominator, it is going to be cosecant x. Now if you see it, it is in the form of infinity by infinity because cosecant 0 is infinity. So infinity by infinity form. Now again apply L'Hospital rule. Then what do we get? Differentiate numerator and denominator with respect to x. Here I get 1 by x, and cosecant x is nothing but d by dx of cosecant x is minus cosecant x cot x, right? Minus cosecant x cot x. Okay. Now you can take these two to the numerator. Then cosecant x will become sin x and cot x will become tan x, right? And in the denominator there is going to be x. Now you can take these two factors together, tan x by x, and there is limit x tends to 0. Now this entire factor will become 1, and what will remain? Limit x tends to 0 sin x. Now what is limit sin x? Limit x tends to 0 sin x? 0. Therefore this entire factor will become 0. Now what is 0? Log y is equal to 0. Why log y? I already told you that this entire thing is log y. So log y equal to 0. Now what does it mean? Y equal to 1. What is actually y? Y is x power sin x, isn't it? Therefore we are already seen that x power sin x is equal to y is equal to 1, isn't it? This is what we got. Now apply limit x tends to 0 for all these. So limit x tends to 0 x power sin x is equal to limit x tends to 0 y, and that is equal to limit x tends to 0 1. Now what is limit x tends to 0 1? It is simply 1. Why? There is no factor of x there. Got it? So the answer for that one is y. So this entire factor, this entire limit is equal to 1. Got it? Okay. Now whenever you get 1 power infinity form, then you can use this formula. So limit x tends to infinity if there is a function f of x raised to the function g, power of g of x, and now if you are getting 1 power infinity, if I substitute in place of x a value of a, then you can directly use this formula. So what is the formula is, you have to take everything to the power of e power limit x tends to a g of x into f of x minus 1, this f of x. Okay, with examples it will be clear. Just say this. Now if I apply limit x tends to infinity, x plus 6 by x plus 1 whole to the power x plus 4. Now if you see that it is in the form of f of x to the power g of x Now we should test whether it is in the form of 1 power infinity or not. See, you cannot apply this formula to everything. Only whenever you get 1 power infinity you can apply it. Now in order to test it, see this, can I make this one as 1? Yes, when limit x tends to infinity. So you pull out x as common, I am going to get 1 plus 6 by x, 1 plus 1 by x. Now 6 by x and 1 by x will become zeros, therefore you are going to get 1 here. And what about this? You are going to get infinity. So I got 1 power infinity form. Now I am going to use this formula, right? So limit x tends to infinity is going to be e power, see this, it is going to be e power limit x tends to infinity g of x. So what is g of x in this case? X plus 4, right? See, this is going to be g of x and this is going to be f of x, right? So this is going to be g of x into f of x minus 1, right? So g of x into f of x minus 1 means you can just simplify it and you get 5 by x plus 1, right? Now I can pull out this 5 outside, see this 5 is written here, and now what is remaining? X plus 4 by x plus 1 is remaining. Now since it is limit x tends to infinity, I can pull out x in both the numerator and denominator, which means I am just dividing numerator and denominator by x. Here I will be getting 4 by x and here I will be getting 1 by x, right? If I substitute infinity in those two places, 4 by x and 1 by x, I will be getting 0 and 0. Therefore it is 1 by 1, right? So it is going to be e power 5. E power 5 into 1 plus 0, so it is going to be e power 5. Got it? Okay. Now exactly the same model is this. So whenever you are going to get limit x tends to something, g of x power f of x or f of x power g of x in this case, it need not be 0 or infinity always. Overall you are supposed to get 1 power infinity in order to apply this form. Okay. So see this, in the earlier case it is limit x tends to infinity, but in this case it is limit x tends to 0, but still it is in the form of f of x power g of x. We shall check whether it is going to give us 1 power infinity form or not. Now if you see this is entire thing is limit x tends to 0 sin x by x, which is going to give us 1. But then if you see this one, limit x tends to 0, when you apply it directly, it might not seem like it is infinity. You might see that it is 0, sin x is 0, 0 and 0. You might think that it is 0 by 0, but if you can rearrange the terms, you can see definitely infinity there. So how can I rearrange it? You just divide numerator and denominator by sin x. Then I am going to get 1 here, and in the denominator I am going to get x by sin x minus 1, right? Now if you apply limit x tends to 0, sin x by x or x by sin x is going to be 1. So 1 by 1 minus 1, which means 1 by 0, which is infinity. Therefore it is still in the form of 1 power infinity, and so you can apply this formula, right? So what is that formula? E power limit x tends to 0. Why 0? Because here there is 0. Alright, limit x tends to 0, g of x into f of x minus 1. G of x means whatever is in the denominator, sorry, this exponentiation, you have to bring it forward, right? That is why I brought it here, and this one minus 1. Now if you just see this after simplification, here you have x minus sin x and here you have sin x minus x. You can cancel off these two, but then minus 1 has to be brought out. Yes, minus 1 is written here. Now what did you get? Sin x by x. So limit x tends to 0, sin x by x, you know it is 1. Therefore it is e power minus 1, which is 1 by e. So 1 by e is the answer for this one. Now similarly if you see this one, limit x tends to infinity, if you try to look at this, here if you substitute infinity, this entire factor is going to be infinity and this entire factor is going to be 0. So it is 1 plus 0 whole to the power, if you substitute in place of x infinity, it is going to be 1 power infinity, right? Okay, now you just see this is f of x, this is g of x. Now you take g of x here, and f of x minus 1 is going to give us this. Now it is simply cx plus d divided by ax plus b. Now you can okay, if you directly substitute x equal to infinity, you are again going to get infinity by infinity form. Either you apply L'Hospital's rule there, that way you are going to get c by a, or you just divide numerator and denominator with x, that is also going to give you the answer. So if I divide numerator and denominator by x, I am going to get c plus d by x, a plus b by x, right? Now in place of x, if you substitute infinity, I am going to get this entire factor as 0, this entire factor as 0, right? So you are going to get e power c by a. Okay, fine. Now let's look at the continuity of a function. So informally, what continuity of a function means, if you have a function like this, okay, and if you are looking at it at a point, now we say that at this point it is continuous if we don't have a hole there, which means if you have a hole there, then it is not actually continuous. Even if by looking at it you can find it out, isn't it? Or if a function is suddenly jumping at a point like this, from here it suddenly jumped here, right? Now it means that at that point it is not continuous, right? Or sometimes the function has just ended there, then it is not continuous at that point. Or a function has just begun there, then it is not continuous, right? So what continuous is, now when you are looking at it at a point, it should have exactly the same value if you look at it a point to the left of it, and if you look at it a point to the right of it, right? If it is not so, then it means that there is some irregularity, which means it is not smooth, right? If it is smooth, then generally you are going to see that both the sides at that point it is going to have the same values, right? So a function is said to be continuous at a point if it is going to be continuous and it is not going to have any hole or a cut or any jump like this. That is informal definition. Now let's look at formally how to define it. A function f of x is said to be continuous at x equal to a if limit extends to a, f of x equal to f of a. So what they are trying to say is, now let us say this is f of x, this is the function we are talking about, and now we are talking about a point a. At x equal to a, we want to see what is this function, whether it is continuous or not continuous. Now they are saying that you find out the value of this point, which is nothing but f of a, right? Now limit extends to a, f of a means as x approaches a, which means it is close to a, not a, right? Either from left side or right side, as we approach a, we should have the same value f of a, which means if that point is having some value both to the left of it and to the right of it, and at that point, and all these three values are actually same, then they are saying that it is continuous according to the formal definition, right? As we approach a, it should have the same value as what it had at a. Got it? Okay. Now this is one way, that is one way of saying it. Other way of saying it is left hand limit is equal to right hand limit equal to value of the function at x equal to a. Same thing. So either you take the left side of it or to the right side of it, or at that point. See, when I say left side of it, it is just you have to move it a small fraction to the left, a small fraction to the right, and check its value. Okay. So this is also written like this: limit extends to a minus a plus, left hand limit, right hand limit. If both of them are equal to f of a, then we can say that it is continuous. Now if a function f is not continuous at x equal to a, we say f of x is discontinuous, which means if these properties fail, then we can say that it is discontinuous at x equal to a. And again, we are going to talk about continuity or discontinuity given the function and a point, right? We are not going to say that a function is continuous or discontinuous without that point. Got it? So here we are talking about continuity or discontinuity at the point a. And next one is f of x will be discontinuous at x equal to a if left hand limit is not equal to right hand limit, which means if the left side I have some value and the right side if I have some value, if both are not equal, then I can say that it is not continuous, which means discontinuous. Or if left hand limit is equal to right hand limit but it is not equal to the value at a, right? Or if f of a is not defined, which means it can be either 0 by 0 or infinity by infinity. In that case also it is not continuous. Or at least one of the limit does not exist, which means either left hand limit or right hand limit, or the limit doesn't exist. If that is the case also, it is discontinuous, which means if any of these four conditions hold, either this one or this one or this one or this one, you can say that it is discontinuous. Okay, fine. Now let's see this question. F of x equal to x square minus 9 divided by x minus 3 when x is not equal to 3, and it is equal to 3 when x equal to 3. Now we are supposed to check the continuity at x equal to 3, which means we should say whether this function is continuous or not at a point. Now how to find it out? there are various definitions. According to the first definition, you can check this, right? So what is it? If you are talking about a point A, then you should check whether the function value at that point is equal to the limit extends to a f of x. You can check whether this is equal or not. If these two are equal, we can say that it is continuous. If these two are not equal, we can say that it is not continuous, right? So what is it? The function value at a point A and the function value as we approach the point A, right? So if we had to compare these 2 points. Now f of A is nothing but in this case f of 3, because that is the point we are looking at, and f of 3 is already given as 3. So from this, right, when x equal to 3, this value is 3, so I written as 3. Now what about the other one? Limit extends to 3 x square minus 9 by x minus 3. We have to find it out. Since it is going to be infinity by infinity form, right? See, if I put 3 there, it is going to be 0 by 0 form, right? It is going to be 0 by 0 form. So I am going to convert it to factorization. So what is factorization? I am just writing it like this, and then I can cancel out these two. Now it is no more in 0 by 0 form. Now we got x plus 3. Now limit extends to 3, x plus 3 is nothing but 6. Got it? Now if you observe it, one thing is we got f of a as 3, and other thing is limit a extends to a f of x as 6. Now these two are not equal. Now what can we say? This function is not continuous at x equal to 3, right? So this function is discontinuous at x equal to 3, which means it is not continuous. Okay, so discontinuous means it is not continuous at x equal to 3. Okay, fine. Let's see continuity at endpoints. So now till now we have been seeing what happens for a function at a point, so whether it is continuous or not. But now instead of talking about a point, we want to talk about an interval, whether the function is continuous at an interval or not. So what we did in the earlier videos was, now given a point, at this point we wanted to test whether it is continuous or not. For that reason, we have seen that if you say the value of the function is f of a at that point, let us say f of x, right, then we have found out the left hand limit, which means the function value at a point slightly to the left of it, and then we have found out the right hand limit, which means the function value at a point slightly to the right of it, right? And now if all these three values are equal, we said that the function was continuous. Now we wanted to see, what we want to see is whether the function is continuous over an interval, let's say a and b. So from a to b, we wanted to see whether the function is continuous or not. Let's say this is x and it is a function. Okay, now how to find it out is, a function is said to be continuous over this interval if it is continuous at all the points between them, as well as it is continuous at the endpoints. But coming to the endpoints, we need not worry whether it is continuous to the left of it, because it doesn't fall in that interval, right? So only thing we should be worried about is whether it is continuous to the right of the initial point and to the left of the final point, right? So which means we have to find out the value here, and that value should be equal to the value slightly to the right of it, and we should find out the value here, and that value should be equal to the point slightly to the left of it, right? Which means we are going to find out right hand limit at the initial point and left hand limit at the final point, as well as we have to check for the continuity over all the points between them. If you can say that this value is equal to the right hand limit and this value is equal to the left hand limit, and all the points at all the points it is continuous, we can say that the function is continuous over that range or the interval. Now see the definition. In an interval a comma b, f of x is said to be continuous if it satisfies the following three conditions. Now what are the three conditions? F of x is continuous for all x belongs to a comma b, which means between these 2 points a and b, f of x should be continuous. And the second point is, f of x should be right continuous at the initial point. What is initial point here? A, right? Now at this point it should be right continuous. So what is the meaning of it? We should find out the right hand limit and we should find out the value of the function. Now these two values should be equal. Then we can say that it is right continuous, right? And f of x should be left continuous at the final point, which means at this point we have to find out the left hand limit, and the left hand limit should be equal to the function value at that point. Got it? So we need to check these three. So what are the three conditions? For all points it should be continuous, and at the initial point it should be right continuous, at the final point it should be left continuous. Now let's take an example. If f of x equal to step x, where step x denotes greatest integral function, then check the continuity on 1 comma 2. So what is the meaning of step x is, if you have a value, let's say 1.5. Now 1.5 lies between two integers, one is 1 and other is 2. Now this value will be given as 1. For all the values between 1 and 2, the value of the function, the step function, will be 1, right? If you say 0.5, now 0.5 lies between 0 and 1, therefore its value will be given as 0, which means for all the values between 0 and 1, the function value will be 0. Now if you see why it is called step function is, it will be like looking like steps, right? So you can see this. For example, if you see this one in the graph, for all the values between 1 and 2, the value of the step function is going to be this one, 1, right? And for all the values between 2 and 3, the value of the step function is going to be like this, right? And for all the values between 0 and 1, the value of step function is going to be like this. So if you see this, it will be like steps, right? So that is why it is called as step function. And as you know, step function is not continuous over a long interval, because there are breaks, or there are holes. If you see it from here to here, it is directly jumping. Therefore, for a long range, it may not be continuous. But if you see this question, they are asking us to check whether it is continuous between 1 and 2, right? So how can I check it? There are three conditions I need to check. For all the values between 1 and 2, I should find out whether it is continuous or not. And then at the initial value, it should be right continuous, and at the final value, it should be left continuous, right? So let's see how to do it. First one is f of x equal to step x could be plotted as shown in the figure. That is where we have shown it. Now from the graph, f of x is continuous at all points 1 to 2. Now if you see this, from 1 to 2, between these two, it is definitely continuous, right? There are no holes or there are no jumps. It is a continuous straight line. Therefore, it is definitely continuous for all the points between 1 and 2. So condition 1 has been satisfied. Now what is condition 2? Condition 2 is nothing but we have to find out the right hand limit at the initial point, right? Now what is the right hand limit at here? See this. One thing is f of 1 equal to 1. From that we can see it. And the second thing is we have to find out the right hand limit at 1. So what is right hand limit means is just move to a point to slightly right of 1, which will be 1.00 something, right? Now when you move it, see this, limit extends to 1 plus f of x, you should find out, right? And if it is equal to f of a, then we can say that it is right continuous. Now limit extends to 1 plus step x is going to be f of 1, which is nothing but step of 1 plus something, right? So if you see this value is going to be step of, you can just assume that we are moving it slightly to the right, which means 0, 0, 0, 1 or something like this, right? Now if you see this value will definitely be in the range between 1 to 2, therefore its value is going to be 1. Got it? So we found out that f of 1 equal to 1, and also to slightly to the right of it, we found out the value is 1. Therefore, right hand limit is equal to the function value at 1. So we can say that it is continuous at 1, right? And similarly, we can find out what its left hand limit is, right? Okay. Now if you see the final point and the left hand limit at it, f of 2 equal to 2, and the left hand limit at x equal to 2 can be found out by limit extends to 2 minus step x, right? Now if you find out limit extends to 2 minus, it is going to be limit extends to 2 minus f of x, right? So we can see that limit extends to 2 minus f of x is not equal to f of 2, right? So we can say it is not continuous at x equal to 2. Got it? Okay. Now if you want to see why it is not continuous, look at the value of the function at x equal to 2. At x equal to 2, the value of the function is going to be 2. Now if you take a point which is slightly to the left of it, which means from 2 you have to subtract something, right? So if I subtract, let's say 0 point whatever value is 0, 0, 0, 0, even the least value, it is going to give me something like 1.999 something like this. Now this value is going to lie between 2 and 1, right? Therefore the step function of this value is going to be 1. got it? So for any value which is less than 2, slightly less than 2, the step function is going to give us 1, right? But the value of the function is 2 and the step function is 1, therefore it is not continuous, got it? Okay. Now this question can also be extended this way. Since we know that it is not continuous at 2, we can say that it is not continuous over the interval 1 comma 2, right? See, now we found out that it is not continuous over the interval 1 comma 2. The reason is at 2 it is not left continuous, right? So now what we could say is, if you just eliminate that point 2, right, it is failing only because of the value at 2, right? Now if you eliminate just the value 2, we can say that it is going to be continuous till this point, right? So from 1 inclusive 1 and excluding 2, whatever is between 1 and 2 without including 2, right, you can include 1. So this is closed and this is open. So from closed 1 to open 2, you can say that the function is continuous. But then when you close it, the function is not continuous. The reason is at 2 the function is actually jumping, right? Now at 2 the function has become 2 and to the left of it the function is 1. That is why we can say that it is failing at 2, but on the other points it is continuous, got it? Okay. Now let's see this question. If f of x equal to x plus 1 power cot x for x not equal to 0 and it is equal to k for x equal to 0, then we are supposed to find out whether it is continuous or not. Okay, it is already given, it is continuous at x equal to 0, then we have to find out the value of k, right? So what is it? Now they are saying that the function is given like this, and now they are saying that it is already continuous at x equal to 0, then we have to find out the value of k, right, where k is here. Okay, so now we can use the definition of continuity to solve this question. So when we know that it is continuous at x equal to 0, then we can say that the value of the function at x equal to 0 as well as the value of the function as limit x tends to 0, both are going to be equal, which means I can write it this way, isn't it? When we know that the function is continuous at x equal to a, then the value of the function at x equal to a as well as the value of the function as limit x tends to a, both are going to be equal, got it? Now from that I can write x equal to 0, a equal to 0, right? If I substitute a equal to 0, I am going to get this. Why? Because they said that it is continuous at 0. Okay, now we can directly see that by substituting f of x is nothing but this point, right? See, when x equal to 0, it is exactly equal to k, that is why f of 0 equal to k. But then as x approaches 0, what does limit x tends to 0 mean? It is approaching 0 but not exactly 0, right? Now we have to use this function. That is why here I am going to use this function, because x is approaching 0, it is not exactly 0, right? So I got this one. Now if you substitute here x equal to 0, I am going to get 1 power cot 0, and cot 0 is infinity, which means it is 1 power infinity form, right? Now whenever we get 1 power infinity, we know this formula. If we have limit x tends to a, f of x power g of x, if you find out that if I substitute x equal to a, if I find out that this value is going to be 1 power infinity, then we could write it this way. We could have written it as e power limit x tends to a g of x into f of x minus 1, right? Now in this case, just see what is f of x and g of x. Now f of x is going to be x plus 1 and g of x is going to be cot x, got it? Therefore you write it this way, e power limit x tends to 0, why a is 0, right? So e power limit x tends to 0, g of x. What is g of x? G of x is cot x. So g of x into f of x minus 1. So what is f of x? X plus 1 minus 1. Correct? Now you can see that it is cot x into x. Now cot x is also 1 by tan x. So we can write it as x by tan x. Limit x tends to 0, x by tan x. As we know, this value is 1. So why is this value 1? Because tan x by x is 1. So x by tan x is also going to be 1. Got it? So this entire value is going to be 1, and therefore we got e equal to k. The value of k is e. Got it? Okay. Let's see this question. if f of x equal to, now over this range they are giving the functions and the function is changing as the range is changing here. When x is less than or equal to 0, it is going to be 0, and between 0 and 1 it is going to be 5x minus 4. So if you see this, exactly when x equal to 0, we have to go here, right? Y less than or equal to 0 is written here. Now when it is between 0 and 1, 0 is exclusive, which means you are not going to talk about 0 again here, right? So then the function is going to be 5x minus 4, and till 1, which means 1 is included here only. So whenever you talk about what happens when x equal to 1, it is 5x minus 4. Now after that, which means from 1 to 2 excluding 1, right? Excluding 1 and excluding 2, the range is for that range the function is 4x square minus 3x, and again after 2 and including 2 the function is 3x plus 4, right? So only thing you should be careful about here is what happens to the function at a given point. Now when the point is 0, it is 0. When the point is 1, this is this one, right? And when the point is 2, it is this one. Got it? Okay. Now they are talking about this. What happens to the function when x equal to 0, when x equal to 1, and when x equal to 2? Which of the following statements is true? They are given 4 statements and they are asking us which of the following is true. So first one is saying that f of x is discontinuous at x equal to 0. So we have to find it out. So how can we find out? Find out the left hand limit and the right hand limit, as well as find out the value at x equal to 0. If all three are equal, then we can say that it is continuous, right? Otherwise it is discontinuous. And what about the next one? F of x is continuous at x equal to 1. Again you can do the same thing. Find out the left hand limit, right hand limit, and the value at that point. When all the three are equal, we can say that it is continuous. Otherwise it is discontinuous. Now what about the option C? F of x is left continuous at x equal to 2. Now they are talking about left continuity. How to check it? Left hand limit and the value at that point, right? So if you see this, 0, 1 and 2 are given. Now here also the function is exactly changing at 0, 1 and 2. Got it? So you have to use this function this way and you have to solve this. Okay, let's check about the option A. Now what is option A saying? They are talking about discontinuity at x equal to 0. That is what they are talking about, right? Now look at this. So if you see the function for x is less than or equal to 0, the function value is 0, right? And for x, whenever it is greater than 0, you can think of it this way, right? For x is 0 and 1, the function is 5x minus 4. This is given, right? So what does it mean? Whenever x is exactly 0, or if it's slightly less than 0, then the value is going to be 0. And whenever the x is slightly greater than 0, then we are going to come here and it is going to be 5 into 0 minus 4, which means it is going to be minus 4. Got it? So say this, left hand limit is nothing but when the x is slightly less than 0, right? So when x is slightly less than 0, which means limit extends to 0 minus slightly less than 0, f of x is nothing but 0, right? Why here? When x is less than or equal to 0, it is 0, right? What about the right hand limit? When x is slightly greater than 0, which means when x is slightly greater than 0, we are going to use this function, right? So in this function, when you are going to substitute x equal to 0, we are going to get minus 4, right? 5x minus 4, which means here you are supposed to substitute 0, then you are going to get minus 4, right? So slightly greater than 0, it is minus 4, and slightly less than 0, it is 0. So definitely it is not continuous. If it is continuous, then slightly less than 0, slightly greater than 0, and at that point it will all be same, right? Since it is not same, we can say that it is not continuous. Therefore f of x is discontinuous at x equal to 0 is true. Option A is true. Got it? Now since option A is true, generally you don't check other options, but then if you look at option D is given as all the above. Whenever you have all the above, you are supposed to check all the other options also. Now let's see option B. What happens to the function at x equal to 1? Now see this, let's see the solution here. At x equal to 1, now again we have to find out what its left limit is and what its right limit is. Now if you see there, they have given that the range is whenever x is less than or equal to 1, they are saying that the function value is 5x minus 4, and whenever x is slightly greater than 1, then they are saying that the function is 4x square minus 3x. Got it? Now let's try to find out left hand limit, right hand limit, and the value at x equal to 1. So first thing is left hand limit. Left hand limit means whenever x is slightly less than 1. So if x is slightly less than 1, you can see this range, right? When x is slightly less than 1, we are going to fall here. Therefore we have to use this function. Okay, so the function we are going to use is 5x minus 4, and in place of x I am going to substitute 1. I am going to get 1, right? And in order to find out the right hand limit, we have to find the function slightly greater than 1. So when the function is slightly greater than 1, I am going to fall in this range. Therefore the function we need to use is 4x square minus 3x, which means right hand limit at x equal to 1 is nothing but slightly greater than 1, right? So limit x tends to x plus f of x is nothing but this function, and in this function I am substituting x equal to 1. I am getting 1. Now in this case, if you observe it, f of this left hand limit is 1 and the right hand limit is 1, and also the function value at 1 is again this function only, right? And when you substitute x equal to 1 here, we are going to get 1. So all of these are going to be 1. So we can say that the function is continuous at 1. Got it? Y, left side, right side, and at that point everything is same. Got it? And so B is also same. Now see this, option B is same, right? And now coming to option C, f of x is left continuous at x equal to 2. So they are not asking about continuity, they are just asking about the left continuity, which means we have to check what happens to the function at a value slightly less than 2 and at the value x equal to 2. Now if these two are equal, we can say that from left side it is continuous, right? Now let's see this function. If you observe it, when it is slightly less than 2, the function that you should use is 4x square minus 3x, right? From 1 to 2, when it's slightly less than 2. Now when it is exactly equal to 2, the function that we should use is 3x plus 4. Got it? So these are the two functions we need to check their values at x equal to 2, and if they are equal, we can say that it is left continuous. Now come here is the solution. Now at option D, okay, so at option C, at x equal to 2, now if you see f of 2, the value of the function at the point 2, for this we are going to use 3x plus 4 function, right? So 3x plus 4 function is going to give me 10. Now I want to find out left hand limit, and at the left side, if you see that, if you remember that for the left side, a function is 4x square minus 3x, which means at a value slightly less than 2, we need to use this function, right? And in this place, if you substitute x equal to 2, I am getting 10. So what did you get here? The left side limit, the left hand limit, as well as the value of the function at 2, both are equal. So we can say that it is left continuous. So in this case, even if you try to find out the right hand limit also, you are going to get 10 only, right? So in this case, at 2 it is actually continuous, right? Anyway, the question is only about the left continuity. Yes, it is definitely left continuous. Even if you extend the question and find out whether it is continuous at 2 or not, you will get that it is continuous. Why? The right hand limit is also going to be equal to 10. You check it, okay? So all the three options are right here in this case. So what is the answer? The answer is all the above. Got it? Okay. Now let's look at examples on continuity. If f of x is given as a function which is mod x by x, and what is mod x? If you give a negative number inside it, it is going to give you a positive number, right? Mod x by x is that. Now is it continuous at x equal to 0? There are various ways of seeing it. One way is, if you directly substitute f of 0, if you find out f of 0, it is going to be 0 by 0, which means it doesn't exist, right? So whenever it is 0 by 0 or infinity by infinity, you can directly say that it doesn't exist, and you can say that it is not continuous. But then other way of doing it is find out the left hand limit and find out the right hand limit, and you see whether both of these are equal or not. If both of these are unequal, then you can say that they are not continuous, right? So let me find out left hand limit of this. So left hand limit at x equal to 0 is, in order to find out left hand limit, I am going to find it out at a minus h. If I am going to find the continuity at a, I have to take it at a minus h, right? So since I am taking it at 0, then I have to find out 0 minus h for a small value of h. Okay, so in place of x, if I substitute 0 minus h, I want to see what happens. Okay, so limit x tends to 0 minus f of x is nothing but limit h tends to 0 f of 0 minus h, which is nothing but in place of x I am going to substitute 0 minus h. And what is h? A small value. right? So in place of x, in this one I'm going to substitute 0 minus h and for a small value of h. Now what is it? 0 minus h divided by 0 minus h, but there is a mod here. So whenever I apply mod, and what is h? H is a small error which is positive, and minus h is negative, and therefore it is entirely converted to positive. See, whatever is inside it, outside it should be a positive number. Therefore mod of minus h is going to be h. H divided by minus h is minus 1. Therefore left hand limit happened to be minus 1. Now we shall find out what is right hand limit. So how to find it out? In place of x, substitute 0 plus h for a small value of h. So right hand limit extends to 0 plus f of x equal to, you have to substitute in place of x 0 plus h. So why 0 plus h? Because we are talking about a point 0, right? In case we are talking about here, you could have written it as a plus h, right, for a small value of h. Now what do we get? In place of that expression mod x by x, if you substitute 0 plus h in place of x, you are going to get this one. Now if you observe it, it is going to be h by h, and since h is already positive, we need not multiply with minus 1, so you are directly going to get it as h by h, which means 1. Now if you observe it, left hand limit and right hand limit both are different, both are not equal, right? So you can, here also you can say that this way it is not continuous. Either directly by getting 0 by 0 you could have said that, otherwise you could do this and say it, okay? So it is discontinuous. Now looking at this one, f of x is 2x plus 3 for x less than 3. Okay, one more thing here, if you want to see graphically what they mean by this. Now if you have x here and x here and f of x here, right? Now they are saying that if x is less than 0, see here I got this, right? Left hand limit is nothing but for x is less than 0, which means left side of the 0, the value is minus 1, which means here I am going to get the value as f of x value as minus 1, right? Yeah, here, right? And now for right hand side of 0, the value of f of x is plus 1, right? But then at 0 it is not defined, right? Which means there is a gap between these 2 points, right? Or if you see that there is a jump, right, suddenly, that is why it is not continuous. Now look at this one. If f of x equal to 2x plus 3 when x is less than 0, and f of x equal to 0 at x equal to 0, and f of x equal to x square plus 3 when x is greater than 0, then what is the value, whether it is continuous or not? How to find it out? Again, go with left hand limit and right hand limit, and they are talking about the point 0. Therefore while finding out left hand limit or right hand limit, we are going to substitute in place of x 0 plus h and 0 minus h, like that, okay? So now let's find out left hand limit at x equal to 0. So how to find it out? In place of x, you are going to substitute 0 minus h, isn't it? Because we want to find out at a point 0, therefore left hand limit is going to be at a point 0 minus h. So in this place, so at 0 minus h means it is less than 0. At less than 0 we are going to use this function. Got it? So in this function, in place of x, we are going to substitute 0 minus h. In this function, in place of x, I am going to substitute 0 minus h. So I got this, right? And now, so I got minus 2h and 3 plus 3, and this x is so small that I have to substitute 0 in place of h. Limit h tends to 0, then I am going to get 3 here. Therefore to the left side of it we got a value of 3. Now let's see what we get at the right side of it. At the right side means, right side of 0 is nothing but greater than 0, we have to use this function, right? Okay, at the right side of it we have to deal with x at a point 0, therefore in place of x you are going to substitute 0 plus h. Got it? So in place of h we are going to substitute 0 plus h. So 0 plus h whole square plus 3. Now limit h tends to 0. If you substitute it, then you are going to get again 3 here. So left hand limit equal to right hand limit, both are equal to 3, but it is not equal to f of 0, right? So according to the definition, again we are going to see that it is not continuous. Got it? So why is it not continuous is, if you observe it, if you see 2x plus 3, 2x plus 3 is going to be something like this. If you say f of x, and if you have x like this, 2x plus 3 is going to be some line like this, okay, and this is going to be 3, and now x square plus 3 is going to be a line like this. Right now if you observe it, they are saying that to the left of 0 the value is 3 and to the right of 0 the value is 3, but then at the point equal to 0 the value is 0. So if you see this, it is suddenly falling down and again jumping there. Got it? From 3 to the left of 0, at 0 it is falling down to 0 and again it is jumping down to plus 3, again it is going that way, right? Therefore it is not defined, or you can say it is not continuous. Okay, fine. Till now we have seen about continuous, so whether a function is continuous over a range or not. Now if we don't have any holes or jumps in a function, we said that the function is continuous. Now let's look at what is differentiability. So coming to differentiability, here we need to know whether the function is smooth or not. So what do I mean by smooth or not is, if you look at this function, if you see this is definitely continuous. If you say from here to here, it is definitely continuous, right, over this range. And also if you see the way it is moving, it is smooth, right? But if you look at this one with a sharp edge, it is also continuous, right? But then it is not smooth. So how to find out whether it is smooth or not is, we are going to use a concept called as differentiability. So differentiability or derivative. So let's talk about derivative. So what is derivative of a slope of a function at a point is, if you are going to draw a tangent for that, let me draw one more. If you are going to draw a tangent, let's say this is the point, if you are going to draw the tangent for the function at that point, okay, now the slope of this particular, let's say this is the x-axis, if you say this angle is theta, then tan theta is nothing but the slope of the tangent for the function at this point, right? Now this one is also called as derivative. So what is the derivative of a function at a given point is, try to find out the tangent, and then you find out this tan theta. After writing out this tangent, you find out tan theta, that is nothing but the slope of it. Now the slope of the tangent is also called as the derivative, right? So a function will be smooth only when you have a unique tangent, right? And also it is going to have a finite value. So it should exist as well as it should be finite. Then only we can say that it is smooth. Otherwise it is not going to be smooth. For example, if you look at this point, right? Now for this one, at this point, if you ask me to draw a tangent, I can draw infinite number of tangents, right? So even this one is going to be a tangent. Any line passing through that is going to be a tangent, right? Therefore, even though the tangent is existing, they are not unique. So we can say that it is not smooth. Therefore, coming to differentiability, a function is said to be differentiable if it is going to be one, continuous, which means it should not have any holes or it should not have any jumps, and second point is there should not be any corner edges, right? So what do I mean by corner edge? Means a sharp edge like this, right? If it doesn't have it, we can say that whatever I told you just now is informal definition, right? So what is formal definition at this point is, see this. Now when can you say that the tangent is going to be unique for a function is, if you can see just to a point to the left of it, right? And if we can find out the tangent there, and if we can draw a tangent to the right of it, just to a point to the right of it, if all these tangents are same, then we can say that it is going to be unique. Otherwise we can draw infinite number, right? For example, if you see this point, if I draw tangent to just a point left of it, it is going to be this line, isn't it? If I draw tangent at a point to the just right of it, it is going to be this line, right? Therefore you are going to get many tangents there. So if the left side tangent and the right side tangent, and if the point at that point, if the tangent all of them are same, then we can say that it is differentiable or the point function is smooth. So whatever I said just now is informal way. Now let's look at the formal definition. Let's see this. Let f of x be a real valued function on an open interval a comma b, and there is a point c which belongs to this function, which means we are having a function which is defined over a comma b, and we are talking about a point which is between a and b, right? Then f of x is said to be differentiable or derivable at x equal to c if limit extends to c, f of x minus f of c divided by x minus c exists, and if it is finite. So what is the meaning of this one is, what they are trying to say by this expression is, let us say this is the function and assume that this is a point on the function, let's call it as c comma f of c, right? And let us assume that there is one more point which is a moving point, let's say this is x comma f of x, right? Now how can we draw a tangent to a curve? Now if you look at this chord, as this point moves towards this point, now that chord will become the tangent. Are you getting this? As this point move towards this point, so as I slowly move this, it is going to be like this. See, as I slowly move this, finally it is going to be a tangent. Got it? So as I move this point x close to c, whatever I get, that is nothing but the tangent, right? And now if you look at this line, the slope of this line is going to be y2 minus y1 divided by x2 minus x1, isn't it? So that is what is written, f of x minus f of c, y2 minus y1 divided by x2 minus x1. Now when is it going to be the slope of the tangent? So it is going to be slope of the tangent only when x is approaching close to c, which means as I move this point x towards this point c. So if you want to understand what extends here, let us say this is f of x and this is x-axis, right? So as I move this point x towards this point c, right, now that this line will become the slope, the tangent, and the slope of that line is going to be the slope of the tangent, which is nothing but the derivative, right? So see this one. So as I move this point x towards c, the slope of this line will become the slope of the tangent, right? Now if it exists and if it is finite, we can say that it is differentiable or derivable. This is one definition. Let's see one more definition also. Okay, one more is, this limit is derivative of f of x and it is denoted by f dash of c. So sometimes we can also write it as f dash of c, like this. Whatever this limit is, we can also write it as f dash of c. Okay, now one way of checking whether the function is derivable or not is the other way. See this, look at this condition. Now this condition is saying that necessary and sufficient conditions for a function to be derivable at a point is existence of the finite left hand derivative and finite right hand derivative and equality of both of them. So what we are trying to say by this point is, if you want to see that there is a unique tangent for a line, now let us say at a point C, just try to find out the tangent to a point to the right of it and to a point bit left of it. Now if all these three tangents are going to be same, or all of them are going to have almost the same slope, then we can say that it is going to have a unique tangent at that point with the unique slope, right? So that is the meaning of it, which means left side derivative and right side derivative, both of them have to be equal, right? So what is left hand derivative is, see this. Now if you are talking about a point C, we know that this is the slope of the tangent as x approaches c minus. So which means if you are talking about, let us say here there is a curve and here there is x, okay, now here there is c, right? Now we shall take a point to the left of c and we'll try to move this line, this point towards c minus. As we are moving this side, it is nothing but the slope of the tangent which is drawn at this point, isn't it? That is the meaning of it. So just move x towards c minus. Now whatever line you are going to get, that is nothing but the tangent drawn at this line, and whatever is the slope is nothing but the slope of the tangent to a point left of it. Now what about the other side? Okay, so this is nothing but moving this means c minus means we can substitute, we can subtract a small number h and we can substitute over there, right? In place of x you can substitute a small point. So say this, so c minus h, So what is that I am trying to do is, from C I am subtracting a small value so that it will move to the bit left. Got it? And here also from C I can substitute a small value and I can write it, which means C. X minus C, what we are trying to do is, from C I can subtract a small value and I can write it there, which is nothing but C minus H minus C. So which is going to give us minus H. Got it? Okay. Now similarly right hand derivative also works the same way. So what is it? We have to move the point X to a point just to the right of C. So that is why I am writing C plus H, right? So if you write C plus, now this is nothing but the slope of the tangent drawn at a point just to the right of C. Okay. Now that can also be done by writing in place of X C plus H. So which means I am just adding a small value to C so that it will move to a point to the right of it. Now that value is close to 0, right? Whatever value you are writing is close to 0. Here also whatever value you are writing is close to 0, right? Now you are going to add that H to C, and in the denominator also you are going to put C plus H, then you are going to get H here. Got it? F of X is differentiable at X if these two are equal. So one way to solve, see, this is one definition. Earlier whatever definition we have seen here, this is one definition. Using this we can find out whether a function is differentiable or not, but it is bit difficult to do it this way, and in most of the questions we are going to use this method because it is simple and it is easy to find out these two, right? Finding out whether a value is unique or not, it requires we need to find all the values, right? But instead of that, if we can find these two values and if they are equal, we can say that it is differentiable at that point. Got it? Okay. Please note this point. Every differentiable function is continuous, but a continuous function need not be differentiable. So what does it mean? If a function is continuous, right? Continuous means like this. Okay, so I'll just talk about the informal definition. So according to the informal definition, what did we see about continuity? There should be no jumps, right? As well as there should be no cuts, which means the holes, right? Now what about differentiability? Differentiability says that there should be no jumps and no cuts. No cuts means no holes, as well as the curve should be smooth, isn't it? Now if you observe it, if a function happens to be differentiable, then already there are no jumps and no cuts. Now what can you say? It means that it is continuous, right? But if a function happens to be continuous, then we know that there are no jumps and no cuts, but then we don't know whether it is smooth or not. Therefore every continuous function need not be differentiable, but if it is known that it is differentiable, it will definitely be continuous, right? Now if you want to see it in this Venn diagram form, then you can see it this way. If a function is differentiable, then it is both continuous as well as differentiable, which means if you think that this is the set of all differentiable functions and this is the set of all continuous functions, if a function falls here, which means if a function happens to be differentiable, then definitely it is going to be continuous. Now if a function falls here, it means that there is a function, I mean to say that there are some functions which will fall here, which means there are some functions which will be continuous but not differentiable. Now let's see one such example. So if you want to see any such example, if you have a graph like this for f of x, then continuous, it is definitely continuous because there are no cuts, there are no holes, but it is not differentiable because at this point, at this corner point, you cannot have a unique tangent, therefore the slope of the tangent is not going to be unique, right? So now if you look at this example, it is exactly that way. If you see f of x is going to be this way, right? So at this point definitely it will not be continuous, differentiable. It is definitely continuous but not differentiable. Now how to find it out? Find out the left derivative, find out the right derivative, and then see if they are equal or not. So according to the definition, what is the left derivative? Limit h tends to 0, f of 0 minus h minus f of 0 divided by minus h. Now 0 minus h is rare, so which is nothing but minus h. So in place of mod x, I am going to substitute mod minus x minus h minus 0 divided by minus h. So we know that since h is a small number which is positive, minus h is going to be negative. Therefore, in order to convert it back to positive, we are going to have h here. So it is going to be h by minus h, which means minus 1. See, only thing about mod x that you should be remembering is, once you remove mod x, whatever result you get, that should be a positive number, right? And since h is a positive number, see, h is a small difference that we are seeing, right? That we are taking in all the cases, right? So h is always positive. Wherever we use h in these limits, h is always positive, right? Whenever we say limit h tends to 0. Now, since h is positive, minus h is going to be negative. Now, after applying the mod, output should be positive. That is why it is h by minus h, which is minus 1. Now the right hand limit is limit h tends to 0, f of 0 plus h minus f of 0 by h. Now it is going to be limit h tends to 0 mod h divided by h. Since h is positive, even if you remove this mod, you are going to get h only, right? H by h equal to 1. So if you observe it, left side derivative is going to be minus 1 and right side derivative is going to be plus 1. So both are not equal, and you can say that it is not differentiable or derivable at that point. At what point? 0. So that is what, at 0 only we are talking about it. Now one more thing, one other shortcut you could use is, but this shortcut can be applied only when a function is continuous. If you know that a function is continuous, then you can use this shortcut. So what is the shortcut is, find out directly f dash of x. Okay, now once you find out f dash of x, then you can find out what its value is at a minus and a plus. If these two are equal, we can say that the function is differentiable or derivable at this point a. Otherwise it is not differentiable or derivable at that point, right? So now for this example, what you could do is find out f dash of x. So what is f dash of x? If f of x equal to mod x, f dash of x is going to be mod x by x. This is f dash of x. Right, now we are talking about 0 at a point 0. So you are supposed to find out f dash of 0 minus, f dash of 0 minus, right, and then f dash of 0 plus. Now what is f dash of 0 minus? The value of this function at a negative number, right? So whenever I give negative x, if x is negative, then output is going to be minus x, isn't it? Minus x by x is going to be minus 1. Are you getting this? So whenever I say f dash of 0 minus, it means that I am substituting a value which is less than 0, which means I am substituting a negative number here. Now whenever I substitute a negative number, then what will be the mod x value? So since inside number is negative, you have to multiply it with minus 1 when you remove it, because the total number has to be positive, right? So therefore when you multiply it with minus 1, this value is going to be minus x by x, which means here it is going to be minus 1. Now what about f dash of 0 plus? F dash of 0 plus means here you are going to substitute in place of x a positive number. So whenever you substitute a positive number, you can directly remove the mod without using any sign, right? Therefore it is going to be x by x, which means it is going to be 1, right? So these two are not equal. Here also you can say it this way. If you didn't understand what I told you here, you could also write it this way. See, since f dash of x equal to mod x by x, then you could write it as if it is f dash of x equal to, now what happens when x is less than 0 and what happens when x is greater than 0. You can write it like this and you can evaluate it. Now if x is less than 0, what happens? Since it is x is a negative number, isn't it? Now you have to multiply it with minus 1. If you remove this mod, then you have to multiply with minus 1 so that the entire number is going to be positive after you remove it, right? Then what happens? Minus x by x, which means minus 1 here. Now what about the other side? If you substitute x a positive number, if you are going to put x equal to some positive, then it is going to be directly x. Mod x is going to be x. So in that case it is going to be 1, right? So even by this you can even show that minus 1 and 1 are there, so not equal. So you can say that it is not differentiable. Got it? So this is an example of a function which is continuous but not differentiable. So why did it happen? Because of this. because of this corner point. You are talking about what happens at the corner point. Got it? And now which means the function falls here. There are functions, there will be functions which are continuous, as which are not differentiable, but then you will not be able to find any function which is differentiable but not continuous, right? So remember this theory point. Okay, fine. Now let's see this question. Let f of x equal to x into mod x for x belongs to real numbers, then f of x at x equal to 0 is. So they are talking about the point x equal to 0 and they are given us the function, and now the options are continuous, differentiable, continuous, not differentiable, differentiable but not continuous, neither differentiable nor continuous. See, directly by looking at it, you can eliminate option C, isn't it? Why? There cannot be any function which is differentiable but not continuous, isn't it? So you can use this diagram. Now if this is the set of all differential functions which are differentiable, and if this is set of all continuous functions, there cannot be any function which is differentiable which is not continuous, right? Therefore you can directly eliminate it. Okay, now what about option A? Can a function be both continuous and differentiable? Yes, right? So examples are here, all the functions which fall here. Now can a function be continuous and not differentiable? Yes, examples are all functions which fall here. It can be continuous but not differentiable, right? Can a function be neither differentiable nor continuous? Yes, because the set of all functions is not just set of all continuous functions. If you say this is set of all functions, right, there can be some functions which are neither continuous nor differentiable, right? And now one more thing, while going for this, if you find out that, see, let us say answer is D, then how could you know that where to stop the solution is, once you find out that a function is not continuous, there you can stop it and say that it is neither differentiable nor continuous. You need not go and check whether it is differentiable or not. Why? If the function happens to be not continuous, then definitely it is not differentiable also, right? You need not go and check for it again. Got it? So option C is not possible, and in case if the answer would have been option D, then it turns out that the continuous function is not continuous. You can stop the solution there, right? So that is how you can solve these questions. Let's go in and go and see this function first. Now f of x equal to x into mod x is given. We have to find out whether it is continuous or not, right, at a point 0. So we want to know how the function behaves when x is less than 0, when x is greater than 0, and when x is equal to 0. Why? Because we are interested in finding out the left hand limit and the right hand limit and the value of the function at that point. Now if you observe it, at x is less than 0, what happens to this? When x is less than 0, right, then if x is a negative number, you can assume that x is a negative number. If I remove this mod, the output should be a positive number, isn't it? If x is negative, if I remove this mod, if the output has to be positive number, you have to multiply it with -1. Therefore, when x is less than 0, you have to multiply this x with -1 if you are going to remove this mod. In that case, it is going to be minus x square. Got it? That is why when x is less than 0, it is going to be minus x square. Now when x is greater than 0, which means x is positive number, now if you remove this, then you need not multiply with any negative sign. The reason is, if I remove this, the number is going to be positive only. Only thing you should remember is, whenever I remove this mod sign, the result whatever you get should be a positive number, right? In case if this is a negative number, multiply with -1. In case if it is a positive number, leave it as it is, right? Since x is greater than 0 means x is a positive number. If I remove this mod sign, just leave it as it is. That is why when x is greater than 0, it is going to be x square only. Now what happens when x equal to 0? It is going to be 0, right? Okay. Now if you observe it, we have to find out the left hand limit. Now what is left hand limit? Left hand limit means what happens to the function when the value is just less than 0. When the value is just less than 0, this is the function which you are going to use. So left hand limit is nothing but limit x tends to 0 minus x square. Why minus x square? Because we are talking about a point which is just to the left of it, which means left of 0 means negative number. So I am using this one. Now you are going to substitute in place of x as 0. So it is going to be 0. Now what about right hand limit? I am talking about a point where that point is just to the right of 0, which means a positive number. So whenever x is positive, the function is going to be x square, right? So x square I am going to use here. Anyway, when you substitute in place of x0, this one is going to be 0 and this one is going to be 0, and also the value at x equal to 0 is going to be 0 already, right? Because of this 0, irrespective of what happens here, when you substitute 0 here, it is entire thing is going to be 0, right? So all these three are equal. Left hand limit is equal to right hand limit is equal to f of 0. So we can say that the function is continuous. Now we found out the function is continuous. Can we stop the solution here? No. The reason is there can be functions which can be continuous but which are not differentiable, which means now it is, since it is continuous, a or b both are equally probable. We don't know which one it is, right? Now as we have already seen that it is continuous, we can apply that shortcut. What is it? When a function is continuous, you can find out f dash of x and then f dash of a minus and a plus. If you can find it out, you can directly solve it. So what I mean to say is, in order to find out the differentiability, you need not go and find out left derivative and right derivative and find the values. That is a long method, right? Since it is already continuous, just find out what is f dash of x. Now here if you find out f dash of x, it is going to be mod x plus mod x, which means you are going to get 2 into mod x. This is what you are going to get as f dash of x for this one, right? Now try to find out what the value of f dash at 0 minus, this is nothing but the left hand limit, and try to find out what the value of f dash at 0 plus, which is nothing but right hand derivative. Sorry, it is left hand derivative and it is right hand derivative. Left derivative and right derivative, we have to find these two. Now how to find these two is, find out what will be this function when it is less than 0, x is less than 0, and find out what this function when it is greater than 0. So you can write it this way: f dash of x is equal to, when x is less than 0. So what does it mean? If x is negative, if I remove this mod sign, then the result has to be positive. That is why you are going to multiply with minus 1. Therefore it is going to be minus 2x, right? Now what happens when x is positive? When x is positive, if x is positive, now if you remove this mod sign, the output is also going to be positive. Therefore let it be 2x only. Got it? Okay. Now if you have to find out the value of f dash of x at 0 minus, you are going to use this function. In this function you are going to substitute at x equal to 0, right? So what will you get? 0. Now if you have to find this value at at a positive value, which means 0 plus, then you have to use this function, and in place of x you have to substitute 0. Anyway you are going to get 0. Therefore since these two are equal, we can say that it is differentiable. So that is a shortcut. Since I explained you, it might have taken some time, but if you do it, it is going to be a shortcut really. So this is going to be continuous and differentiable. Now even though we have seen the shortcut, let's see the actual method also, because there will be some functions which you might not be sure whether they are continuous or not. If you are directly doing without checking for continuity, then you might have to follow this method, right? So what is it? Now left derivative is going to be limit h tends to 0 minus f of 0 minus h minus f of 0 divided by minus h. It is going to be minus h square. So see this. Why minus h square is, you are going to substitute in place of x minus h. So minus h into mod minus h. We know that h is a positive number, which is a small positive number, right? So now if you substitute h a positive number, you are going to have, let's say h is a small number which is close to 0, right? We need not write h 0 minus and 0 plus. Okay, now if you see this, h is a positive number which is close to 0. Now if you write like this, f of 0 minus h, which means in place of x you are supposed to substitute minus h. So here if I substitute minus h, it is going to be minus h into mod minus h. Mod minus h is going to be h only, and outside there is minus h, therefore minus h into h is going to be minus h square. So you got minus h square, right? And f of 0 is, we already know it is 0, divided by minus h. so which is going to be h, and since limit h tends to 0 is there, which means in place of h you are supposed to substitute 0, you are going to get 0 in the output, right? So therefore the left side derivative, the left derivative is going to be 0. Now what about right derivative? In right derivative, limit h tends to 0, f of 0 plus h minus f of 0 divided by h. Now h is a positive number, and if you substitute h here, it is going to be h into mod h. So since h is positive, you need not multiply with minus number, right? So it is going to be h square only. So h square by h, which is nothing but h, and since there is limit h tends to 0, in place of h if you substitute 0, the output is going to be 0. So the left derivative and right derivative both are equal to 0. Got it? Therefore you can also say that by this method also you can say that it is differentiable at 0. So when to use this shortcut and when to use this method is whenever you know that the function is already continuous, then you can go for the shortcut. Now if you are not comfortable with this method, and if you always want to use this method, so be sure that before applying this method, find out whether the function is continuous or not. It must be simple, and after that you apply this method if it is continuous. If it is not continuous, then you can there only you can say that the function is not differentiable as well. Are you getting this? So what is the simple method is find out whether the function is continuous or not, right? Now see, even though the question is asked about differentiability, you can do it this way. Find out whether the function is continuous or not. If it is continuous, if it is not continuous. In case if it is not continuous, then you can say that it is not differentiable also. In case if it is continuous, then you can apply shortcut, and you can find out whether it is differentiable or not. Got it? Okay. Otherwise, if you directly want to find out about differentiability or derivability without talking about continuity, then you can directly use this method without worrying about whether it is continuous or not. That is up to you. Okay, fine. Now let's see this. A function is given, f of x equal to 1 by 1 plus mod x. Check the differentiability at x equal to 0. So if they are asking only about differentiability, you can directly go and find out left derivative and right derivative, and you see whether they are equal or not. That is one method. What is the other method? Find out whether it is continuous or not, and then you can apply the f dash x method. So let's see the simple method first. Okay, see which one is simple, that depends on whether it is easy to differentiate the function or not. So let's see this one. F of x equal to 1 plus mod x is the function given. Now in order to find out whether it is differentiable at x equal to 0, we have to find out how the function is behaving at a point x and left to the x and right to the x, right, at a point 0. So here we are talking about at point x equal to 0. So at the point 0, left to 0 and right to 0. Now see this, if we talk about the function at a point left to 0, so left to 0 means we are talking about negative numbers, which means this x is negative. So whenever x is negative, if you are going to remove this mod, then it is going to be minus, isn't it? Whenever x is 0, negative number, and if you are going to remove this mod, it is going to be minus x, which means 1 by 1 minus x. Now whenever x is a positive number, if you are going to remove this mod, then it is going to be plus x only. So this is what? 1 plus x when x is positive number. When x is negative number, it is minus x. When x is positive number, it is plus x, right? And what happens when x equal to 0? If you substitute x equal to 0, it is going to be 1 only. Okay, now we got how the function is behaving at 0 and around 0. Okay, now let's try to find out what is left derivative and right derivative. So left derivative is limit h tends to 0, where h is a small positive number, limit h tends to 0, 1 by 1 minus, which means, see, whenever you are talking about left derivative, you are talking about this function as f of 0 minus h, which means f of minus h, which means a negative number, right? Why? Because h is a small positive number, minus h is going to be a negative number. So whenever you are talking about negative number, you are supposed to use this function. Now I am going to use this function. In that function, in place of x, I am going to substitute minus h. So I am going to get 1 plus h here. 1 plus h minus 1 divided by minus x minus h. It is going to be 1. Okay, so why is it 1 is? These two are going to get cancelled out, and minus minus is going to become plus, and then if you substitute h equal to 0, you are going to get 1. Now what about right derivative? In right derivative, you are going to put here as f of 0 plus h, and h is a small positive number, as you know. Now since h is a small positive number, f of 0 plus h is going to be a positive. So plus h means a positive number, therefore you are supposed to use this function. Now if I am going to use this function, it is going to be 1 by 1 plus h minus 1 divided by h. Now if you find it out, here you are going to get minus h and h, these two are going to get cancelled, and if you substitute in place of h 0, you are going to get minus 1. Now left derivative and right derivative both are not equal, therefore you can say that it is not derivable at that point, right, at that point 0. Now if you want to use the other method that we have discussed last in the earlier example, what is the other method? Check whether it is continuous or not. So what is continuous? Check whether the left hand limit is equal to right hand limit is equal to the value. Now what will be left hand limit? Left hand limit means what happens to the value to a point to the left of 0. To the left of 0, this is the function, right? Now at this point, if you substitute x equal to 0, you are going to get 1, which means left hand limit equal to 1. What happens to the function at the right side? Right side is this one, right of 0 is this one, right? Now at that point, if x equal to 0, if you substitute it, it is going to be 1 by 1, again it is going to be 1. It is 1, it is 1 and it is 1. So you can say that it is continuous, right? So whenever you say that it is continuous, if it is not continuous, then it is not differentiable also. If it is continuous, you can apply the shortcut. So what is the shortcut? Just find out f dash of x. If you try to find out f dash of x is going to be 1 by 1 plus mod x whole square into mod x by x. This is what you found out. Now find out the left derivative and right derivative. So left derivative means f dash of 0 minus, right derivative means f dash of 0 plus. Now what does it mean? If you substitute a negative number in place of x, what happens? Now if I substitute a negative number in place of x, mod x is going to become minus x. Therefore it is going to be 1 by 1 minus x whole square into minus x by x is going to be minus 1. Therefore it is minus 1 by 1 plus 1 minus x square. Now in this place of x, if you substitute 0, you are going to get minus 1 if you substitute 0. Therefore left side left derivative we got it as minus 1. Now let's try to find out right derivative. So what will be the right derivative? Right derivative is going to be 1 by 1 plus, I think here we got 1 by 1 plus mod x. Acha. So 1 by 1 plus mod x into this one you are going to get. So why is it? Because this has to be written as 1 plus mod x whole power minus 1. Now when you differentiate it, you are going to get minus 1 in the beginning, right? So if you get minus here, you are going to get plus 1. Okay. Now if you see this, it is going to be, if it is a positive number, 0 is a positive, 0 plus means a positive number. If you substitute a positive number, it is going to be 1 plus positive number. So there is no need of multiplying with minus, because even if you remove the mod, it is going to be a positive number whole square into minus. Now what about mod x? Again, since you are if you remove this, it has to be positive, leave it as x only. So x by x, which means it is going to be minus 1, right? Now if you substitute x equal to 0 here, it is going to be minus 1. Now we found out that left derivative is plus 1 and right derivative is minus 1. Here also you can say that it is not differentiable. See, in this case, it is better that you go with this method, because finding out the derivation, this f dash of x is bit difficult, and again you have to do this, right? So going with that method might be easy for this example. So based on the example, you can choose the method. If the example is simple that you can find out the differentiate f dash x easily, then find out whether the function is continuous or not. In case if it is continuous, then go with the f dash of x method. Otherwise, go with this method. Okay, fine. Now let's see this example. Let f of x equal to mod x minus 1 plus mod x plus 1. Discuss the continuity and differentiability of the function. That is what is given. So this is the part of the solution. So first of all, whenever such functions are given, you can see that the functions are of form mod x, it is a combination of two functions. One is mod x minus 1 and the other is mod x plus 1. So if you try to look at the graph for mod x minus 1, you will see that it is going to look something like this. At a point 1, it is going to have something like this. Okay, which means at a point 1 there is a corner point for this. Now if you look at this one, mod x plus 1, then at a point minus 1, it is going to have when x equal to minus 1, it is going to have a corner point. Therefore, it is clear that if you have to check whether it is differentiable or not, you have to find out the left derivative and the right derivative at these points minus 1 and 1. Got it? Then only you can go ahead with that. So that is why I am trying to find out how the function is behaving to the left of minus 1, to the right of minus 1, to the left of 1 and to the right of 1. Right? So let's see what their values are. Now f of x to the left of minus 1, what happens to this? Now to the left of minus 1 means you can assume that this number is less than minus 1. You can say the number is minus 1.5. Now if you take the value minus 1.5 and you substitute here, it is going to be minus 1.5 minus 1, which means minus 2.5, which means the total number is negative. Since the total number is going to be negative, in order to convert into positive, if you remove this mod, then you have to multiply with minus 1. That is why I am multiplying with minus 1. Got it? And now if you substitute again minus 1.5 here, again this number is also going to be negative. In order to make it positive, you are supposed to multiply this with minus 1. Now you are multiplying with minus 1. So minus 1 here and minus 1 here. Got it? And what about between minus 1 and 1? You can take any example. Let's say you are taking 0. Now if you take 0 here, it is going to be a negative number. Therefore multiply with minus 1. And if you take 0, it is going to be a positive number. So leave it as it is. Got it? And then to the greater than 1, to the right of 1, let's say you are taking a number 2. If you take a number 2, it is going to be positive, it is going to be positive, so leave them as it is. So this is how the function is behaving. I mean, when I join these two functions, they are behaving this way. Now if you simplify them, you are going to get this minus x, which means minus 2x, right? And plus 1 minus 1, they are going to get cancelled away. And what about here? Minus x plus x, they are going to cancel away, and 2, 1 and 1, which means 2. And what about this? 2x. Got it? So I got minus 2x, 2 and 2x for this. So which means if you try to draw it in a graph, you are going to see something like this. From minus 1 to 1, the value of it is going to be 2. Right? So which means you are going to see the graph something like this. And less than minus 1, it is going to be minus 2x. And greater than 1, it is going to be 2x. So again, if you see this, the corner points are here only, right? So whenever you have any such corner points, right, or these are also called as kind of vertices, right, edges. So now whenever you have the sharp edges or the corner points, there is a chance that the function may not be differentiable at that point. See, one thing is definitely it is continuous. You can see that there are no gaps or there are no jumps. Therefore, it is definitely continuous, but it is not. It may not be differentiable. We have to check it, right? So, what are the various methods you can check it is? One simple method is, since we know that it is clear, right? From here it is continuous. Or if you want to check whether it is continuous or not, you can check it. So, how to find out whether it is continuous or not? You go to this point minus 1. Find out the left limit. So, what is the left limit? To a point just to the left of it. Now what about this? It is going to be minus 2x, isn't it? See, I am talking about this value, this function, this entire function at a point to the left of minus 1. Now it happens to be minus 2x, right? Now what is minus 2x value at x equal to minus 1? It is going to be 2, right? Or if you want to find it, you can find it this way. I am talking about left hand limit at x equal to minus 1, right, which is nothing but limit x tends to minus 1 minus f of x. This is what I want to find out, right? So which is nothing but minus 2x. In minus 2x, if you substitute minus 1, it is going to be plus 2. So this value is going to be plus 2. And what about its value at minus 1? It is going to be 2 only. Now what about the value to the right of minus 1? Sorry, to the right of minus 1 is again plus 2. Therefore, its left hand limit is equal to the value at that point is equal to right hand limit. So we can say that it is continuous at minus 1. Similarly, you can do the same thing at plus 1. Now how to do it? Find out the right side limit, right hand limit, and at the point what the value is, and then at the left hand limit, right? Now if you try to find out the right hand limit, you are supposed to use this function. Why? At a point to the right of 1, the function is 2x. Now in the 2x, if you substitute x equal to 1, you are going to get 2. And now at x equal to 1, the value is 2. And also to the left of it, the value is 2. Therefore, left hand limit equal right hand limit, it is continuous. right, and the value at that point. Therefore it is continuous at -1 and 1, and anyway at all the other points you can clearly see that it is continuous. So what can we say? The function is continuous at all the points. Now only thing we should check is whether it is differentiable or not. So how to find out differentiability is, since it is already known that it is continuous and there are only 2 points where it might fail, we can check the differentiability only at these 2 points. That's it. Okay, now that too we can use f dash method. Now I want to find out f dash of x, and I want to find out the left limit for -1, which means f dash of -1 minus, this is what I want to find out. I want to find out left limit at -1, which means f dash of -1 minus, right? Now if I am talking about a point which is to the left of -1, then this is what I am looking at. Now find out its derivative. We are going to get -2, isn't it? That's it, -2. So what does it mean? The left hand limit at x equal to -1, the left limit, or sorry, the left derivative, I'm talking about left derivative, okay? The left derivative at x equal to -1 is -2, right? Similarly find out the right derivative. So what is right derivative? F dash of -1 plus, this is what you have to find out. Now when I say -1 plus, I'm talking about a point to the right of -1, which means I'm talking about this one, right, which is clearly 2. Now if I try to differentiate it, it is nothing but d by dx, right? So this is going to be 0. Now what do you understand? The left limit, so the left derivative is -2 and the right derivative is 0. Therefore at -1 it is not, differentiable or derivable. So clearly it is true. Why? Because it is the corner point, right? So therefore we can say that it is not derivable at that point. Now what about 1? So in order to check for 1, you can find out. 1 is left derivative at x equal to 1, which is nothing but f dash of 1 minus. If I find out f dash of 1 minus, right, which means I am talking about a point to the left of 1. So to the left of 1, the point is this, the function is this. Find out the derivative. So d by dx of 2. Since it is a constant, I am going to get 0. Therefore left derivative at x equal to 1 is 0. Now what about right derivative? So for that you have to find out f dash of 1 plus. So what is it? So it is, find out the function to the right of 1. So which means to the right of 1 is this one. You find out the differentiation of this, which is 2 into d by dx of x, which is nothing but 2. Got it? So therefore we got 2 here and we got 0 here. So we can say that the left derivative is not equal to right derivative, and so the function is not derivable at this point 1. So what can we say? The function is not derivable at these 2 points, and other than this all the points there are no, everything is smooth, so it must be definitely derivable at all the other points, right? The function is continuous at all the points and the function is derivable at all the points except 1 and -1. So that is what they asked. Discuss the continuity and derivability of the function. Got it? So it is not derivable at this point and at this point, and it is continuous throughout the range. Got it? Okay. So one more point is, whenever you have a function like mod x minus a, definitely this function will have a corner edge or that sharp edge at x equal to a. Therefore at this point it will not be derivable. You can remember that. Okay, so which means if we have mod x plus a, then at x equal to minus a, it is not going to be differentiable or derivable because it is going to have a sharp edge, right? So how to find out is, whenever you have mod, let's say ax plus b, now where is it not derivable is, you have to equate this entire thing to 0, which means you can say ax plus b equal to 0 and you find out that value, which is nothing but minus b by a. So at this point generally it will not be differentiable or derivable. If you have any doubt, you can just check at that point, right? Which means you can do this method and you can check it. Got it? So the points you need to check are this, whenever for this one a, for this one minus a, and for this one minus b by a. These are the points at which you have to check whether it is differentiable or not. Okay, fine. Okay, let's see this question. F of x equal to step sin x where x belongs to 0 comma 2 pi. Which of the following is true? f of x is discontinuous at x equal to pi by 2, f of x is discontinuous at x equal to pi, and f of x is continuous at x equal to 3 pi by 2. See, this is continuous. Okay, these two are discontinuous, this is continuous, and option D is all the above, right? So you have to understand what is step x first. So step x will give us, now for all the values, see, whenever you talk about sin x, all the values of sin x will lie between -1 and 1, isn't it? Let's not call x, let's call a. Okay, or you can say -1 sin x and 1. So all the values of sin x will always lie between -1 and 1, and it can be -1 and it can be 1 as well, right? So you can divide it. So in this range we have three integers. So what are the three integers? One is -1, and the other is 0, and the other is 1. Now whenever the value of sin x happens to be a value between these two, -1 and 0, then step x is going to show -1. Okay, now whenever the value is going to be between these two, 0 and 1, step x, right, if value happens to be between these two, step x function is going to show you 0. Got it? Therefore this step x function, step sin x function, whenever sin x equal to 1 is going to show you a value of 1, and whenever sin x happens to be a value between 0 and 1, it is going to show a value of only 0, and whenever the value happens to be between -1 and 0, including -1, the value is always going to be shown as -1. Got it? So only three outputs are possible. So one is -1, other is 0, and other is 1. Okay, whatever the value of sin x is. Now they are talking about 3 points. One is pi by 2, other is pi, and other is 3 pi by 2. It is better if you can draw the graph and if you can observe it. Okay, now let's say this is 0, this is 1, this is -1, this is 1, this is 0, and this is -1. Okay, now sin x, if I am trying to write, the value is going to be, see, so I am trying my level best to put it as symmetrical as possible. Generally it is symmetric, this one and this one will be symmetric. Okay, so now at a value x equal to pi by 2, its value is going to be 1, right? And at a value x equal to pi, its value is going to be 0, and at a value x equal to 3 pi by 2, its value is going to be -1. Okay, at a value pi by 2, its value is going to be 1, at a value pi, its value is going to be 0, at a value 3 pi by 2, its value is going to be -1. Okay, now they are saying about this, f of x is discontinuous at x equal to pi by 2. So let's check this. At x equal to pi by 2, what is its value? Its value is 1. Therefore f of pi by 2 equal to 1, right? Now let's try to find out what is the left limit of it. So left hand limit is going to be f of pi by 2 minus, so what does it mean? What is its value to a point just to the left of pi by 2? To a point just to the left of pi by 2, this value will be close to 1 but not 1, which means this value will lie between 0 and 1, right? Whenever sin x value is lying between 0 and 1, step sin x will always be 0, which means this is going to be 0. Are you getting this? Which means you can consider it as a point here. Since this point is lying between 0 and 1, if I apply step, its value is going to be 0. Got it? Now what about the right hand limit? F of pi by 2 plus, this is the right hand limit, right? So which means you can think of it as if we are talking about a point here. Now at this point, the value of sin x is lying between 0 and 1, but it is not equal to 1. Therefore its value will be 0 only, right? So now if you observe it, left hand limit and right hand limit are equal, but is not equal to the value at that point. Therefore we can say that it is not continuous at that point. Got it? So f of x is not continuous at pi by 2. Now if you see this, you know how to look at this graph is, see, whatever I have drawn here, it is just a sin x graph, it is not step of sin x. Now if you try to see the step of sin x, it will be as if from 0 to pi by 2 through a point pi by 2 it will be 0, and exactly at the point pi by 2 it will jump to 1, and immediately after pi by 2 it will be again 0, which means there is a jump there. Are you getting this? From 0 to pi by 2 it will be 0, and exactly at a point equal to pi by 2 it will jump, and again it will fall down. Therefore there is a jump. So whenever there is a jump, we can say that it is not continuous. Jump or hole or cut, right? So it is not continuous. And one more thing you should be careful is, this is sin x curve, not the step of sin x. Using this we are just analyzing what happens to step x. Okay, next one is at pi. If you look at pi, now let's see what its value is at pi. At pi its value is 0, okay, to a point just to the left of it. Just to the left of it means here, right? To a point just to the left of it, its value is again lying between 1 and 0, therefore its value will again be 0. To a point to the right of it, its value will be between 0 and minus 1, therefore its value will be minus 1, right? Which means left hand limit is 0 and the value at that point is 0, but the right hand limit, if you see, it is minus 1. So all the three are not equal. Again we can say that it is not continuous, right? So if you try to see the graph, it will be as if from here to here it is going till as if it is 0, and suddenly as we move after pi it will drop down, it will jump from here to here, it will jump directly, it will jump to a point minus 1, right? So which means from here to here it is 0 and suddenly it will jump here, showing that the value is here, which means there is again a jump, or therefore it is again not continuous at that point. So at x equal to pi it is discontinuous. So these two are true, right? Anyway these two are true and all the above is there, so all the above must be the answer, right? Let's see. Now next one is f of x is continuous at pi 3 pi by 2. Now if you look at this point 3 pi by 2, okay, which means we are talking about this point, right? Now at this point the value is minus 1, and to a point to the left of it, which means if you talk about this, that is left hand limit, this value is lying between 0 and minus 1, therefore the value will be minus 1 only, and to a point to the right of it, again this value will lie between 0 and minus 1, therefore its value will be minus 1 only. Got it? Therefore the value at that point is minus 1, left hand limit is minus 1 and right hand limit is minus 1, so we can say that the value is going to be minus 1 only. So it is continuous, right? So if you see the graph, it is going to be from here to here, it is continuously going to be minus 1. So from here to here it is continuous, there is no jump here, right? Unlike this, here there is jump, here there is jump, but here there is no jump. Got it? So it is definitely continuous at x equal to pi by 2. Therefore the answer is all the above. Okay, fine. Now let's see the topic of maxima and minima. A function f of x is said to have maximum at x equal to a if f of a is greatest of all the values in the neighborhood of a, where a is an interior point in the domain of f of x. Which means if you look at this this graph, let us say this is f of x, okay, this curve is representing f of x, and now if you see a point for which the value of this function is highest, that point happens to be a. Got it? So at a, f of x is having the highest value, let's call it as f of a. Now what are the properties that it should satisfy if it has to be called the maximum is, for all the other points this value should be greatest, which means f of a should be greater than f of a plus h, which means for all the points which are to the right of it, it should be greater, as well as f of a is greater than f of a minus h. For all the points which are to the left of it, it should be greater, right? So for this it is called as the maximum. So if you see this from here to here, if you consider, this is the highest point, right? But then in general we call it as the local. Okay, there is no concept of local maxima and local minima. We are not going to look at it in this topic, but in general when you are talking about a small neighborhood, then we can say that it is the local maximum for that neighborhood. Now if that maximum is going to be the maximum for all the functions, then it is generally called as the maximum. Got it? So for this topic, let's restrict ourselves to maximum concept. So what is the maximum? So maximum means whenever a value is having the highest value compared to all the other ones, right? So this is the meaning of it. And now if we talk about the minimum, a function f of x equal to y equal to f of x is said to be minimum at x equal to b if f of b is the smallest value in suitably small neighborhood of b, where b is an interior point in the domain of f of x. So what they are trying to say is, if you look at this function, right, for this function at this point, this is the least value of the function, right, which means at a point b the value of the function is least, and that value is actually f of b. Got it? Now if you look at any point to the neighborhood of it, which means to the left or to the right, this one is supposed to be the least, then only we can say that this is the local minimum. And in case if that is the only minimum, we call it generally as the minimum without using the word local. Okay, so now f of b is less than or equal to f of b plus h, which means to the right of it whatever values are there, it is less than all such values, and then f of b is less than or equal to f of b minus h. So which means to the left of it whatever values are there, it is less than all those values, therefore it is minimum in that neighborhood. Okay, fine. In the topic of finding the maxima and minima, what we are interested in is the point at which we have the maximum value for f of x or the minimum value for f of x. So one easy method is to represent the entire function as a graph, and then we can find out the point at which the slope of the tangent is 0, right? So which means if you observe this, if there is a curve like this, okay, now let's say this is the point at which the function f of x is maximum. Let us say this is f of x and this is x. Okay, now this is the graph plotted between x and f of x. Now if you observe this is the point at which we are having the maximum, and if you try to draw a tangent at that point, the slope of the tangent will be, this tangent will be parallel to x-axis, and so the slope will be equal to 0, right? Therefore if you try to find out at this point, let us say this point is a, okay, let us say this is f of a. Now at this point a comma f of a, if you try to find out the slope of the tangent, that is going to be 0, right? So what is the slope of the tangent? F dash of x at the point a, that is why f dash of a, right? If f dash of a happens to be 0, then we are going to have the maximum value there. That is why this point is very important for us, and such points we call them as stationary points, right? And also if you want to see even a point, even the point at which f of x is having the minimum value, the least value, there also the slope will be equal to 0. Therefore in order to find out either maxima or minima, the main interesting point is stationary point, right? Now let's see that if f dash of a equal to 0, then f of a is the stationary value, and the stationary point is a comma f of a, and f of a should exist, right? So it means that this particular value, this is either the maxima or minima, that value is called as the stationary value, and this point is called as the stationary point, right? So that is what we really use in this topic. So sometimes what happens is there is one more point which is called as critical point, and according to the definition of critical point, every stationary point also happens to be critical point, and so in the questions, instead of asking about a stationary point, they are sometimes asking about the critical point. The reason is every stationary point is going to be a critical point. Now if you look at the definition of the critical point, you will understand that. Now see this, we say that x equal to a is a critical point of the function f of x if f of a exists and either of the following are true. So f dash of a equal to 0 or f dash of a does not exist. Now if you look at the definition of the stationary point and critical point, every stationary point satisfies the definition of the critical point. The reason is, for every stationary point f dash of a equal to 0 and f of a exists, right? Therefore it so happens that every stationary point is definitely going to be a critical point, right? And sometimes what they are trying to ask is, instead of talking about the stationary point in the equations, they are talking about the critical point. So coming to the topic of maxima and minima, either if they ask you about the critical point or stationary point, you just take them as one and the same and solve the question by using the same definition of the stationary point. You just find out the points at which f dash of a is equal to 0, and from that you find out the stationary point, even though they are asking about the critical points, right? And also remember that every stationary point is a critical point. Okay, fine. Now let's look at the functions, types of functions. Now based on the way a function is growing or decreasing, we can classify functions into various types. So the it is all based on the values of the functions at various points. Now a function, let us assume that this is the function you are talking about. You can say that within this range x1 to x2, which means from here to here, you can talk about the function. If it is increasing, you can talk about it, and if it is decreasing, you can give it some name, right? So one of the classification is monotonic functions. So see this, a function f from a to b to r. So f is a function which is taking values in the range a to b, and it is giving real numbers as the output, right? Is said to be monotonically increasing or non-decreasing on a comma b if x is less than y implies f of x is less than or equal to f of y. So what they mean to say is, if you are having a function within the range, let us say a to b, then it should either be same or it should be increasing, or it should be same or it should be increasing. If you have such a function, then it is called as monotonically increasing, right? So what it means is, it should not decrease at any point. It could either remain same or it could increase, right? Now if you observe this one, so even the function is like this. In this case, I'll just maximize it. It is simply showing something like this, right? It is increasing at all the points, or it is remaining same. So in that case, it is called as monotonically increasing. Now what is strictly increasing is, you are not supposed to have this kind of growth. You should always have it in the increasing, right? So which means between a and b, if you are going to see, it should be of form like this, right? Or even if it is growing, it is not a straight line, it should be increasing. There should not be any points, 2 points which are equal, right? So which means like this or like this, you should not have any points there, right? Now see this, strictly increasing on a comma b means, if x1 is less than x2, that implies f of x1 is less than f of x2 for all x1 comma x2 belongs to a. So if you observe the difference between this one and this one, here whenever two values are equal, it is allowed, but here you don't have any points which are equal, which means it is definitely increasing, strictly increasing. Here it is either remaining same or it is increasing, alright? That is the meaning. Now let's see monotonically decreasing function. So if it is monotonically decreasing, it means that it could either remain the same or it could decrease, or remain the same or it could decrease. If a function is behaving like this, then it is called as monotonically decreasing, right? Now if you see this in this diagram, so we have drawn the diagram like this, and now we are saying that this is monotonically decreasing because it is actually decreasing and not increasing, right? So if it is non-increasing, you can say that it is monotonically decreasing. See, you should understand the difference between these two. So non-increasing means it could even remain same. So it could either remain same or it should decrease, but it should not increase. That is the meaning of it, okay? Now they are defining it on a range. See, even though the function is may increase or decrease in the other range, when we are talking about a range, what we mean to say is, let's say a and b have to be defined, right? Yeah, so let us say this is the a, this is a, and maybe this is b. Now if you see in AB, you take any 2 points, as we are going forward, it is either decreasing or remaining the same. It is never increasing, right? And what about strictly decreasing? Strictly decreasing means it should behave like this, right? As you go forward, it should always decrease. That is called as strictly decreasing, right? And now if you see this here also, there is no point at which it is increasing or remaining constant. right? It is continuously decreasing. That is why it is called as strictly decreasing. So that is the main difference between monotonically decreasing and strictly decreasing. Okay. Now let's say there is a function f which is defined on a set A, which means the domain of if we take f as a function, let us assume that the domain is forming a set A. Now for all the values which are present in A, if we can find out the value of f which is greater than any other values, then it is called as the greatest value, right? So greatest. Similarly, least means you have to find out a value of some value in the domain for which the function should be the least possible value compared to all other values, right? So I'll just explain you in words. Let f be a function defined on a set A. So it means that A is forming all the points which are present in the domain for the function, okay? And L belongs to f of A, then L is said to be the maximum value or the greatest value or absolute maximum or global maximum of f in A if f of x is less than or equal to L for all x belongs to A. It means that whatever other points you take, you compare it with L, at all those points the value should be less than or equal to this particular value, right? Then you are going to say that that value is the maximum. So what I mean to say is, assume that this is the function and it is defined like this, okay? And say the domain is from here to here, right? Which means you are talking about all the points from here to here. In all these points you find the value of f of x, right? Now if you are able to find a point L in such a way that the value of f of x at that point is greater than the value of f of x at all the other points, then that particular point is called as the greatest point, isn't it? The maximum value or the greatest value or the absolute maximum or global maximum. So these are all the names given to that, right? And now if we talk about the minimum value, right? If we have a function like this, let's say a function is defined like this, okay? And this is the domain of the function, which means it is defined across all the values from here to here, right? Now if you are able to find out a value of L at which the function value is least or minimum compared to the function value at any other points in this set, then we can call that this is the minimum value. So the minimum value or least value or absolute minimum or global minimum of f in A if f of x is greater than or equal to L for all x belongs to A. Got it? So this is the definition of greatest and least values, okay? Now let's see the concept of global maximum or minimum in the interval. So as I told you that there can be more than one local maximum or local minimum if a function is behaving like this. If a function is having some values like this, right? Then what happens is we have many critical points or stationary points. So wherever you are going to get the slope of the tangent as 0, all those points can be considered as the stationary points or critical points, right? Now when you try to find out the points at which slope is equal to 0, you are going to get many points like this, right? Now these are all going to be the either local minimum or local maximum, right? Now among all these points, whichever is the least is called as the global minimum, right? And whichever is the maximum is called as the global maximum, right? Now along with these points you might also have to include the endpoints, right? Why? Because you might have started observing the function. If it is a monotonically decreasing function, you might have started observing it only at the point when it started decreasing, right? Therefore at that point it need not be having a slope 0 if I try to write the tangent, right? Which means if the value is coming like this, if the function is coming like this, then even though the slope is not 0 here, still this is the maximum value, isn't it? That is why along with all these points you also consider the extreme points. Extreme point means the end of the range. If you are talking about the range A to B, then you try to find out the value of the f of x at A and B also, right? Along with these points you are supposed to find out the value at all the other stationary points. Now among all these points, whichever is having the maximum is called as the global maximum, whichever is minimum is called as the global minimum, right? Now see this, in order to find the global maximum and minimum of f of x in the interval a comma b, find out all critical points of f of x in a comma b, that is all points at which f dash of x equal to 0. As we know that it is also called as stationary points, right? So find out all such points. How can you find it out? Write f dash of x equal to 0 and solve that equation. Then you are going to get all the values of x which are called as the stationary points or critical points. Now let C1 to Cn be the critical points at which f dash of x equal to 0. Now once you find it out, then you can say these all values, they either can be local minima or local maximum, isn't it? So f of C1, f of C2, f of C3, they all can be local minimum or local maximum with the values of the functions at the critical point, right? Now what is the global maximum? You find out the maximum value of those. So along with the values at the critical points, you also find out the values at the extreme points of the range. Now whatever is the maximum, we call it as the global maximum, and whatever is the minimum, we call it as the global minimum. Got it? Okay. Now let's see this topic of finding out the maxima and minima. So in order to find out the maxima and minima of a function, you are supposed to find out f dash of x. So after finding out f dash of x, you have to equate it to 0 for finding the stationary points. So this is step 1 is find out the first derivative, and step 2 is find out the stationary points. So what I mean by this is, if you have a function like this, let's say you have a function like this, okay? Now whenever you draw a tangent to this function, if the tangent happens to be parallel to x-axis, right, then only its slope is going to be 0, isn't it? Therefore at a maximum point or minimum point of a function, generally we get a tangent which is parallel to x-axis, which means its slope is going to be 0, right? Then only we can say that a function is going to be either maximum or minimum at that point. Got it? For that reason, first find out f dash of x and then find out the stationary points by equating it to 0. Stationary points means the points at which the tangent is having a slope 0, that is called as the stationary point. Got it? Okay, at each stationary point, now we are supposed to find out double derivative of x. Okay, if double derivative at that stationary point, let us say the stationary point is x naught, if the double derivative at that point x naught is greater than 0, then the function has minimum value. If it is less than 0 double derivative, then the function has maximum value. But then if it is equal to 0, then we need to probe further, then we need to find out the third derivative. Now in case if third derivative is not equal to 0, then we can say that the function has neither maximum nor minimum at that point. Got it? So in case if the third derivative, see this one, so in case if the third derivative is equal to 0, then we have to find out the fourth derivative. Got it? So what does it mean? So whenever you look at the even powers, that is where we are going to decide whether the point is going to be maximum or minimum. Whenever you have odd derivatives, they all should be 0. So whenever the odd derivatives are not equal to 0, we will not be able to, we can say that the point is neither minimum nor maximum, right? So which means if a point has to be minimum or maximum, then all the odd derivatives at that point should be equal to 0, and the even derivative should be either less than 0 or greater than 0. So which means it is, now fourth derivative is nothing but the even derivative, isn't it? So fourth derivative, if it is positive, we can say that it is having a minimum at that point. If it is the fourth derivative is negative, we can say that the point is having maximum at that point, right? Now you have to repeat this process until the point is decided, which means until you reach a point where, or until you reach a derivative where it is saying that even derivative is equal to 0, I mean odd derivative is equal to 0 or not equal to 0. Till that point you have to go on, right? So one more thing, the note is, it must be remembered that this method is not applicable to those critical points where f dash of x remains undefined. So whenever you find out that f dash x is not existing, you cannot apply this method. Okay. So one more point here is, see, various points is, these points are called stationary points, right? So in case if you get any other point which is not those, then it is called as inflection point. So inflection point means the point which is not either minimum or maximum. Got it? So if a point happens to be not a minimum or maximum, then we can call it as the inflection point. So this is all about the theory. You will be able to understand this method once we take an example, right? So let's see some examples on this, then you will be able to understand it. See, always the process is same. First try to find out the first derivative and then try to equate it to 0, and after that find out all the stationary points and decide whether that stationary point is going to be minimum or maximum only at the even derivatives. At the even derivatives, if it is greater than 0, it is minimum point. If it is less than 0, it is maximum point, right? And at the odd derivatives, you have to see whether it is 0 or not 0. In case if it is 0, we have to go on to the even derivative again. If it is not equal to 0, then only you can stop there and say that it is neither minimum nor maximum, which means it is an inflection point. Got it? Okay, we shall see some examples. With those, this method will be clear. Okay. Now let's see this question. The function f of x equal to 3 into x power 4 minus 4x cube plus 10 has a minimum value at x equal to dash. So they are talking about a function and they are asking us to find out the minimum value. Now how to find it out is, as I told you, first find out the f dash of x and equate it to 0, so that you will find out all the stationary points, right? So f dash of x, I am finding it out, which means first derivative. So first derivative, I got this 3x power 4 minus 4x cube plus 10. If I find out f dash of x, I am going to get 12x cube minus 12x square, that equal to 0, right? So if you try to pull out 12x square as common, now I get that either x has to be 0 or x minus 1 has to be 0 if this product has to be 0, which means either x has to be 0 or x has to be 1. Now these are the two stationary points I got. So whenever you get stationary points, then either this point can be either a maximum or minimum, which means this point can be a point at which the function has either maximum or minimum. Similarly, this point can be a point in which the function might have either a minimum or maximum value, which we can't decide as of now. So for that, let's find out the second derivative. Okay, now if we try to find out the second derivative, we got this function. Now in this second derivative, try to substitute these values. So let's test for x equal to 0 first and then x equal to 1. Okay, because in the options both 1 and 0 are given, so let's test anyway both of them. So let's test x equal to 0 first. Now if I am trying to test x equal to 0 by substituting in place of f double dash, if I substitute in place of x 0, then I am going to get the answer as 0. So whenever f double dash x is equal to 0, we will not be able to decide anything. We have to go to f triple dash, right? So third derivative. So third derivative of x is 72x minus 24. Now in the third derivative, when I am substituting x equal to 0, then I am getting a number which is not equal to 0. So whenever at the odd derivatives, if you get a number which is not equal to 0, then you have to stop there and say that this point can neither be minimum nor maximum, right? So which means the point x equal to 0 is a saddle point or inflection point. So inflection point means which is neither a minimum nor a maximum. So the meaning of this point means it is neither a minimum nor a maximum. Got it? So x equal to 0 is ruled out. Therefore option might be x equal to 1, and also none is given, so we have to test it again. So for x equal to 1, again follow the same procedure. What is it? Find out, after finding out the x equal to 1 from f dash of x equal to 0, you find out double derivative and equate in place of x 1. So do that. Now when you find out double dash at x equal to 1, come here, at x equal to 1, now if you find out f double dash of x, this happens to be greater than 0. So what does it mean? Whenever second derivative of x is greater than 0, it means that at that point the function is having the minimum value, right? So f of x has minimum value at that point. At what point? At x equal to 1. Got it? So at x equal to 1, the second derivative happens to be greater than 0, which means it is having a minimum value at x equal to 1, right? So what is the minimum value if you want to find out? You just substitute 1 here. 3 into 1 minus 4 plus 10, which is 9. So 9 must be the minimum value of the function. Got it? So the answer is at point 1 we are going to have minimum value. Got it? Okay. Let's see this question. If f of x equal to x into x square minus 1, then find the points at which f of x assumes maximum and minimum. So for that reason, you have to find out f dash of x first, and then you can find out what are the stationary points. So let's see what is f dash of x. F dash of x equal to x into 2 into x minus 1. It is UV formula, right? So when you have a function like f of x into g of x or u into v, now we are just differentiating this one first with keeping x as constant, okay, and then differentiate x keeping this one as constant. Now we got that f dash of x equal to this one, this function. Now equate it to 0 so that you can find out the stationary points, right? So whenever I equate it to 0, I found out that x equal to 1 or x equal to 1 by 3 are stationary points. Therefore, at these stationary points, there is a chance that we can have either minimum or maximum for the function, okay? Now let's see if that is true. So how can we know? By finding out the second derivative, f double dash of x. Now find out f double dash of x. It is 6x minus 4. Now in this 6x minus 4, substitute in place of x these two stationary values. If you are going to get greater than 0 or less than 0, we can know which one is minimum and which one is maximum. Now if you find out at x equal to 1, f double dash of x is greater than 0. Why? If you substitute x equal to 1 here, you are going to get 2, right? So 2 means greater than 0. So whenever you get the second derivative as greater than 0, we can say that the function value is minimum at that point, right? Therefore f of x has minimum. At what point? At a point x equal to 1, right? So at x equal to 1, the function will assume minimum value, right? Okay, now what happens at x equal to 1 by 3? Now if you substitute x equal to 1 by 3, if I substitute x equal to 1 by 3 here, it is going to be 2 minus 4, which means minus 2, which means less than 0. So what can we say? F of x has maximum, right? Which means at x equal to 1 by 3, the function is going to assume max value. Got it? Okay. Let's see this question. For the function f of x equal to x square into e power minus x square into e power minus x, the maximum value appears at x equal to what? So for this, you are supposed to find out f dash of x and then equate it to 0 so that you will find out the stationary points. Now if you find out the f dash of x and equate it to 0, we got the stationary points as x equal to 0 or x equal to 2. These are the two stationary points. Now let's see whether at these points we can get maximum or minimum. For that reason, you have to find out second derivative, f double dash of x. Now the second derivative happens to be this big function, okay? Now the entire expression is the second derivative, right? Now in this second derivative, you substitute x equal to 0 first so that you will know what this point could be. Now when you substitute x equal to 0, we got a value of 2. So what does it mean? It is greater than 0. Now whenever we get second derivative as greater than 0, it means that at that particular point the function is going to have minimum value, which means at x equal to 1 the function is having minimum value, right? And what about the x equal to 2? At double derivative you substitute x equal to 2. Now if you substitute x equal to 2, the function value happens to be minus 2 by e square. E square is going to be a positive number, 2 is a positive number multiplied with minus. Therefore this entire number is less than 0. Now since we got a number less than 0, we can say that the function is having maximum value. Therefore at x equal to 2, the function has maximum value. Got it? Okay. Let's see this question. For the function f of x equal to x square into e power minus x square into e power minus x, the maximum value appears at x equal to what? So for this, you are supposed to find out f dash of x and then equate it to 0 so that you will find out the stationary points. Now if you find out the f dash of x and equate it to 0, we got the stationary points as x equal to 0 or x equal to 2. These are the two stationary points. Now let's see whether at these points we can get maximum or minimum. For that reason, you have to find out second derivative, f double dash of x. Now the second derivative happens to be this big function, okay? Now this entire expression is the second derivative, right? Now in this second derivative, you substitute x equal to 0 first, so that you will know what this point could be. Now when you substitute x equal to 0, we got a value of 2. So what does it mean? It is greater than 0. Now whenever we get second derivative as greater than 0, it means that at that particular point the function is going to have minimum value, which means that x equal to 1 the function is having minimum value, right? And what about the x equal to 2? At double derivative you substitute x equal to 2. Now if you substitute x equal to 2, the function value happens to be minus 2 by e square. E square is going to be a positive number, 2 is a positive number multiplied with minus. Therefore this entire number is less than 0. Now since we got a number less than 0, we can say that the function is having maximum value. Therefore at x equal to 2 the function has maximum value. Got it? Okay. Now let's see this question. If y equal to a log mod x plus bx square minus x has extreme values at x equal to minus 4 by 3 and x equal to 2, then what are the values of a and b? So they are saying that extreme values means either minimum or maximum. They are already giving that either at x equal to this value or this value we are having the maximum values, extreme values, which means either this can be maximum or minimum and this can be maximum or minimum, right? Now given this, they are asking us to find out what could be the values of a and b. So how to find it out is, without assuming these two values, you can just take this function and try to find out the maximum or minimum by usual procedure. And whenever you reach a point where you can decide a and b, then you can stop and decide it. So let's go with the usual procedure. Now what is the normal procedure? You have to find out the f dash of x. Now f dash of x, given that f of x is this one. Now if we find out f dash of x, I got this. Now if you equate this one to 0, then only we are going to find the extreme points, isn't it? But then extreme points are already given. Got it? So f dash of x, we got it as this one, equate it to 0. Now if you solve it, we are going to find out the extreme values. But since extreme values are already given, you can stop it here and then see from the extreme values what should be f dash of x. Right? If the extreme values would have been minus 4 by 3 and 2, then this f dash of x should have been this one, isn't it? Which means x plus 4 by 3 into x minus 2 equal to 0, and this function, this equation and this equation should be exactly the same. Got it? Now whenever you talk about the equation, you should see that some of the all the quotients are exactly the same. But if you observe this equation which we got from the extreme points and this equation which we got from f dash of x, there is a small change here. Now if you observe this, the quotient of x here is minus 2 and the quotient of x here is minus 1. So either you can multiply this one with 2 in order to get this, or you divide this one with 2 in order to get this, so that you can compare the terms, right? So how can I do that? Just multiply or divide this one. Divide this one with 2 so that you can make this quotient as minus 1 here, and then you can compare the corresponding terms. Got it? So what is it? If I divide it by 2, I am going to get 3 by 2 x square minus x minus 4 equal to 0. Now here you can clearly see that x quotient here and x quotient here is same. Therefore all the other quotients must also be same. So now we can compare the quotients one by one. Now what about the quotient of x square? Here it is given as 2b, right? And here it is given as 3 by 2. Therefore 2b must be equal to 3 by 2. So just say this, 2b must be equal to 3 by 2. Then what do you get from that? b equal to 3 by 4, right? And now here if you see a, here it is minus 4, right? Therefore a must be equal to minus 4. So if b equal to 3 by 4 and a equal to minus 4, there is a chance that if you substitute it here and you find out f dash of x, you are going to get the same values, extreme values. You can test it if you want. What is it? Take b equal to 3 by 4 and a equal to minus 4 and substitute there. And if you go on finding out the extreme values, you are going to get these two, minus 4 by 3 and 2. Got it? Okay. This question is given in GATE 2012. So let me read it out for you. Consider the function f of x equal to sin x in the interval pi by 4 comma 7 pi by 4. The number of locations of the local minima of this function are. Now they are talking about the local minima, and also they are asking about how many points you are going to have local minima, right? In order to solve this, you are supposed to find out all the points at which we are going to have local minima. Now definitely those points will be one of the stationary points. So in order to find it, you just find out all the stationary points, and one of the stationary point will definitely be, one of them or many of them will definitely be local minimum, right? And after that you need to even check at the extreme values. Extreme values means since the range is given, you have to find out the left boundary and the right boundary, and at those points also you need to check whether it is a local minima or not, right? Now while defining the definition of local minima, I told you to look at the neighborhood both to the left side as well as the right side. But when you are looking at the extreme points, if you take the left extreme point, just look at the right neighborhood of it and decide whether it is a local minima or not. And similarly, if you are looking at the right extreme value, then look at the left neighborhood of it. Okay, now I'll show you what I'm telling you here. So first thing is find out all the stationary points. So how can you find out the stationary points in the range? Find out f of x and equate it to 0, right? So f dash of x, so f of x equal to sin x, find out f dash of x and equate it to 0. I'm trying to find out all the points at which the tangent is having a slope of 0. See, what does it mean? F dash of x equal to 0 means I'm finding out the points at which the slope of the tangent is parallel to the x-axis, which means slope of the tangent is 0, or the tangent is parallel to the x-axis. Now if I find out, then I found out that at x equal to pi by 2 and 3 pi by 2, in this range, you should also keep this range in mind. In this range, these are the only 2 points for which the tangent is 0, slope of the tangent is 0. Therefore these two are the stationary points. Now one of these 2 points may be, there is a chance that one of these 2 points may be, or both of the points may be local minima. So let's find it out. In order to test it, we can find out f dash of x. Now if I find out f dash of x, at one point I got less than 0, and other point I got greater than 0. So whenever it is less than 0, this is the maximum value, so rule it out, which means pi by 2 is ruled out, right? Now what is remaining? 3 pi by 2. At 3 pi by 2 I got greater than 0, which means definitely here I have a minima, right? So since I have a minima, then I can say that this is one of the points at which we have local minima, right? And now I have to find out whether at the extreme points we are going to have local minima or not. So it will be better if I show you with a graph whether it is having a minima at the extreme points. Let's see the graph there. Here, now if you see this, so this is the extreme point. One extreme point is pi by 4, right? So which means this is the pi by 4, right? And the other extreme point is 7 pi by 4. Now if you observe this, if you are talking about the left extreme, just compare the value of that point with the points to the right neighborhood, which means just find out the point to the right of it. At all the points to the right of it, they are greater than the value at this point, right? So at this point the value is 1 by root 2. Now if you take any point to just to the right of it, in the right neighborhood, they will be greater than this. That is why at this point it is minimum, right? So it is called as local minima. So when you are talking about the left extreme, look at only the right neighborhood. When you are talking about the right extreme, look at only the left neighborhood. Why? Because the function is defined only between those interval, or we are caring only about that interval. We don't care about the points which are to the right of it in this case and which are to the left of it in this case, right? Now similarly, if you want to test whether it could be a minima or not, just compare it with the values to the left of it in the left neighborhood. Now in the left neighborhood you can clearly see that the values are less than this, and so it cannot be minimum. But here to the right of it you are seeing that the values are greater than that, therefore it can be minimum, right? Therefore we got this point also as a local minima, and also 3 pi by 2 as one of the local minima, right? So these 2 points are the local minima. Got it? Now what is the global minima? If you find out all the points, all the critical points and all the boundaries I mean all these extreme points, and if you find out the minimum among them, that is going to be global minima, right? Global minima is going to be this one, but these two are local minimas. Got it? Okay. Now one more way you can identify the local minima and all the points of local minima is one other shortcut is just see the function and see where the strictly increasing behavior is going to start. If you look at it from this point, from pi by 4 to pi by 2, the function is strictly increasing, and therefore the pi by 4 must be a minimum in that interval, isn't it? Therefore it is a local minimum. And again, if you see this, from here to here it is strictly decreasing, and again from here it is strictly increasing, right? Therefore at this point the increasing behavior has started, and so you can say that this is the again a local minimum, right? That is one other way of looking at it. Now look at the answers. Pi by 4 and 3 pi by 2 is the answer, right? 2 at pi by 4 and 3 pi by 2. Therefore D is the answer. Okay. Now let's see this topic of mean value theorem. So the first theorem is Rolle's theorem. So I'll read it out and explain you. So Rolle's theorem says that let f of x be defined in the range a comma b such that it satisfies three conditions. First condition is f of x is continuous in a comma b, and the second condition is f of x is differentiable in a comma b, and the third condition is f of a equal to f of b. If you have any such points, right, if you have any such points in which all these three conditions hold, then they are saying that this theorem says that then there exists at least one point C between A and B in such a way that f dash of C is equal to 0. So what they are trying to say is, let us say there is a function here, okay, there is a function here, and assume that the function is moving something like this, okay. Now this is f of x is the function and x is the values, right? So you can take 2 points here, one point, let's call it as A, and let's call this one as B, right? Now if you see this point, f of A is equal to f of B, isn't it? So what they are trying to say is, whenever you have any such 2 points on which the value of the functions is equal, then definitely you will be able to find one more point between these 2 points in such a way that you should be able to draw a tangent which is parallel to x-axis. That is what they are trying to say, okay. So again 2 more conditions are added there. So one thing is these 2 values should be same, and 2 more conditions added is that the function should be continuous, which means there should not be any holes or jumps. In case if if there is a hole or a jump here, then this is not possible, isn't it? And the second one is the function is differentiable, which means the function should not have any sharp edges, which means the function should not be like this. So in this case also you will be able to see that f of A is equal to f of B, but then you will not be able to find a point at which tangent is equal to 0. The slope of the tangent is equal to 0, right? So there should not be any holes or cuts, and there should not be any corner edges, right? Other than this, you can say that you should be able to find out a point C, right? And also one more important point is there exists at least one point that is important. So what they mean to say is, sometimes it might so happen that there exists more than one point. Let us say you have a function like this, okay. Now assume that this is the point B and this is the point A, right? Now f of A is equal to f of B. The function value at A and B both are equal. Therefore you should be able to find out at least one value, isn't it? So here you have one value, and here you have one value, and also here you have one value. So at least one value is there. So what they are trying to say is, if a function is going to start at some value and again come back to that value, then what happens? Either it is going to remain stationary all the way, which means in that case it is going to be a straight line, or it is going to increase and then drop down, in which case the slope is going to be positive for some time and then negative for some time. Therefore definitely at the middle point the slope is going to be 0 at some point, isn't it? Or what is the other case? The value is going to decrease and then it is going to increase, right? So what do I mean? If f of a equal to f of b, then see, let us say these are the 2 points, this is a and this is b. Now they are saying that f of a equal to f of b. How can this happen? One way is your function is just a straight line. In this case, at all the points, whenever you draw the tangent, it will be definitely parallel to x-axis. What is the other case? The function is going to increase and then it is going to decrease. Then only, once the function increases, if it has to reach the same value, it has to decrease somewhere, right? And also they are saying that it is differentiable, which means there are no corner edges, right? Therefore, definitely if you are drawing the tangents, at least one tangent at some point is going to be parallel to x-axis. What is the other case? The function is going to be decreasing and then again it will increase to reach the same point. Even in this case also, if you try to draw the tangent at all the points, at least at one point you are going to get a point in such a way that it is parallel to x-axis, given that it is differentiable. If it is continuous and differentiable, only these three cases are going to happen, right? And sometimes what happens is you might get it multiple times, increase, decrease, increase, decrease, and finally reach that point. In that case, you are going to get more than one point at which tangent is going to be parallel to x-axis. Got it? Okay, that is about this theorem. Now let's see this theorem, Lagrange's mean value theorem. Let f of x be defined in the interval a comma b such that it satisfies two conditions. First condition is f of x is continuous in a comma b. Second condition is f of x is differentiable in the range a comma b. Then there exists at least one point c which belongs to a comma b such that f dash of c equal to f of b minus f of a divided by b minus a. So what they are trying to say is, if you have a function like this, let us say you have a function like this, okay, and now assume that we are talking about the range a comma b in such a way that, let us say this is a and maybe this is b, okay. So this is a and this is b. Now within this range, two conditions have to be satisfied. First condition is f of x is continuous, it should be continuous, and the second condition is f of x is differentiable in the range a comma b. So if you see this, it is definitely continuous between these 2 points as well as is differentiable. There are no holes, there are no jumps, that is why it is continuous, and there are no corner points or the vertex points, so therefore it is differentiable. Now they are saying that there should exist at least one point in such a way that f dash at that point, which means the slope of the tangent drawn at that one, is equal to f of b minus f of a divided by b minus a, which is nothing but, see, if you write this point, this line, what is this point? This point is b comma f of b, isn't it? Now what is this point? This point is a comma f of a. Now what will be the slope of this line? The slope of this line is going to be y2 minus y1 divided by x2 minus x1, isn't it? Therefore the slope of this line is f of b minus f of a divided by b minus a, right? And the slope of tangent at this point is f dash of c. Let us say this point is c, okay. Now what they are trying to say is, if you have any function defined like this, now there will definitely exist a point on the function in such a way that the tangent drawn at that point will be parallel to the line joining these 2 points, which means the slope of this line and the slope of this line both are equal. What is the slope of the tangent drawn at c? F dash of c. What is the slope of the line joining these 2 points? y2 minus y1 divided by x2 minus x1. So this is what they are saying, right? So now if you see the relationship between this one and the earlier Rolle's theorem, you can see that the Rolle's theorem is nothing but this one, in which Rolle's theorem has only discussed about one case where these two values are equal. What happens when these two values are equal? When these two values are equal, this line joining these two is nothing but the line parallel to x-axis. Therefore, in that theorem they were talking about the existence of a point which is parallel to x-axis, and in this theorem we are talking about existence of a point at which the tangent is parallel to the line joining these 2 points. Got it? Okay. Now let's see this theorem, Cauchy's mean value theorem. So let f of x and g of x be defined in the interval a comma b, closed interval, such that f of x and g of x are continuous in a comma b and f of x and g of x are differentiable in a comma b, right? So these two conditions are exactly same as if it is Lagrange's theorem, right? So in the Lagrange's mean value theorem, what we have seen is for one function they have given the same thing, which means if f of x is defined in a comma b such that f of x is continuous and f of x is differentiable, then what they have given is, if these two conditions are satisfied, then what they have given is f dash, there exists a point c in such a way that f dash of c is equal to f of b minus f of a divided by b minus a. This is what they have given, right? Now here it is a combination of two functions. Therefore, for the second function also, g of x, there should exist one more point, there should exist a point in such a way that g dash of c is going to be g of b minus g of a divided by b minus a, right? Okay, now they are saying that from these two equations you can write this, isn't it? So if you see that this is equation 1 and if you see that this is equation 2, from equation 1 and 2 you should be able to write this, right? So equation 1 divided by equation 2 equal to this. But only thing you should be careful here is, since g dash of c is given in the denominator, right? So you should see that g dash of x is not equal to 0 for any value there. That is why, just to rule out that condition, they have given this. Okay, so it is same as Lagrange's theorem, but where Lagrange's theorem is defined for one function, here it is defined for two functions. Got it? Okay. Let's see this question. The mean value c for the function e power x into sin x minus cos x in the interval pi by 4 comma 5 pi by 4 is. So they are saying that there is a function and this is the function they are saying, and now they want us to find out the mean value for the function, right? So now if you look at the range, it is pi by 4 and 5 pi by 4. Now which theorem you want to use, that depends on what are the values of the function at this point and at this point. If these two values are equal, we can use the Rolle's theorem easily, right? Let's try to find out these two values. Now f of pi by 4 equal to 0 and f of 5 pi by 4 equal to 0. So these two values are equal, therefore we can directly use Rolle's theorem, right? So what does Rolle's theorem say? Whenever these two values are equal, there exists a value c in this range in such a way that the slope of the tangent at that point is going to be 0. Now what is the slope of the tangent? We have to find out the first derivative of the function. Now if you find out the first derivative of the function, we get this value, right? Now this value should be equal to 0, right? This is the first derivative of the function, right? This value should be equal to 0 at that point. Now let us assume that the mean value is c. Now at the point c, which means if I substitute in place of x the value c, then we should get this one as 0. That is what we are trying to do. F dash of c is equal to 2 e power c into sin c equal to 0. Now if this entire term, if it has to be 0, definitely e power c cannot be 0 or 2 cannot be 0. So only thing is sin c has to be 0. Now when is sin c going to be 0? Only when c is going to be all this 0 or plus or minus pi or plus or minus 2 pi, so on. Now out of all these values, we are interested in only the values which fall in the range pi by 4 and 5 pi by 4. Now in this range, if you see, there is only pi. Out of all these values for which it is there, the only thing is it is pi. And one more thing is, whenever you are trying to apply this mean value theorems, you should also check that the function is continuous and differentiable within that range. In general, whenever they ask such questions, they generally give such functions, right? Also, if you look at the options, right, they are actually the mean value theorem might be applied there. Or if you don't understand and if you don't know whether it is continuous or not or differentiable or not, better use the methods that we have discussed in continuity and differentiability, right? So you can see that this function is going to be continuous and differentiable by using those methods. Okay, so after continuous and differentiable, then you use this mean value theorem. Most of the equations they are going to give you in such a way that it is continuous and differentiable, otherwise you cannot apply this mean value theorems anyway. Okay, fine. Now let's see this question. Find the mean value c for the function f of x equal to x into x plus 3 into e power minus x by 2 on the interval minus 3 comma 0 closed. So they are saying that we have to find out the mean value. That is what they are asking. Now how to find it out is, we should decide upon which mean value theorem we should apply. That depends upon what is the value for f of a and f of b. If this is a and if this is b, if you assume that way, then you find out what is f of a and f of b. Now if you find out f of a, it happens to be 0, and if you find out f of b, it happens to be 0. Therefore f of a is equal to f of b, and so you can apply Rolle's theorem, right? So according to the Rolle's theorem, if you have to apply it, you should write one thing. I mean, you should try to find out whether it is continuous and differentiable in this range, right? So let's talk about differentiability first. So because once it is differentiable, definitely it will be continuous. That is why I am talking about differentiable. So now if you find out f dash of x, then you are going to get that, this is the expression you got finally. F dash of x is this. Now if you look at this function, definitely for the range minus 3 to 0, there is no point for which it doesn't exist, right? So for all the points between minus 3 to 0, this value will exist. Therefore it is definitely differentiable in this range. So since it is differentiable in this range, it will definitely be continuous, right? See, for differentiability we need not check about closed interval minus 3 comma 0, but here we are checking about closed interval 3 comma 0 minus 3 comma 0 because we want to even apply the same method in order to say that it is continuous. Since it is differentiable in this range, it is definitely continuous in this range. Got it? Okay, come here. Now f is definitely continuous in minus 3 comma 0 and differentiable in minus 3 comma 0. Therefore we can apply Rolle's theorem. So hence by Rolle's theorem, there exists a point c such that f dash of c is going to be 0. So this is f dash of x. F dash of x I am equating it to 0. In place of x I am substituting c because that is what they have asked, right? So we got this. Now anyway this part cannot be 0, therefore only the part which can be 0 is this one, right? Now if you equate it to 0, c is going to be either 3 or minus 2. Now out of these two values, 3 and minus 2 lies in this range. See, even though we got two values, we should be concerned only about the value which falls in this interval, because that is the interval we are concerned about. Got it? So what can we say now? So the value of c according to Rolle's theorem is minus 2. So the mean value is minus 2. Got it? Okay. Now let's see this question. The mean value c for the function f of x equal to square root of x square minus 4 in the range 2 comma 4 is. So now we are supposed to find out the mean value. So how to find out is, first of all, before going ahead and finding out it, let's see whether we could apply any theorem here or not. In order to apply any theorem, the function has to be, one is continuous and other is differentiable, right? So if you find out about differentiability, let's try to find out f dash of x. F dash of x happens to be x by x square minus 4. Now where should it be differentiable? In the range 2 comma 4. For all the mean value theorems that we have seen, every theorem says that between the range wherever you are looking at, for the function wherever it is defined, 2 comma 4, even though it is closed, we have to look at it in the open interval. Open interval 2 comma 4, it should be differentiable. Now if you see this, the f dash of x will exist for all the values between 2 and 4, right? But then it is not exactly closed interval 2. Therefore you need not substitute the value 2. Only at the value 2 it is going to give us infinity. But anyway, we are not worried about the value 2 because in any theorem, if you look at it, they are going to talk about differentiability in the open range of a comma b, in the open interval a comma b, right? So for all the other points other than 2 which is not in this range anyway, it is differentiable. Got it? Which means f dash of x exists. And now one more condition you should check is, before applying these mean value theorems, you should look at continuity. If you look at this function, you can look at the continuity by looking at all the points between 2 and 4, right? So you have to see that it is continuous between 2 comma 4, which means it should be right continuous at 2 and it should be left continuous at 4 and between these two it should be continuous, right? Now you can check that from the continuity theory that we have seen earlier. You can check those two things, whether it is left continuous at 4 and right continuous at 2, and whether it is continuous or not in the middle values. You can find out that it is continuous, right? So it is differentiable and it is continuous. Okay, after that you can apply any theorem depending on what are the values of f of a and f of b. Now if you observe it, 2 is lower bound, which means it is a and it is b. You not to apply any theorem, right? Now you have to find out what is the value of f of a and what is the value of f of b, and after finding out these two values, if both are equal, you can apply Rolle's theorem. If both are not equal, you can apply Lagrange's theorem, right? Now if you see this, f of a and f of b, f of a is 0 and f of b is square root of 12. So both are not equal. So you can apply Lagrange's theorem. So what does Lagrange's theorem say? There exists a point C in such a way that f dash of C is equal to f of b minus f of a divided by b minus a, isn't it? There exists a point C in such a way that f dash of C is nothing but, in this f dash of x you are going to substitute C. Got it? So that is why C by square root of C square minus 4 is equal to f of a, f of b minus f of a divided by b minus a. F of b is equal to 12, f of a equal to 0, and b minus a is 2, right? So C by square root of C square minus 4 equal to root 3. So from that, if you solve it, you are going to get that the point C is root 6. Got it? Okay. Now let's see this example. Find the mean value C for the function f of x equal to Lx square plus mx plus n, such a way that L is not equal to 0 in a comma b. So they are asking us to find out what is the mean value for the function Lx square plus mx plus n in the interval a comma b. Now if you see this, it is a quadratic function. Generally quadratic functions will be both continuous and differentiable over any range. So since it is given as a comma b, definitely it is continuous and differentiable in that range. Okay, so since f of x is quadratic equation, it is continuous on a comma b and differentiable on a comma b, which means there should exist a point C such that f dash of C equal to f of b minus f of a divided by b minus a. Now what about f dash of x? F dash of x is going to be 2Lx plus m, right? So f dash of C is going to be 2Lc plus m, that equal to, now f of b minus f of a divided by b minus a. Now if you try to solve it, you are going to get that C is equal to b plus a by 2, and also b plus a by 2 will definitely lie in the range a comma b. Got it? Therefore C, the mean value for this one is a plus b by 2, which is going to definitely fall in this range. Okay, this question is asked in previous GATE. Now let's see this question. The mean value C for the functions f of x equal to sin x and g of x equal to cos x in closed interval minus pi by 2 comma 0 is. So they are talking about a closed interval minus pi comma 0, but then two functions are given. So whenever two functions are given, we should use the Cauchy theorem, right? So Cauchy mean value theorem says that first of all, the function has to be continuous and differentiable in that range. So definitely, since it is sin x and cos x, we know that they are continuous as well as they are differentiable over the entire range, and in minus pi by 2 comma 0 they will definitely be continuous and differentiable. And now since two functions are given, according to the Cauchy mean value theorem, there should exist a point C in such a way that f dash of C divided by g dash of C equal to f of b minus f of a divided by g of b minus g of a, right? Now what is f of 0? F of 0, see, I am talking about this is a. If you assume that this is a and this is b, according to the way we discussed the theorem, this is a and this is b, right? Then there exists a point C in such a way that f of b minus f of C divided by g of b minus g of a is equal to f dash of C divided by g dash of C. Now I am just substituting all the values there. Now what is f dash of C? If f of x equal to sin x, f dash is nothing but cos x. Now f dash of C is nothing but cos C. Similarly, if g of x equal to cos x, then g dash of x is going to be minus sin x and g dash of c is going to be minus sin c. Got it? Okay, that equal to f of b minus f of a divided by g of b minus g of a, and all these values we computed here anyway. So we are going to get that tan c equal to minus 1. So which means in the range minus pi by 2 to 0, what is the value for which we are going to, what is the value of c for which we are going to get tan c equal to minus 1? There is only one value, which is minus pi by 4. Therefore the mean value here in this case is going to be minus pi by 4. Got it? Okay. Now let's see this integration. The process of finding a function given its derivative is called as anti-differentiation or integration, which means integration is nothing but anti-differentiation. Let's see an example. So if capital F dash of x, which means if we take capital F of x and if we derive it first time, which means one time derivative, if that is equal to small f of x, then we say that capital F of x is an antiderivative of small f of x, right? Now if you apply integration on both sides, then what happens is, if you apply this integration here, integration of d by dx of f of x, it is going to be f of x, right? Now why do we add c is, see this, now if you derive it on both sides, here you are going to get small f of x and here you are going to get capital F dash of x, and d by dx of c is going to be 0, right? Therefore there has to be a constant whose value we don't know. In case of a definite integrals, we can find out this value also, but here you should always add the constant because we don't know its value. Okay, for example, if you take this, integral of x is going to be x square by 2 plus c, so always add the constant c. Now if you try to derive and apply the derivation on both sides, if you derive the left hand side and right hand side, if you apply d by dx here, it is going to be x. If you apply d by dx here, it is going to be x square is going to be 2x, 2 and 2 are going to get cancelled, therefore you are going to get x, and d by dx of c is going to be 0, so x and x. Got it? So that is why always add this constant c. Now coming here, we have some formulas written over here. So these are all the formulas for derivatives. Okay, so what you could do is note down these formulas. These formulas will be useful when you are trying to solve the questions. There is no other way, you have to remember these formulas. Okay, so these are all the formulas of derivatives and these are all the formulas of integrals. So you better note it down. When we are solving examples, I am going to use these formulas. Okay, fine. Now you can see these formulas. They are some of the formulas which will be useful in solving the questions. So this side is all about derivatives and this side is all about integrals. You can pause the video and write them down. Okay, now come this side. So here also we have some more formulas. There is no other way, you might have to remember all these formulas because there is no shortcut for this topic. Okay, so you can pause the video and again you can copy them down. This side we have derivatives and that side we have integrals. While solving the questions, we are going to use these formulas. Okay, fine. Let's see this question. Integral x power 6 dx. So it is in the form of integral x power n dx, which is nothing but x power n plus 1 by n plus 1, right? So you are going to add c as well. So it is x power 7 by 7 plus c. And the next one is, this is one example. Next example is integral x cube minus 1 by x square. So since it is not in the form of x power n, when you split it up, it will be in the form of x power n. That is why you just split it into two terms, x cube by x square and 1 by x square. So you are going to get x cube by x square means x, and 1 by x square is nothing but x power minus 2, right? So x and 1 by x square. 1 by x square can be written as x power minus 2. Now x can be written as x square by 2 plus c minus x power minus 2. It can also be written as x power n plus 1 by n plus 1, which means x power minus 2 plus 1 by minus 1, right? So there is already minus and we are going to get anyway minus, so it is going to be plus. So here you are going to add one constant and here you have to add one more constant. Let us say these two constants are c1 and c2 that we have added. Okay, let's assume we have added c1 here and here c1 and c2, right? And let us combine these two constants. Either you add or subtract, it doesn't matter. Either you write minus or plus, it doesn't matter. Anyway, they are constants, right? So now let's say c1 minus c2, or you can make it as plus as well. c1 plus c2, you can call it as c. Then you are going to get this one. Got it? Okay. Now let's see this question. integral cos 2x dx. So if you can directly remember the formula, you can do it. Otherwise, you know that sin x differentiation is cos x, and since there is 2x, you can try with sin 2x. See, if you can directly remember the formula, do it. Otherwise, you can guess it this way. So d by dx of sin x we know is cos x, but since we are talking about cos 2x, you take sin 2x and see what happens. Then you are going to get 2 cos 2x, right? So what do you understand from this? Cos 2x is equal to 1 by 2 into d by dx of sin 2x. Now you apply integration on both sides. Therefore, integral of cos 2x is going to be 1 by 2 into integral of d by dx of sin 2x, which is nothing but they both are going to get cancelled away because both are anti-property, isn't it? Therefore, integral and d by dx is going to get cancelled, and anyway you are going to add c there. So that you can do it that way. Otherwise, if you remember the formula, you can do it anyway. Okay. Come to the next example. Now, integral cosecant x into cosecant x plus cot x. So this can be written as integral cosecant square x plus cosecant x cot x dx, right? Now you integrate this one first, and then this, and then this one. We know that integral of cosecant square x is minus cot x, or d by dx of cot x is minus cosecant square x, right? Either you remember differentiation formula or integration formula, you can do it, right? D by dx of cot x is minus cosecant square x, or integral of cosecant square x is minus cot x, and d by dx of cosecant x is cosecant x cot x. So that way you can do it, right? And you have to add a constant there because it is integration. Got it? Okay. Now let's see some methods of integration. Sometimes we will be able to solve the questions easier if you are going to apply these methods. Even without using these methods also you will be able to solve the questions. But then if you can use these methods, some questions it will be very easy. Okay, and it requires practice to understand where to apply it and where not to apply it. Okay, let me explain you the method first. This method is called as integration by substitution. Now if you have integral f of x, it can be transformed into another form by changing independent variable x to t by substituting x equal to g of t. So what I mean by this is, whenever you have any variable x, you can change it into a function of t, right? By substituting in place of x a function of t, you can change the entire integral into some other variable. That is called as changing its form, right? Now for example, consider that there is an integral f of x dx. How to change it is, if you are going to substitute in place of x g of x, then what happens is, see, in place of x, if you are going to write g of x, then what happens to dx? You should also talk about this, right? So in place of x, if you are going to write gx, then dx by dt, differentiate both sides with with respect to t, then you are going to get dx by dt equal to g dash of t. From that you are going to get dx equal to g dash of t into dt, right? Now if you look at it, the entire expression or this entire integral can be transformed into only variables containing t. Okay, so integral is going to be integral f of x dx. Now it is going to be integral f of, in place of x you can write g of x, g of t, right? And in place of dt dx, or in place of dx you can write g dash of t dt, right? So this way you can transform any function into other function. Okay, let's see how this one will be useful in some of the questions. Come to this example. Let us take this example, integral tan x dx. Now we can write tan x as sin x by cos x dx, right? Now if you substitute in place of cos x t, then differentiate both sides with respect to differentiate both the sides. Okay, so if you differentiate this side and this side, you are going to get here as minus sin x dx equal to dt, right? Or you can differentiate both sides with respect to t, then also you will get the same. So how do you get it? Cos x is, if you differentiate with respect to t, it is going to be minus sin x into dx by dt, and this side you are going to get 1, and dt you can send it that side, right? That way you are going to get minus sin x dx equal to dt. Okay, fine. Now we know that cos x can be replaced with t, and sin x dx can be replaced with minus dt. Got it? Therefore in this integral, in place of sin x dx, you can write it as minus dt, right? And in place of cos x, you can write it as t. Therefore, integral tan x is nothing but integral minus dt by t. Now, it is nothing but integral 1 by t dt with minus in the beginning. This entire thing is nothing but integral t dt with minus in the beginning, right? Okay, integral 1 by t dt, right? Integral 1 by t dt with minus in the beginning. Now we know that if we take log t and differentiate it, we are going to get 1 by t, isn't it? So that way, this entire thing is going to be log t. Therefore, log t, and whenever you write t, it is better that you write mod t, okay, plus c. Got it? Now it is going to be minus mod cos x plus c, right? So since you have minus here, what you could do is you could take it this side, and minus log a is nothing but log a power minus 1. So that way you can convert this cos x into secant x. Got it? And don't forget to add c. See, whatever we did here is nothing but we are trying to substitute here. So you need not always follow this. In case if you know how to solve it, you can directly do it. If you don't know how to solve it directly, then maybe a substitution method will be useful. It is not that always substitution method should be used. With practice, you will understand where to use it and where not to use it. And one more thing is, if options are given, one good thing is take the option and you try to differentiate it, and you try to check the given function. In case if you get it, that is also a good thing, right? Which means you take this and you just differentiate it, and if you are going to get that, you can go with that. Okay, fine. Now let's see this question. Integral sine cube x into cos square x dx. So we are going to rewrite this function so that we can transform it. Even though it is given as sine cube x, I am going to write it as sine square x here and sin x dx at the end, right? So sin x dx, I am just going to pull it here. And now I am going to convert this sine square x into 1 minus cos square x. So 1 minus cos square x into cos square x into sin x dx. Now we can use substitution method here. Let us assume cos x equal to t. Then differentiate on both sides. Then you are going to get minus sin x dx equal to dt. Okay. Now you can replace this entire form, this entire sin x dx, with this sin x dx equal to minus dt, right? See, if minus sin x dx equal to dt, then sin x dx equal to minus dt. So here this entire thing can be written as minus dt, right? So this entire form can be written as integral sin square x into cos square x into sin x dx. This entire thing can be written as minus 1 minus t square into dt. How did we get this? See, this one is written as dt, okay, and this one is written as t square, and this one is written as 1 minus t square, right? So 1 minus t square into dt, but since it is minus sin x dx equal to dt, sin x dx will be equal to minus dt. That is why we are going to get minus here. Okay. Now you can expand it. 1 minus t square into dt can be written as t square minus t power 4 dt. Now this is x power n form, so which you can directly write it, right? So it is going to be t cube by 3. For this one it is going to be t cube by 3. For this one it is going to be t power 5 by 5, right? And since you are going to integrate them separately, you have to add two constants. So here you are going to add one constant, and here you are going to add one constant, right? Later you can merge these two constants into one single constant. Got it? So this is what you got. Now again, after transformation, just remember that we have introduced this variable t. Given function is in x, but we have introduced the variable t. So again, convert it back to x. How can you convert it? In place of t, you substitute cos x. Since cos x equal to t, in place of t you have to substitute cos x, right? So it is going to be cos power 5 divided by 5 minus cos cube divided by 3 plus c. Okay, cos power 5x by 5 minus cos cube 3x, okay, by 3 plus c. So why only one c? I am just combining these two constants. Okay, fine. Now let's see the next method by which you can solve some of the integration problems. It is called as integration by parts. Substitution method is over. Now it is integration by parts. So whenever you have a product of two functions and if you are going to integrate it, you can use this. Even though we have seen some formulas in the beginning which were actually product of two functions, you need not remember that formula. You can use this method and you can also derive the answer for them. Okay. Now see this method is used to integrate the product of two functions. If f of x and g of x be two integrable functions, then integral f of x into g of x is going to be, so f of x you leave it and integrate g of x with respect to x minus integral of f dash of x into integral g of x dx whole dx. Okay, so with examples I'll tell you how to solve it, and if you want to simplify the examples, one rule you can remember is whenever two functions are given, which function you want to choose as f of x and which function you want to choose as g of x. Depending on your choice, some questions can be solved easily. Okay, so you can remember this rule. Highlight. So for f of x, you always go in this priority, which means if there is any inverse trigonometric function, then you take it first. I means inverse trigonometric function. If f of x and g of x, if you have two functions and if one of the function happens to be inverse trigonometric function, then you assign it to f of x and the remaining one to g of x. That way if you solve it, it will be easy. If you don't have it, if you have logarithmic functions, then give it the next priority, and or if you have algebraic, then give it the third priority. Then you give the priority for trigonometric functions, then the exponentiation. Got it? Therefore, if you have any of these combinations, first one should be inverse trigonometric, then logarithmic, then algebraic, then trigonometric, then exponential. This is the order in which you should give priority to choose f of x. Okay, now let's see this one. Let's see this example. Integral x into e of x dx. Now again here you can see that we have product of two functions. Okay, one of them you can take it as f of x and other thing you can take it as g of x, right? So which one you want to take it as f of x and g of x is, you just use this rule, highlight, right? Now is there inverse trigonometric function? No. Is there logarithmic function? No. Is there algebraic function? Yes. So x is algebraic function, right? So you can take x as f of x. Okay, so now if you take x as f of x, in the previous formula if you substitute it, you are going to get this, right? So it is f of x into integral g of x dx minus f dash of x into integral g of x dx whole dx, and since d by dx of f of x is 1, which means f dash of x is 1, I am directly writing it as 1. Got it? Okay, and now if you observe it, so this is x into ex, and this entire thing is going to be, if you integrate it one time, it is going to be ex only. Again if you integrate one more time, you are going to get again ex only. Got it? So x into ex minus ex. So at the end you can add c. Okay, so don't add the constant in the middle, just put it at the end, that is enough. Okay, now let's see one more example. Look at this. Now in this case, again which one do you want to take as f of x and g of x is, you can use the rule highlight. Now if you use the rule highlight, inverse trigonometric you don't have, but logarithmic you have. Therefore you can take f of x as logarithmic function, which means log x is going to be f of x. Therefore f of x into integral g of x dx minus f dash of x. F dash of x means d by dx of log x, which is going to be 1 by x into integral g of x dx. Got it? Now what is 1 by x square? You can write it as x power n, which means x power minus 2. Then you are going to get minus 1 by x. Now what about 1 by x square? It is minus 1 by x, and you multiply it with minus 1 by x, it is going to be 1 by x square, right? So integral 1 by x square dx. Now it is going to be minus 1 by x. Got it? So at the end you can add c. Now you can pull out minus 1 by x as common, then you are going to get log x plus 1, right? Okay. Now let's see this question, integral x into cos x dx. So here which one should you pick up as f of x and which one should you pick up as g of x? So you can use this rule, highlight. Now there is no inverse trigonometric function, there is no logarithmic, but there is algebraic. Therefore you are going to take algebraic as f of x, which means this one is going to be f of x. Therefore f of x into integral g of x dx minus f dash of x. F dash of x here happens to be 1 into integral g of x dx whole dx. Okay. Now instead of this rule, if you would have chosen cos x as f of x, then what would have happened is, here see this, f of x into integral g of x dx minus f dash of x. F dash of x is going to be minus x sin x, and again integral g of x dx is going to be x square by 2. Now again if you see this, here itself again you might have to use UV form. Again in that UV form, again if you choose sin x as f of x, again it is going to be one more UV form, so it is never going to end. That is why sometimes using this rule you will be able to solve the questions, otherwise you might have to go in a lengthy process. Okay, fine. Now let's say you have chosen this way, and let's see the solution. Now x into, what is integral cos x dx? It is sin x. Why? D by dx of sin x is cos x, right? So again it is sin x. Now what is integral sin x? It is minus cos x. Why? D by dx of minus cos x is going to be sin x, right? And minus, so it is going to be plus. Got it? At the end just use constant. Okay, fine. Now let's see the next method of integration. It is called as integration by partial fractions. When we have the ratio of two polynomials in the form of p of x by q of x, where p of x comma q of x are polynomials in x and q of x is not equal to 0, we are going to apply this method. I'll take an example and explain you. Now assume that we have to find out 1 by x into x plus 1 dx. Now just try to make it into two parts, that is nothing but integration by partial fractions. Okay, so try to split it in such a way that integration will be easy. So how are we going to do it is, try to write 1 by x into x plus 1 as a by x plus b by x plus 1. Now you find out what could be that a and what could be that b, right? So just compare it. So if you cross multiply it, is going to be a into x plus 1 and b into x. Alright, so I'm just trying to merge them by taking the LCM, right? Now it is a into x plus 1 and b into x. Now this side is going to be 1, therefore 1 is going to be equal to a into x plus 1 plus b into x, right? From that if you solve it, a is going to be 1 and b is going to be minus 1. Therefore this entire function can be written as 1 by x minus 1 by x plus 1. So 1 by x minus 1 by x plus 1. So 1 by x, we know that integral 1 by x is log x, and integral 1 by x plus 1 is going to be log x plus 1. So whenever you have this 1 by x and this way, you have to apply, in case of log you have to apply mod. Just remember this rule. Whenever you are going to apply this, you are going to write this as integral 1 by x, you have to say log x, log mod x. Okay, and then you have to add a constant c there. Got it? So this is the way we are going to do it by partial fractions, which means if you have a fraction, we are going to split it into two fractions and solve it. Okay, now let's see this question. Find the integral of x square by x square plus 1 and plus x square plus 1 into x square plus 4 dx. So in order to solve it, let's try to put in place of x square as y, so that we can just split it. It is not substitution method. Instead of using x square, by writing y, it will be simple to visualize it. That's it. I'm not using any substitution method here. So if I just substitute y, the entire function is going to transform like this. Now I want to write it as if it is a sum of two functions. Okay, so for that reason I'm writing it as a by y plus 1 and a by y plus 4. So I have to find out what can be a and what can be b. So just cross multiply this, which means a into y plus 4 and b into y plus 1, and you compare it with y. Okay, so what does it mean? A into y plus 4 plus b into y plus 1 equal to y. Now from that you can find out, you will get two equations, right, in a and b. One equation is a plus b equal to 1, another equation is 4a plus b equal to 0, right? Now if you try to solve it, you are going to get a as minus 1 by 3 and b as 4 by 3. Therefore I can write this function as minus 1 by 3 into this and 4 by 3 into this. Instead of y, you can write it as x square. Okay, So say this minus 1 by 3 into x square plus 1 plus 4 by 3 into x square plus 3. Now when you apply integration for this, it is nothing but applying integration for these two independently. Now if I apply integration for this, it is going to be minus 1 by 3 into 1 by 1 plus x square, right? So we know that 1 by 1 plus x square is nothing but integral of 1 by 1 plus x square is tan inverse of x, right? And for this one, 1 by x square plus a square form, it is in the form of 1 by x square plus a square. It is 1 by a into tan inverse of x by a, right? Which means 1 by a into x square plus 2 square, right? Therefore in place of a there is 2. So what is the formula? 1 by a into tan inverse of x by a, right? So 4 by 3, it is going to remain as it is, and for this one we are going to get this entire, and for this one we are going to get this function, right? So what is it? Minus 1 by 3 into tan inverse x plus 4 by 3 into 1 by 2 into tan inverse of x by 2, and at the end just add the constant c. Okay, so you are going to get that function. Fine. Now let's look at definite integrals. So the theorem is, let f of x be continuous function in the interval a comma b, and capital F of x be the antiderivative of f of x, then integral a to b f of x dx can be written as f of b minus f of a, right? So with an example it will be clear. If it is given that you have to find out integral 0 to pi by 2 cos x dx, then find out the integration of cos x, which is nothing but sin x, and then the you have to write the interval as 0 to pi by 2, then you have to write it as sin pi by 2 minus sin 0, which means 1 minus 0, which is 1. So other way of looking at it is, you can also think of it as if it is the area under a curve, right? So if you look at cos x is going to be something like this, isn't it? So at 0 cos x value is going to be 1, right? At pi by 2 cos x value is going to be 0. Therefore when they are talking about integral 0 to pi by 2, which means from 0 to pi by 2, cos x means the area under the curve cos x from 0 to pi by 2. So this is what they are talking about, right? Now this area we found out is 1. Got it? Okay, there are some properties on this definite integrals which will be very useful while solving the gate questions. So see this. So in general, if you remember these properties, it will be very useful, and I'll show you when we go to the problems how to use these properties to solve the questions. Okay, so what you could do is just pause the video and note down these properties. We shall apply these properties while solving the questions. Okay, fine. Now these are some more properties which will be useful while solving the questions. So you can pause the video and I can write them down. So one thing is, if you look at this property 9 and property 10, it is looking a bit lengthy and maybe it might be confusing for you to understand from here. So what you can do is just write them down with examples. I'll explain every property. Okay, so whatever properties you have seen, we are going to solve examples on them, then you will understand how to apply them. Okay, so for now don't worry about this, just write them down. Okay, fine. Now let's solve this question. Integral 0 to pi by 2 tan x by tan x plus cot x dx. So I'm going to rewrite this cot x as tan pi by 2 minus x, and to that I'm just writing 0 there. Now if you look at this, it is in a form where we can apply one of the properties. So what is the property is, here if we have f of x divided by f of x plus f of x in f of a plus b minus x, right? So it is in the form of f of x by f of x plus f of a plus b minus x, then that can be written as b minus a by 2. So this is a property. So using that property I have simplified it, right? So you can refer to the properties. I think it is third property in the given list. So what is the property? F of x by f of x plus f of a plus b minus x can be written as b minus a by 2, which is going to be pi by 4. Alright. Okay, let's look at the next question. Integral 0 to pi mod cos x dx is given, right? So integral 0 to pi mod cos x dx is given. Now here we don't know what the value of mod cos x is. It can be positive or negative, right? So if you look at the behavior of the function from 0 to pi by 2 cos x, you can see that 0 to pi, isn't it? So 0 it is going to be here, and pi by 2 it is going to be here, and then at pi it is going to be here. So this is pi, so this is 0 and this is pi. Now if you look at 0 to pi, from 0 to pi by 2 cos x is positive, and from pi by 2 to pi cos x is negative, right? Therefore, using one of the properties, we can split it this way. Even though the integral is we are supposed to find out the integration from 0 to pi, you can break it from 0 to pi by 2 and from pi by 2 to pi. So 0 to pi by 2 mod cos x plus pi by 2 to pi mod cos x dx, right? Now 0 to pi by 2, anyway, since it is positive, so you can leave mod cos x as cos x only, right? Now from pi by 2 to pi, since it is negative, you have to multiply it with minus 1, right? That is why minus pi by 2 to pi cos x dx, right? And now what is the integration of cos x? Sin x. Why? D by dx of sin x is cos x. Therefore sin x, for this one we are going to get sin x, and for this one also we are going to get sin x, right? Now what are the limits? 0 to pi by 2, right? Between the interval 0 to pi by 2, and here from the interval pi by 2 to pi. Now how to solve it? It is sin pi by 2 minus sin 0, and in this case it is sin pi minus sin pi by 2, right? Therefore here you are going to get minus 1, and here you are going to get 1. 1 minus of minus 1 is going to get you 2, right? Anyway, we have already seen that this value is 1 in the previous example, right? 0 to pi by 2, and also this value will also be 1. Now they are asking about the mod cos x, which means what is the positive value, right? So it is going to be 1 plus 1, isn't it? In case if the mod is not given, then it would have been 0. Why? This is 1 and this is minus 1. Got it? Okay. Now let's see this integral 0 to n step x dx. Again, by using that one of the property, we can split the range. So interval. So even though the interval is given as 0 to n, you can split it as 0 to 1, 1 to 2, 2 to 3, so on. So why are we trying to split is, if you look at the step function, it is going to behave this way, right? If you say from 0 to 1, it is going to be 0 only, right? And from 1 to 2, right, its step function is going to be 1, which means here it is going to be 1, right? And from 2 to 3, the step function is going to be 2. Now this value is going to be 2, right? And from 3 to 4, the step function is going to be 3, right? Like this it is going to be there. Therefore, even though we are supposed to find out from 0 to n, I am going to split it as if it is from 0 to 1, and then from 1 to 2, and then from 2 to 3, 3 to 4, like that, because the function value is changing. That is why I am writing that way. Okay, so even though we have to find out step x, I am writing it as 0 to 1, its value is, step x value is going to be 0, and from 1 to 2, step x value is going to be 1, and 2 to 3, step x value is going to be 2, and similarly from n minus 1 to n, the step x value is going to be n minus 1, right? Now since these are constants, you can just bring them, we can just take them out of the integration. So which means leave 0 as it is. In this part you bring out 1, and integral dx is nothing but x. Now x with the interval 2 to 1 to 2. Therefore if you substitute it, it will be 2 minus 1. Getting this? Now here also you can bring out this constant, and it is integral dx, which will be x with the interval 2 to 3. Therefore you can write it as 3 minus 2, right? Plus so on, plus here you can pull out n minus 1. Yes, n minus 1 is pulled out, and integral x is nothing but, integral dx is nothing but x, and it is from n minus 1 to n. Therefore it is n minus 1, right? So if you see this, all these are going to be 1s only, right? And now what is the number remaining? These numbers 1, 2, so on, n minus 1, those numbers will be remaining. So 1 plus 2 plus so on plus n minus 1. So this is the sum of first n minus 1 natural numbers, so which can be written as n minus 1 into n minus 1 plus 1 divided by 2. It is going to be n into n minus 1 by 2. Got it? Okay. Now let's see this question. Integral 0 to 1 x into 1 minus x power 99 dx. So in order to solve this question, I am going to use the property, this one. If you have integral 0 to a f of x dx, now this can also be written as integral 0 to a f of a minus x dx. So this property can be used in order to solve that. So what is that I am trying to do is, whenever you have a, in place of x I am going to write a minus x, right? So in this case we have 0 to 1, so which means a is 1 in this case, right? Therefore I can write it as, in place of x I can substitute 1 minus x. Alright, so integral 0 to 1, 1 minus x into 1 minus x. So why am I doing this? So that I can get x power 99 instead of getting 1 minus x power 99. It will be a bit difficult to solve, so that is why I am writing this way. Now I am going to get x power 99 here, right? Now it is going to be 1 minus x and it is going to be x power 99 dx. Now you can simply multiply these terms. So what is it? So x power 99 minus x power 100, x power 99 minus x power 100 dx. Now what do you get from that? Integral x power 99 is going to be x power 100 by 100, and x power 100 is going to be x power 101 by 101. And what is the interval? From 0 to 1, right? Now we can directly substitute here 1. So it is going to be 1 by 100 minus 0 by 100. So I am not going to write it. And what about this? 1 by 101 minus 0 by 101. So it is going to be 1 by 100 minus 1 by 101. It is 1 by 10100. Got it? Okay. Now let's see this question. Integral 0 to pi by 2 log tan x dx. Now again I am going to use the same property that we have used in the earlier question. So what is it? Integral 0 to a f of x is equal to integral 0 to a f of a minus x. So if you assume that this entire integral, whatever is given is I am just writing it, let I equal to this one. Now I will also be equal to integral 0 to pi by 2 log of tan pi by 2 minus x, which means in place of x I am writing a minus x. Alright, so this is going to be cot x. So log cot x dx, right? So now if you observe it, these two are actually the same, representing the same integral, right? Now let me add these two. When we add these two, it is going to be 2 into I. So what is that we want? Actually we want the value of I, but then I got 2 into I, right? Now 2 into I is going to be integral 0 to pi by 2 log tan x dx plus integral 0 to pi by 2 log cot x dx. Since the integral is over the same interval, I can just take it as common, integral 0 to pi by 2 into log. Now it is log a plus log b. So log a plus log b can be written as log ab. So it can be written as log tan x into cot x dx. Now these two can be cancelled and it is going to be log 1. So what is log 1? 0, right? So this entire thing is going to be log 1, which means 0. So we got 0. So what does it mean? 2 into I happened to be 0, right? Then what does it mean? I equal to 0. So what is I? I is the actual integral given. So this entire value is going to be 0. Got it? Okay. Now let's see this question. Integral 0 to 1 log 1 plus x by log 1 plus x divided by 1 plus x square dx. So in order to solve this, you could directly solve it, but then if you go with substitution method, it will be easier. So let's see that method. So what we can do is, in place of x we can substitute tan x. So why am I trying to do this is, once I find out dx, then I am going to get a term there, and then 1 plus x square I am going to get a term. Both of them will get cancelled. That is why I am doing it. Okay, you'll understand why I am doing it here. See this? Now let x equal to tan x. If I use this, then what happens to dx? Dx is going to be secant square t dt. Okay. Now whenever you go with the substitution method in definite integrals, you should also see that you are going to change the interval of the integrals. Okay. So here the interval is from 0 to 1 for what? For x. Then what will be the interval for t? That one also you need to check, right? So if x is ranging from 0 to 1, if the interval for x is 0 to 1, then what will be the interval for t? So now see this. So whenever x equal to 0, what should be the value of t? If x equal to 0, t has to be 0, right? Therefore here we got as 0. And whenever x equal to 1, what should be the value of t? It should be pi by 4. Therefore 0 to pi by 4. So when x is from 0 to 1, then t will be from 0 to pi by 4. Got it? Okay. Now for this definite integral we are going to write 0 to pi by 4. Okay. And the other one is, I'm just going to substitute wherever we have x, I'm going to put tan x. So log 1 plus tan t. Okay, so wherever there was x, I'm going to write tan t, and here 1 plus tan t square, and wherever there was dt earlier, sorry, dx earlier, I'm going to write secant square t dt. Right, now the reason why we substituted is this one and this one will get cancelled. That is the reason. So 1 plus tan square t is nothing but secant square t, and here also we got secant square t. So these two factors will get cancelled away. Now what do we get? Integral 0 to pi by 4 log 1 plus tan t dt. Let's call it as I. Leave it there. And now we can use the other property. So what is the other property? Is integral 0 to a f of x can be replaced with integral 0 to a f of a minus x, right? So now I am going to use that property, and I am going to rewrite this I as integral 0 to pi by 4. Wherever there was x earlier, I am going to write it as pi by 4 minus x. So pi by 4 minus x. So in place of x we have t, that is why pi by 4 minus t. Got it? Now this one will also be equal to the earlier integral. That is why if you are calling this one as I, then this one will also be equal to I. Okay, now let's just expand this one. So tan a plus b is nothing but tan a minus tan b. Okay, this is tan pi by 4 minus t, right? So it is tan a minus b. So tan a minus tan b divided by tan a plus tan b. So that is the formula that we are going to use. So if you substitute there, tan pi by 4 is going to be 1 minus tan t divided by 1 plus tan t. Okay, just add these two and simplify this. You are going to get it as 2 by 1 plus tan t. Now I equal to 2 by 1 plus tan t we got, and here I equal to log 1 plus tan t we got, right? Now you just add 1 plus 2, which means this one, let's call this equation as 1 and let's call this equation as 2. Now I am going to add this one, right, with this one. Now both are having integral 0 to pi by 4 only, right? So this one is having log something and this one is having log something. Now whenever I have log a plus log b, I can write it as log ab, right? Now when I combine these two, I can write it as log ab. Why? It is integration from 0 to pi by 4 and it is also integration from 0 to pi by 4. So for both of them combinedly I can apply integration from 0 to pi by 4, and now log a into b. So a into b. Now these two will get cancelled away. Now you are going to get log 2 dt. Now we can pull out log 2. So s log 2 is out. Now integral 0 to pi by 4 dt, which is nothing but t. So now the t with limits 0 to pi by 4, right? So what do you get? Pi by 4 minus 0. So 2i. So whatever this value you got, that is equal to 2i. But what we wanted is I. Now 2i is equal to pi by 4 log 2. Therefore I will be equal to pi by 8 log 2. Got it? So this way you can solve this question easily, right? But anyway, in order to know that where to apply this substitution and where to apply the properties, you have to practice more questions. With practice you will be able to understand it. Right away you will not be able to understand that you have to do this substitution here and then follow this property. Then in such cases you go with the normal methods, whichever you know. But if you can do more practice and if you can understand that these methods will be better, then apply these methods. Okay, with practice this will be easy. Okay, now let's see this question. If I1 equal to integral 0 to pi f of cos square x dx and I2 equal to integral 0 to 3 pi f of cos square x dx, then which of the following is true? I1 equal to I2, I2 equal to 3 into I1, I2 equal to 3 into I1, none. So we are going to use the property, this one. So see this, look at this property. Now whenever you have to find out integral 0 to n a f of x dx. You can write it as if it is n into integral 0 to a f of x dx whenever f of x is equal to f of a plus x. Got it? So whenever the function is repeating itself, then you can use it. So in other way, I'm just taking this one, see this. Now if you have a function like this from here to here and also from here to here, let's say if the function is repeating itself like this, okay. Now if we have to find out, let us say this is 0, this is a, this is 2a and this is 3a, right? Whenever you want to find out the area under this curve from 0 to 3a, you could have broken it down as 3 into integral 0 to a when the function is repeating itself this way, right? Which means whatever value is here, if you add a and if you go there, it should be there. And whatever the value of the function is here, if you add a to it, which means here it should have the same value, right? And whatever the function is having here, it should have the same value here, which means for every difference of a, you should have the same thing. Then only you can use that, okay? Now if you observe this, you need to check this. Integral 0 to pi is given and integral 0 to 3 pi is given. Now can I write it as 3 into integral 0 to pi? That is the question. So when can you write it? You can write it only when f of x is equal to f of a plus x, right? Now what is f of x here? Cos square x. Now I want to find out whether it is equal to, I don't know, right? Whether it is equal to a plus x or not. So what is a here? It is pi, isn't it? 0 to pi is given. Therefore I need to check this. Cos square pi plus x. Now what do we know about pi, cos pi plus x? Cos pi plus x is minus cos x, but then square is given, therefore minus cos x whole square, which is cos square x. Yes, both are equal, right? Therefore definitely we can substitute it. So what is that? If it is from 0 to 3 pi, you could write it as 3 into 0 to pi, right? Which means I2 can be written as 3 into I1. So this is the answer. I2 can be written as 3 into I1. Got it? Okay. Now let's see this question. Integral minus 1 by 2 to plus 1 by 2 cos x into log 1 plus x by 1 minus x dx equal to. So in order to solve this one, we are going to use a property. The property is like this. Whenever you have integral minus a to a f of x dx, then it can be written as 2 into integral 0 to a f of x dx if f of x is even, or 0 if f of x is odd. So what do I mean by even and odd is, I'll just take an example and I show you. Let us say this is the function and the function is this way, okay, and assume that this is minus a and this is a and it is 0. Now if you try to integrate from minus a to a, here you are going to have positive value and here you are going to have negative value, and everything is going to get cancelled off, right? So which means you are going to get 0. Now in this case it is an odd function. So odd function means if you take any point, let's say some b here, and if you take, let's say this is the point b, or let's say this is the point minus b, this is on negative side, right? Now if you go to the plus b and if you see it, whatever value was here, it will be exactly minus of that. Alright, now if you look at an even function, so what is an even function is, if you have something like this, if I have something like this and again something like this, right? Now if you see this, from minus a to a, I am going to get, this one is also positive and this one is also positive. So whatever value was here, you are just adding it. Therefore it is 2 into integral 0 to a, right? Now if you observe it, if you take any point here, let us say minus b, and if you take any point here plus b, now if you find out the value of f of x, then f of minus b will be equal to f of plus b, which means this is nothing but a even function. Now here if you find out, f of minus b will be equal to minus of f of b, right? Which means whatever positive value you got, you are going to get negative of that, right? So that is how you can differentiate between even functions and odd functions. In case of even functions, we can say that the value is going to be 2 into integral 0 to a whatever this value is. In case of odd functions, it is going to be 0 because they are going to get cancelled away, right? Okay, now if you look at this, integral minus a to a f of x is equal to 2 when f of x is even, and it is 0 when f of x is odd. Now just try to find out whether this function is even or odd. Okay, so how to find it out? Find out f of minus x. If that happens to be f of x, then you can say that it is even. Find out f of minus x. If it happens to be minus f of x, then it is odd, right? Now let's try to find out f of x. F of x is going to be the same thing, whatever we have gone, we are taking this one entire thing as f of x. Now try to find out f of minus x. If you try to find out f of minus x, then in place of x you are substituting minus x. So in place of x minus x, in place of x minus x, right? That is why when it is 1 plus x by 1 minus x, here it has become 1 minus x by 1 plus x. Got it? Okay, now what is cos minus x? It is minus cos x, which means minus is going to come here. Now you can take that minus, right? You can take that minus to here. Okay, cos minus x, cos minus x is cos x only, right? Yeah, cos minus x is cos x only. Okay, oh fine. Now cos minus x is cos x only. Now 1 minus x by 1 plus x is there, so this one I could write it as like this, isn't it? 1 minus x by 1 plus x, I could write it this way. Then it is log a power n. I can get the n forward, right? So what do I get? I'll get this one here, which means minus 1 is going to be here. Now if you observe it, f of minus x is now equal to minus f of x. So what does it mean? It is an odd function. So whenever function is odd, which means the function is like this. Whenever the function is odd, we can say that the integral minus 1 by 2 to 1 by 2 is going to be 0. Got it? Okay. Now let's see this question. Integral 0 to pi x into sin x divided by 1 plus cos square x dx. So how to solve it is, we are going to use the property that if integral 0 to a x into f of x is equal to a by 2 into integral 0 to a f of x dx when f of a minus x is equal to f of x. So if you can see that this condition is satisfied, then this entire thing can be written like this. It can be simplified that way, right? Now if you observe this one, it is in the form of x into f of x dx, isn't it? So what is f of x? You can clearly see that f of x is this. This is clearly in the form of integral 0 to a, integral 0 to pi, x into some function of x, x into f of x dx. So exactly it is in that form, right? Now when can I write this entire thing like this? When you can check this one. What is it? F of a minus x equal to f of x. You have to check that one, right? Okay. Now f of x equal to this one. Now let's test what is f of a minus x. So in this case a is nothing but pi. So f of pi minus x, I am checking it. That is nothing but sine, wherever there was x, you are supposed to put pi minus x. So in place of x I am writing pi minus x and pi minus x. Now what is sine pi minus x? It is sine x. And what is cos pi minus x? It is cos x, right? Therefore it is going to be sine x by 1 plus cos square x. Got it? So if you observe it, f of a minus x, which means in this case pi minus x, happened to be f of x, which means this condition got satisfied. Therefore I can write this entire integral simply like this, right? Which means in this case we can write the entire integral, this entire integral as pi by 2 into integral 0 to pi f of x dx. So f of x is nothing but sin x by 1 plus cos square x. Okay, fine. Now in order to solve it, if you follow the substitution method, it will be even simpler. So what is substitution method is, let us say cos x equal to t. Then what happens to the limits? That is what you should be worried about. So when it is from integral 0 to pi, when the x is varying from 0 to pi, what does t vary from? So cos 0 is going to give you 1 and cos pi is going to give you minus 1. Therefore, when x is ranging from 0 to pi, then t will range from 1 to minus 1. Got it? Okay, that is what is range. Now if cos x equal to t, differentiate on both sides, then what do you get? Minus sin x dx equal to dt, which means sin x dx is equal to minus dt. So substitute in this entire function whatever we got here, right? So which means I am transforming whatever was in t, whatever was in x into t. So sin dx is going to become minus dt, and 1 plus cos square x is going to become 1 plus t square, right? And 0 to pi is going to become 1 to minus 1, and pi by 2 is going to be same as it is. Got it? Now this entire thing can be written as, so minus you can put it outside, 1 by 1 plus t square, and we know that integral 1 by 1 plus t square is tan inverse t. So it is tan inverse t. So minus pi by 2 into tan inverse t. Now it is from the interval 1 to minus 1. Therefore you have to write tan inverse of minus 1 minus tan inverse of 1. Now what is tan inverse of minus 1? It is minus pi by 4. What is tan inverse of 1? It is pi by 4. Therefore minus pi by 4 minus pi by 4, we are going to get it, which is nothing but minus 2 into pi by 4, which is pi by 2. Got it? So minus pi by 2 outside and minus pi by 2 inside. So when you multiply them, it is going to be pi square by 4. Okay, fine. Now let's see some problems on this property. I have written the property as well here. So integral 0 to pi by 2 sin power nx dx is equal to integral 0 to pi by 2 cos power nx dx. So that is equal to, you are going to write it this way, n minus 1, n minus 2, n minus 3, n minus 4, n minus 5, so on until either you reach 2 by 3 or 1 by 2, and then multiply the entire thing with k. Now where that k is going to be pi by 2 if n is even, or it is going to be 1 if n is odd. Okay, now how to solve this is, we shall see some examples, then you will understand how to use this one. Integral 0 to pi by 2 sin power 8x dx, this is what you want. So how are you going to do it? So n, here in this place n is 8, so 8 and then n minus 1, n minus 1, like that, n minus 1, n minus 2, n minus 3, like that. Okay, so 8, 7, 6, 5, 4, 3, and finally we are going to reach to 1 in this case, right? So when are you going to stop? Either you reach 1 by 2 or 2 by 3, then you are going to stop. Then what is that you are going to multiply it with? That depends on what this number is, right? In this case, since the number is 8, which means the number is even, so you multiply it with pi by 2. So multiplying with pi by 2, so you got 35 pi by 256. Now question number 2, integral 0 to pi by 2 sin power 5x dx. So this is what you want. Now again you are going to do the same thing, n minus 1, n minus 2, like this. So 5, 4 and 3, 2. So since you have reached 2 by 3, you can stop there. Either you reach 1 by 2 or you reach 2 by 3, you are going to stop. Okay, and then multiply it with what? That depends on this value. So since this value is odd, you have to multiply it with 1, right? So in this case you got 8 by 15. Now the next one is integral 0 to pi by 2 cos cube x dx. So again you can do the same thing, n minus 1, like that. But then if you see it, right away we got 2 by 3, so you have to stop it there and multiply with pi by 2 or 1, that depends on the value of n here. Now since it is odd, multiply it with 1, so you are going to get 2 by 3, right? And next one is integral 0 to pi by 2 cos power 6x dx. So how to solve it? Now again n minus 1, n minus 2, n minus 3, like that. So if you write like this, 6, 5, 4, 3 and 2, 1, which means we have reached 1 by 2 and we are going to stop there. Multiply with what number? That depends here. So since it is an even number, you are going to multiply with pi by 2. So here you got 15 pi by 96. Got it? Okay. Now let's see one more property. I'll show you the property first and then we can solve the questions on it. The property is integral 0 to pi by 2 sin power mx into cos power nx dx is equal to, so whenever you have any such combination, then you take m and you write m minus 1, m minus 3, so on until you go till 2 or 1, multiplied with, again you start with n minus 1, n minus 3, so on until you go till 2 or 1, which means you start with m minus 1 here and you successively decrement 2, and here you start with n minus 1 and you successively decrement 2, and in the denominator you find out m plus n and then you successively decrement 2 there. So start with m plus n and then m plus n minus 2, so on till 2 or 1. Okay, now finally you have to multiply with k, and that k is going to be pi by 2 when m comma n are even, and k is going to be 1 if it is not, in any other case, which means one is even, one is odd, or both are odd. In that case it is going to be 1. See, one more thing you should be careful about is, either in this example or in the previous example, always the power has to be a positive integer, which means we are never going to deal, or we cannot apply this formula whenever m or n is a negative integer. Got it? Okay, now let's look at some example. Integral 0 to pi by 2 sin power 8x into cos cube x dx. So how to solve it is, start with m, okay, and start with m minus 1 and you decrement 2 each, so which means m minus 1 decrement 2 decrement 2 decrement 2 until you reach 2 or 1, and again start with n minus 1 and you decrement, keep on decrementing 2. So if I start with n minus 1, it is going to be 2, so you are going to stop there. Got it? And in the denominator you are going to start with m plus n, which means 11, and you keep on decrementing 2, so 11, 9, 7, 5, 3, 1. Now what is the final one? You have to multiply with k. That value of k depends on what these two are, right? So in case if both are even, it is going to be pi by 2, otherwise it is going to be 1. Since both are not even, it is going to be 1. So the answer is 2 by 99. Got it? And now the next question is integral 0 to pi sin power 4 x into cos cube x dx. So there is a property that if it is odd function, right, it is going to be 0, otherwise if it is even function, it is going to be 2 into integral 0 to pi by 2. See, now what I wanted to see is whether I could express it in this form or not. That is what I wanted to check, which means I don't know, I could write it this way. What I want to check is if I could write it as if it is 2 into integral 0 to pi by 2 sin power 4x into cos cube x dx. Why am I trying to write it this way? Because I can apply that formula, right? But then before checking it, I should be sure that, see, whenever you are going to write like this, you should be sure that the function is even. So how to be sure? So you can use this, or you can write this only when f of pi minus x, which means this one, f of, if it is integral 0 to 2a, then it is f of 2a minus x should be equal to f of x. Then only you can write this way, right? Now if you try to find it out, f of pi minus x, in this case here you are going to get sin power 4 pi minus x, which is going to be sin power 4x only, and cos power 3 pi minus x, which is going to be minus cos x whole power 3, which means this entire thing is going to be minus x. So if you try to find out f of pi minus x for this one, you are going to get minus f of x, which means it is an odd function. So whenever it is an odd function, you cannot write like this, the answer is going to be 0. So for this one, the answer is going to be 0, right? Now let's see this one. Integral minus 2 pi to 2 pi sin power 4x into cos power 8x dx. So how to solve it is, find out whether it is even function or not. In case if it is even function, you could write it as 2 into integral 0 to 2 pi, right? See, I want to convert this one so that I could apply this formula. That is what I am trying to do here, right? So integral 2 into integral 0 to 2 pi, can I write it like that or not? That depends on whether it is even function or not. Now just find out whether it is even function or not. How to find it out? It is from minus 2 pi to 2 pi. See, if it is from 0 to pi, then you have to use this one, f of minus f of pi minus x equal to f of x or not. That is what you are going to check. But if it is from minus 2 pi to 2 pi, then you have to check f of minus x is equal to f of x or not. Then it is even, right? So now if you try to find out f of minus x, you are going to get sine power 4x only. Here you are going to get minus cos, but again since it is power 8, it is going to convert to plus, which means if you find out f of minus x here, you are going to get f of x only, which means it is an even function. Therefore you can write it as 2 into integral 0 to 2 pi f of x dx, right? So which is going to be, so I am not going to substitute f of x here, so you assume that f of x is the same thing. Now again if you see it, it is from 0 to 2 pi. I want to write it as if it is 2 into 0 to pi. So when can I do that? Again I need to check this one, right? Since it is from 0 to 2 pi, you have to check f of 2 pi minus x, which means here you have to place in place of x 2 pi minus x, 2 pi minus x, right? And then if you have to check whether it is f of x or not. In this case it happens to be f of x. If you find out f of 2 pi minus x, that will be equal to f of x, which means again it is an even function. Therefore you can write it as it is 2 into, which means already it is there, this entire function can be written as 2 into integral 0 to pi, this entire function, right? Now 2 into 2 will be there, which means 4 into integral 0 to pi f of x dx. Now I want to still write it as integral 0 to pi by 2. Why? Because I can apply this formula only for integral 0 to pi by 2. So can I write it as 2 into integral 0 to pi by 2 f of x dx, this entire integral? That is what I want to know, right? It turns out that you could write. The reason is, here if you find out f of pi minus x, that will be equal to f of x, which means it is a even function again, right? So find out f of pi minus x, it is going to be sine power 4 pi minus x into cos power 8 pi minus x. So you are going to get minus cos here, but still it is a power of 8, therefore you are going to get same function. So it is going to be 8 into integral 0 to pi by 2 f of x dx. Now finally we got it in a form we need. What is the form? 0 to pi by 2 sine power mx into cos power nx. Now it can easily be written as 8 into, so why 8? 8 is already there, 8 into, now you start from m minus 1, which means you start from 3 and you keep on decrementing 2. From 3, if you decrement 2, it is going to be 1. Now here also you start from n minus 1 and you keep on decrementing 2. If I start from n minus 1, it is going to be 7, and if I keep on decrementing 2, it is going to be 7, 5, 3, 1. Got it? And in the denominator you start with m plus n, which means you add these two, it is going to be 12, and then from there you keep on decrementing 2. Got it? Till you reach 2 or 1. So here you got 2, and then you have to multiply with either pi by 2 or 1 depending on what these numbers are. In this case both the numbers are actually even, therefore you are going to multiply with pi by 2. So the answer is going to be 7 pi by 256, final answer. Okay, fine. Now let's see this question. This is given in GATE 2009. Integral 0 to pi by 4 1 minus tan x divided by 1 plus tan x dx. So convert tan x into sin x and cos x. So in place of tan x I can write it as sin x by cos x. Here also sin x by cos x. Then what do I get? Cos x minus sin x divided by cos x plus sin x. Right? Now we can use substitution method, where if you assume t is equal to sin x plus cos x plus sin x, then dt is going to be minus sin x plus cos x dx. Okay? Therefore you can write this entire function as, see, this entire integral can be written like this. Okay, in this we are going to substitute. So what are you going to substitute is, in place of sin x cos x minus sin x dx, in this entire expression, it could be replaced with dt simply, and then sin x plus cos x can be replaced with t. Only thing remaining will be what to replace this pi by 4 with and what to replace this 0 with. Now for that reason you take this 0 and substitute here. As the limits or the interval for x is from 0 to pi by 4, you can find out the interval for t. So for that reason you substitute 0 here. You are going to get cos 0 plus sin 0, which means 1, and when you substitute pi by 4 and pi by 4 here, you are going to get 1 by root 2 plus 1 by root 2, which means 2 into root 2, which means root 2. Therefore it is from 1 to root 2. You are going to get 1 here and root 2 here. So wherever it was 0, you are going to get 1, and wherever it was pi by 4, you are going to get root 2, which means interval for x is from 0 to pi by 4, and the interval for t is from 1 to root 2, right? And here you are going to substitute t, and this entire thing is going to be dt, so dt by t. Now what is this? It is going to be log mod t. 1 by x, integral 1 by x is going to be log mod t, right? So it is going to be the interval is from 1 to root 2, right? Now you substitute root 2 here and 1 here. Log root 2 minus log 1, log root 2 minus log 1. We know that log 1 is 0, so you can eliminate it. Now you are going to get log root 2. So log root 2 can be written as log 2 power 1 by 2, which can be written as 1 by 2 into log 2. Got it? Okay. Now let's try to solve the same question in a different method. So if you see this, I could write 1 as tan pi by 4. So I am going to write this 1 as tan pi by 4 and this one as tan pi by 4. Now you can see that it is in the form of tan A minus tan B divided by tan A plus tan B. So which can be written as tan A minus B. So this entire thing, so this entire function or that entire expression 1 minus tan x by 1 plus tan x can be written as tan pi by 4 minus x. Okay. Now this entire integral can be now transformed to integral 0 to pi by 4 tan pi by 4 minus x dx. Now if you remember it, we have a property that integral 0 to a f of x can be written as integral 0 to a f of a minus x, right? Therefore here I can substitute in place of this entire thing pi by 4 minus this. So integral 0 to pi by 4. So in place of this entire thing, I can write it as pi by 4 minus x. So it is going to be pi by 4 minus pi by 4 minus x. So if you are going to strike off this, it is going to be tan x. So integral 0 to pi by 4 tan x dx. Now we know that integral tan x is going to be log secant x. So you are going to put anyway mod there, right? So why? If you try to apply d by dx of log secant x, it is going to be 1 by secant x into secant x tan x. Therefore it is going to be tan x, right? So that is why integral of tan x is going to be log secant x. So here you are going to put mod. Now the limits are from 0 to pi by 4, right? So you are going to substitute in place of secant x pi by 4. Now if you say secant pi by 4, it is going to be root 2, right? Minus secant 0. So secant 0 is 1 minus log 1, right? So log root 2 minus log 1. You are going to get this like in the previous method also you got the same thing in the end, right? So it is going to be 1 by 2 into log 2. Alright? Okay. Now let's see this question. This is given in GATE 2014. Integral 0 to pi x square into cos x dx. So in order to solve it, you can apply that UV rule, right? So which means it is in the form of a product of two functions, this one f of x and g of x. So in that case, I told you that it is better you take f of x in the form of islet, right? Sorry. So if you have inverse trigonometric functions, then you are going to give first priority for this one to be taken as f of x. But you don't have any inverse trigonometric functions and you don't have any logarithmic, but you have arithmetic function. Therefore f of x is going to be arithmetic in this case, right? So which means f of x is going to be this one, right? So now f of x into integral g of x. So what is integral cos x? It is going to be sin x. Therefore integral, if you apply it, so it is going to be sin x. For that the interval is from 0 to pi, minus integral of f dash of x. So what is f dash of x? 2x into integral cos x dx. So integral cos x is going to be sin x. Anyway for this one as well as for this one, the limit is going to be 0 to pi. So limit is going to be from 0 to pi. So anyway here there you have to one more time integrate it. That is why I am not writing it there. Got it? Okay. Now if you observe it, here we get x square minus sin x with pi and 0. If you substitute sin pi, it is going to be 0, and sin 0 is also going to be 0. So 0 minus 0 is again going to be 0. So that 0 into x square is entirely going to be 0. So this factor is going to be eliminated. Now whatever you have is, you can pull out this minus 2 outside, then you have x into sin x there. So whenever you have x into sin x, again you can apply UV method, that f of x into g of x method, or if you remember that, if you have one formula where if you have integral 0 to a x into f of x dx, this one, integral 0 to a x into f of x dx, this could be written as a by 2 into integral 0 to a f of x dx when f of a minus x is equal to f of x. So in this case, in place of a you have pi. Now let's test that. So f of a minus x, if it is equal to f of x or not. So what is f of x here? Sin x. Now f of pi minus x is equal to sin x. Therefore f of a minus x happens to be f of x. So you can apply this formula, right? So what does that formula say? You can remove this x and you can write pi by 2 outside. Therefore 2 is already outside. Now I can remove this x and I can put pi by 2, and I can write integral 0 to pi sin f of x dx. In this case f of x is sin x. Got it? Okay, now 2 and 2 will get cancelled away. So what is remaining? Integral 0 to pi sin x dx. Now integral sin x is nothing but minus cos x. So we have minus pi into minus cos x, and the interval is from 0 to pi. Got it? So these two will get cancelled away. Now cos pi minus cos 0. So cos pi is going to be minus 1, minus cos 0 is also going to be minus 1, right? So minus 1 is going to give me, so in case if you write like this, it is going to be like this, minus cos pi minus cos 0, right? So minus 1, it is going to be minus 2 pi. Got it? Okay. This question is given in GATE 2011. So let's say this, integral 0 to pi by 2 cos x plus I sin x divided by cos x minus I sin x dx. Given I equal to square root of minus 1, which means it is imaginary number. What will be the evaluation of the integral? So now they have given this function, which is cos x plus I sin x divided by cos x minus I sin x. So instead of working them with this, we have a formula that e power I theta is equal to cos theta plus I sin theta. So this is the formula which we already have. Now from that formula, if you see this, I can write it as e power ix, okay, e power ix, and this one I can write it as e power minus ix. So e power minus ix. So I am directly writing it in that way. Now I can take it to the numerator and I can write it as e power 2ix. So integral 0 to pi by 2 e power 2ix dx, right? So now it is in the form of e power some a into x, which is nothing but, if you try to integrate it, e power ax divided by a. So in that case you are going to get 1 by 2i into e power 2ix, right? So it is going to be I think here, right? So 1 by 2i into e power 2ix. So what are the under the interval 0 to pi by 2? So you are going to substitute in place of x pi by 2 here and minus 0. So e power 2i into pi by 2 minus e power 2i into 0. So this entire thing is going to be 1, and this entire thing you have to expand it out. So it is I pi. So what will be I pi? So from that one, if e power I theta is cos theta plus I sin theta, then e power I pi will be equal to cos pi plus I sin pi. Cos pi plus I sin pi. E power I pi is going to be cos pi plus I sin pi minus 1. And we know that cos pi, okay, here, so cos pi is equal to minus 1, and then sin pi is equal to 0. Therefore this entire thing is going to be 0, and it is minus 1 which is minus 2. So 1 by 2i into minus 2 which is going to be minus 1 by I. So minus 1 by I can be written as I square by I, which means this entire thing can be written as I. Got it? So minus 1 can be written as I square. So I square by I, so this is I. So the answer for this question is I. Okay, fine. This question is given in GATE 2015. Let's try to solve it. Integral 1 by pi to 2 by pi cos 1 by x divided by x square dx. Now we can use substitution method. So you can let 1 by x is equal to t. Then what do we get if we differentiate on both sides is minus 1 by x square into dx is equal to dt, right? So if you observe it, this entire function can be transformed like this. So dx by x square, so dx by x square is equal to minus dt. So in place of these two I can write minus dt, and in place of 1 by x I can write t. Therefore cos t into minus dt, and only thing remaining is what is the interval going to be, right? So in order to find out this interval, you substitute in place of x 1 by pi. If you substitute in place of x 1 by pi, then t is going to be pi. So you got pi here, and in place of x if you substitute 2 by pi, then t is going to be pi by 2. So integral pi to pi by 2 cos t into minus dt. So now we know that integral a to b, see this is the property, integral a to b f of x dx is equal to minus integral b to a f of x dx, which means if I reverse this this interval, then I have to apply negative sign. So already we have minus here, right? So assume that minus comes out, and again you are going to multiply with minus 1, therefore it is going to be positive. So if you try to reverse it, it is going to be pi by t to pi cos t dt, right? Now if you apply integration to cos t, it is going to be sin t. Why? D by dx of sin t is going to be cos t, right? So it is going to be sin t, then from pi by t to pi. So it is sin pi minus sin pi by 2. So what is sin pi? 0, minus sin pi by 2 is 1. Therefore you are going to get minus 1. Got it? Okay.